Hello, my friends, and welcome to the complete Kotlin developer course. In this video, we are going to make an overview what we are going to learn through the course. So, first, we will start by the basics of Kotlin, how to set up the Kotlin development environment. We will learn about expressions, variables, constants, and control flow. Next, we are going to move to the functions. So we will learn about functions and nullability. Next steps, we are going to the collections and lambdas. So we will learn about the arrays and the list, the map and the set, and we'll learn about lambdas. Also, we will go to the advanced topic about OOP, object-oriented programming. We'll learn about the classes, objects, properties, methods, and enum. Later, we are going to learn about the generics and the interfaces. And we will move to the exceptions, how to handle the error and how to prevent exceptions and how to make exceptions also. We will learn about the functional programming. So we will learn about conventions and the operator overloading. Moreover, we will move to the coroutines. We'll learn about the Kotlin coroutines and these special cases and the scripting with Kotlin. And we will move later on into the databases. So we'll learn about the Firebase connection and integration, learn about room, database, and preferences. Last, we will learn about real projects. So we will build real applications. Till now, we have finished the course about the e-commerce shop application and food recipe application and maps and tracking system application and much more. We are making also more and more apps, real projects in Kotlin. So we will use coroutine, we will use databases, Firebase, OOP, functional programming, exception, and all these concepts inside these applications. So till now, we have these apps and we are going to move and make new videos and new applications through the course. Like no other course over internet, we have carefully created this course to maintain and to cover all the details that we will see in the Kotlin. So with lectures and new details and with real examples like this app, we will make and ensure that you understand every concept and make real apps and publish them on Play Store. Hello, my friends, and welcome to the complete Kotlin developer course. Kotlin is a programming language introduced by JetBrains in 2011, the official designer of the most intelligent Java IDE, named IntelliJ IDEA. So we have worked with the IDE, IntelliJ IDE, in the Java developer course. This is a strongly statically typed general-purpose programming language that runs on JVM, Java Virtual Machine. In 2017, Google announced Kotlin is an official language for Android development. Why Kotlin? Why I should learn Kotlin? Kotlin is an open source programming language that combines object-oriented programming and functional features into a unique platform. So Kotlin is getting high popularity among all levels of programmers, and it is used for cross-platform mobile application that we are going to use later on, like as in Android Studio, Android application development, also the cross-platform, which is also to be used in iOS, and the cross-platform for the desktops and other things, the web application development, server-side application, desktop application development, and data science-based applications. It is widely used. Coding IDE. The primary tool that you will see in this course is to create Kotlin projects in IntelliJ IDEA from JetBrains. Okay, so IDE stands for Integrated Development Environment, or IDE, and is similar to other IDEs such as Visual Studio and Xcode, if you have worked with one of these. Just a comparison and just an overview how IDE write the code and work with the code. You use an IDE to write code in an editor compiler. In an editor, compile the code into a form that can be run on your computer, see output from your program, fix issues in the code, and much more. This is the job of the compiler and IDE. Source code, a file containing your programming code. The compiler, source code goes through the compiler. Output, compiled code with the class extension file name, and the virtual machine and electronic gadget execute byte codes. Okay, so this is a quick understanding for Kotlin and its history. Now let's go and install IntelliJ. The first step to install the IntelliJ IDEA, go to jetbrains.com/IDEA. Okay. And this is the most powerful Java and Kotlin and also Android IDE in integrated development environment. So these are the specifications, and you can scroll down and see what are the features. Okay, we scroll down and there are two versions of IntelliJ. The IntelliJ IDEA Ultimate and the Community Edition. You see that these are included in both of the versions, but these are not included in the community version. It is included only inside the Ultimate. Ultimate you should pay, and it is limited, but for our version, for our course also, you are going to use Java, Kotlin, Groovy, Scala, Android, Maven, Git, Git Debugger, Docker, and we click on download for the community section and edition. Okay, so after downloading, we will start download. So after completing the steps of installing IntelliJ, and follow the installation instruction on the IntelliJ side. Please don't run the IntelliJ IDEA. So this is the IntelliJ IDEA, and you don't run it for the first time, because we are going to install something called JDK. So Kotlin allows you to program to several different platforms. The two most prominent platforms are Java Virtual Machine, or JVM, and Android. And instead of compiling to native Java and machine code on each platform, Java programs are compiled into a format called bytecode. And this is called and achieved by the virtual machine, and the virtual machine is included in the JDK. So the easiest way to get the JDK from the platform is to visit the Oracle site and /technologies/Java SE downloads, or you can put simply on Google download JDK. Okay, you get this and click on JDK download. Okay, you wait till appearing the download page, and you select your operating system specific package. Okay, I will install this because it is x64. I have reviewed, and download JDK. Okay, it's about 150 megabytes. Click start and go the installation process of JDK. And after finishing installing JDK, you will run the IntelliJ IDEA and you will get this screen. So our main purpose is to create a hello world So once you have installed IntelliJ IDEA and the JDK, follow the normal process of starting the IntelliJ by clicking on it and go ahead and choose Create New Project, and a new screen will be appearing here. One thing that you need to specify is a project SDK. You can put, if you have the latest version of Java, please always select the latest version of the Java. And since we have installed the Java JDK, so you can specify the program files java/jdk. You just ensure that you have the latest version of JDK and install and select the path that your JDK have been installed. For now, I am not going to create Java. I'm going to create Kotlin. So here we go. We have many types of Kotlin files that we can create. And we can start by JVM ID. Okay, so create next, click next. The project name, you need to specify the project name. Hello Kotlin. I will create the name, and here is the project location. I will put it on the desktop. The project SDK, as I told you, if you don't download and if you had not downloaded the JDK, please click on download JDK and it will parse the latest JDK. Okay, it's very simple, or you can specify the JDK from here. Okay, use library and click on finish. Okay, it's very simple, and here we go. It's configuring Kotlin, and wait for the progress to be installed. Okay, and here it is a configuration notice, and if we click on the file, it is similar to that we have seen in the Java course. So if you want to learn more about IntelliJ, please go back to our course, Java course, or you can follow us here for the basic Kotlin and basic IntelliJ structures. For the first thing, we have the project panel. This is the project panel. I can select the project packages, scratches, open file, but we will always use package of the project. And we see here the hierarchy of the files, the external libraries, but we are going to mainly work with src folder. It is in blue. Okay, this is the project panel. You can click on this and you can hide it and show it. This is the toolbar that we are going also to be used and to run, debug, and get the configuration. And here is the editor. This is the editor. Okay. I will create the first Kotlin program by creating the file. I will name it as hello. Click. Okay. And you see, guys, it is .kt, which is .kotlin. Okay. Always update the plugins to the latest version. After this video, I will update them. But till now, I have this file called hello.kt.kotlin, and I need to create. Don't be frustrated. Just follow me, and you will be professional in Kotlin. So arrays of string. We are going to go deep in every single thing and every single notice and concept in Kotlin. Don't worry. Hello, master coding family. Okay, you see, guys, we have created this function inside the hello.kt file. And there is a green flash and that it is indicating triangle. Run hello kt. I click run, and you see the console will be appeared here, telling us hello master coding family. So this, congratulations, you have make it. You've now created your first Kotlin project and you run your first Kotlin project. Kotlin, like most other programming languages, allows you to document your code using what are called comments. These allow you to write any text directly alongside your code, which is ignored by the compiler. So the first way to write the comment is like so. Inside this, I can write here, hello. This is the first comment. So if I click run, this line will not be executed. It is just a comment. So you see, guys, this is the hello master coding family. This is the line. Only one line it will be executed and not this line. So this is the first way to write a comment. Also, the second way is a better way to write comment which span multiple lines. We can put a forward slash and put asterisk, put like this, and you can go hello, hi, what's up, and much more. So in this way, we are creating the comments for the multiple usage. Okay. Kotlin also allows you to nest comments. This will be not useful, but this way we have learned how to create the comments and how to make the comments inside the Kotlin file. At its simplest, computer programming is all about manipulating data. Remember, everything you see on your screen can be reduced to numbers that you send to the CPU. Sometimes you yourself represent and work with the data as various types of numbers, but other times the data comes in more complex forms such as text, images, and collection. In your Kotlin code, you can give each piece of data a name you can use to refer it later. The name carries with its an associated type that denotes what sort of data the name refers to, such as text, number, or data. So you will learn more about some of the basic types in this lesson, and you will encounter many other types throughout the rest of the course. So let's start by constants. Look at this code. We will start by val number int equal to 10. Okay, we don't use semicolon, just put like this. So this uses the val keyword to declare a constant called number, which is one of the type integer. Then it sets the value of the constant to the number 10. Thinking back to operators, here's another one. Equal sign is an operator sign that we are going to take in the next videos. But till now, just learn how to create a constant variable. We start by val number int, and 2 points. We specify the type of this value, a variable, and equal, and we give it a value. The type int can store integers. So int is for stores integers. Okay, the way you store decimal numbers is like this. So val pi double equal to 3.14159. Okay, so double stores decimals. You see, I'm using comments here, guys, in order to allow you understand better code, and you write your own notes for understanding the code. Okay, this is similar to the int constant, except the name and the type are different. This time the constant is double and the type can store decimal with high precision. There are also a type called float, so I can create float here. Val k float equal to 6 point this number. We have an error and we need to specify f. So when using a float, we need to specify and tell the compiler that this variable is a float type by specifying f letter at the end. What does float and double differentiate? That stores short for floating numbers. This float short for floating point. The stored decimal with lower precision than double. So always use double for higher precision, and float for small small numbers. Double, you can put many numbers here, but float small pieces of numbers after the decimal point. So in fact, double has about double the precision of float, which is why it's called double in the first place. So double decision of the float point. A float takes up less memory than double, but generally memory use for numbers is not a huge issue, and you will see double used in the most places. Even though we call an item created with val a constant, it's more correct to say the identifier marked with val is what a constant. Once you have declared a constant, you cannot change its data. For example, consider the code number int equal to 10. I can't put here that number equal to now to 10 to 50 to 11. I can't put like this. It give me an error. What this error? Change to var. It's telling me to change the val to var. So val is values for the constants, and var is a variable. Okay, so once val is declared, I can't make a change for it. So because this is called constant. So constants are useful for values that are not going to change. For example, if you were modeling an airplane and need to keep track of the total number of seats available, you could use a constant. Or if you have a constant in mathematics like pi 3.14159, you can use a value of constant and create as pi. So in certain situation, for example, at the top level of your code, outside of any functions, you can add the constant keyword to val to mark it as compile time constant. So I can put here const. Okay, at the top level of any method. We need to specify it outside any method. But till now, we will later on we will talk about constant and the non-access modifiers in the OOP section. But till now, you understand the variable, the values, the constant of and the constant data type in Kotlin, and we are ready to go through the variables in the next lesson. Thank you, guys. Hello, my friends, and welcome to the complete Kotlin developer course. We have learned in the previous video how to create constants inside Kotlin. But often you want to change the data behind a name. So for example, if you were keeping track of your bank account balance with deposits and withdrawals, you might use a variable rather than a constant. If your program's data never changed, then it would be a rather boring program. But as you have seen, it's not possible to change the data behind a constant. When you know you will need to change some data, you should use a variable, not val. So variable, not use it when data changes. Don't use val. Just you create var. So these are the variables. And throughout the course, I will comment everything in order to ensure that you understand everything by comments. And you check the source code by downloading it from the description in the resources folder. And this documentation, all of this documentation can found at master coding app on Play Store. So don't miss to download it to get all documents. Okay. Now variable. Let me remove this and put it outside. And the variable we have var. We start by var. It is indicating a variable. So we put the variable name or the variable number that I am going to put, the type of it equal to 99. Okay, I have created a variable called variable number. I put it of type integer and specify the value. It is equal to 99. Only the first part of the statement is different. You declare constants using val, whereas that you declare variables using var. Once you have declared a variable, you are free to change it to whatever you wish, as long as the type remains the same. So for example, to change the variable declared above, you could do this. Variable name, variable number equal to 100. I can change it and can do it exactly. But I can't use variable number equal to hello. You see, guys, there is an error. Let's see. Hover your mouse to see the error. Type mismatch, required int, found string. So it's telling us that it should be an integer of type integer. So I can change it again to 55. This is the meaning of using variables, and this is the power of using the variables. Now, let me show you one trick. Always try to choose meaningful names for your variables and constants to ensure that you memorize them when creating a big softwares. Good names can act as documentation and make your code easy to read. A good name specifically describes the role of variable or constant. Here are some examples of good names. Okay, so I can create person age var. It will indicate for every person, for every coder, that this variable will give us a person age. It's very simple. Or you can create a number of students. This will indicate for us the number of students as a variable. Okay? Or the mark or grades for student. Okay, these are the good naming of and meaningful names. Or you can create v1, but v1 it may refers for the age of the person. But how you will remember that? I advise you to put the age of person, or person start always with small letter, person age, and you put the other word with the capital letter. This is the Pascal writings. Okay, this is very good example about creating the variables. You can create also variable of type string, of type string. I will call name person of type string equal to John. You see, guys, the first part is just as the constant is changed from var to val, and the second part is the same as before. Okay, so I can also create value of constant j. You see, j, it will not indicate anything for me or for any coder later on. It's just saying hello, and it is constant. While in the variable form, we just defer it by var. And also I can change the name of person from variable from John to anything I need to change it later on. Also, I can create a variable of type float, boiling point of type float equal to 3.45, and don't miss the f. Okay, it's the same as constant, but it differ in from val to var. Okay, thank you guys, see you in next videos. What's up, guys, and welcome again to the complete Kotlin developer course. In this video we are going to talk about the type conversion. So sometimes you will have data in one format and need to convert it to another. So the naive way to attempt this, it would be like so. So var x of type int equal to 7, and I will create a new variable called y of type double equal to 3.14. Okay, now x equal to y, this will give you an error because type mismatch, required int and found double. I am assigning x equal to y, and y is double and x is int, so I'm putting a double inside int. This will give an error. Okay, if I put y equal to x, this will not give an error because double is I'm putting a double here, and inside this double box I am putting an integer. An integer is smaller than double and it is contained in double, so in this case it will be accepted. Okay, so instead of simply assigning, you need to explicitly say that you want to convert the type. You would do like this. Integer, when you need to convert the type, converting the type. Integer, you use this formula. Integer equal decimal dot to int method. Okay, we will learn about method later on, but till now, if you need to make a casting, you need to like type conversion, it would be sometimes it is useful to check the inferred type of the variable of a constant, so and convert it. So we will create x, which is an integer, equal y dot to int. So we use this method. Okay, I will comment this. Let's run and see. I will print it out, x, print x. And here we go, guys. We have eliminated the decimal part from the double that we have it in our y variable. So we convert the double into int. So no problem between converting from double from int to double and from int to double, like we have seen in y equal to x. But there is a problem while converting from an double to integer. Okay, so double cannot be contained in integer except if we use y.toInt method. We'll learn about these writings later on, but till now, just understand the relation between the primitive data and data types, and we are going to see later on the methods and other things. Just another important note in Kotlin, that sometimes it's useful to check the inferred type of the variable or constant. So if I create like 100 or 1000 line of codes, and despite searching for the type of x, I can put here, you can do in IntelliJ by clicking on the variable or the constant name and holding down the Control Shift P. Okay, you can see how you can make, and the inferred type is integer, so you get a message telling us that x is a integer. Okay, this can be done by Control Shift and P. You see the expression and you get the integer, the data type. Well, primitives require less memory, which means they are better for performance, but they are also lacking some of features of integers. So the good news is in Kotlin, you don't have to worry about whether you need to use a primitive type or an object type like in Java. So Kotlin handles that complexity for you. So all you have to do is to use an int. You have been using double to present the fractional numbers. Kotlin offers a float type which has less range and precision than double, but requires have as much storage. So we have the four here, the six primitive data types of numbers that are requiring that we have seen in Java. So byte is the minimum value is -1 to 8. The maximum value that contain is 1 to 7. Storage size is 1 bit. Now, the short is from this number to this number, maximum values, and the storage size is 2 bit. The int, see guys, the int is from this number, this big number, to this big number, and its storage size is 4 bits. The long is bigger than int, and it's the longest one from this number to this number, and its storage size is 8 bits. The float data type is minus 3.4 exponential from this minimum number value to this maximum value. Precision is 6 digits after the decimal point. Storage size is 1 bit, while the double is from this number to this number, 15 digits. Storage size is 2. So let me go to the IDE, and we will learn now about the numbers. We have seen the int, the val int, a of type short equal to 12. I create some variables, val b of type byte equal to 120. We see that the range is of short is less than the byte. I will create as s. Val I of type int equal to minus 1000 or 10,000. I can create a val answer equal to a plus b plus or s plus b plus I. Okay, just before talking about the answer, the first thing that we have learned is how to create the variable in the variable section, and we have introduced the numbers that they are short, byte, int, and long. I will create also the long and create a val about the float. So long, I will long equal to like this number. I can create a variable of type float equal to like point f, and val d of type double equal to point. Okay, just in the float you need to specify that it is a float by putting f, okay, at the end of the number. Okay, it's very important. These are the numbers that primitive data types that are dealing with numbers that you can create in Kotlin. Okay, now just a very interesting thing in Kotlin, that if you create a variable, it is not it's not of known type. I'm not specifying that it is a long, float, type, or int, byte, or short, and you assign the value s plus b plus I, s plus b plus I. I'm adding 12 plus 12 plus 120 plus minus 10,000. What do you expect from Kotlin? Thanks for Kotlin for creating a special variable, the corresponding variable of these things. So what I mean by that, I will print now answer. Okay, and let's run and see. It will do the calculation, and it's minus 9868. It's not a short, it's not a long, it's not a byte, it's of type integer, because if we go back to the documentation, we see that this number is included inside the int range. So automatically Kotlin will create this answer, and it will create it of type int. So if you hover the mouse over it, val answer of type int. You see, guys, val answer of type int. So we have learned about numbers in in Kotlin. Now, next step, we are going to talk about the characters and later on about the strings. So for that, I hope you stay safe and see you in next videos. To represent the character in Kotlin, char types are used. So we have learned about the numbers and we are going to learn about the character. So unlike Java, char types cannot be treated as numbers. Okay, so we have learned in Java, if you will go to the complete Java developer course, you will see the character video and the character lesson, and you see that characters are dealt according with an integer and as integers in the ASCII table, while characters are not dealt inside Kotlin. So in order to create a variable of type character, we start by a variable, or you can specify it as a constant val. I will start by constant letter of type char. Okay, you specify it. You could make like this letter equal to k, or you can directly put it like this. I prefer using this. Okay, now print what is the letter that we are going to print. You can print the letter like letter. Let's run and see. You see, guys, it printed from the character. Okay, so in this way we are creating and using the characters. You can't specify here the Unicode of the letter like this in Java. Okay, you only can put the characters like these now, and only one character. Okay, in Java you can do something like that, you can specify 65, which refers to a capital A, but in Kotlin it is prohibited. Okay, this is the character, and it is not of double quotation, it is of single quotation, and you specify one character and not two. These are the characters. You may encounter this data type, but it is not very useful, but we should learn about it because sometimes you may use this. We have learned about the numbers, and we have introduced these 6 types, the character variable, and we are now going to learn about the Booleans. So the Boolean data type has 2 possible values. Booleans have 2 possible values, either true or false. Okay, so I create a value, a constant value, or a variable by the same. I will call it as flag equal to true. In this way, I can create a value, or I can specify its type by Boolean. Okay, now print. In the same way, I will use print flag. Okay, let's run and see. And here we go, we have printed the Boolean. So in this way, we have created the Boolean type variable called, or constant called flag, and we assign its value to true. You can assign either true or false. Okay, so in this way we we learned about Booleans. Booleans are used in decision-making statements. This will be discussed in later lessons about the loops and the conditional statements. So don't worry, we are going to talk about them in deep later on, and we encounter these Booleans much more inside our videos. What's up, guys, and welcome again to the complete Kotlin course. In this video, we are going to talk about the strings in Kotlin. So we have seen deeply the strings in Java, but if you are like a newbie or a beginner and you are learning directly Kotlin, you are coming to the right place. So Kotlin, like any good programming language, can work directly with characters and strings. So in order to create a string has several characters, like a variable used for creating variables and constants of type string that contains words or phrases or any other thing. So, but strings are characters, are classes, and we will learn about classes later on in the OOP section of Kotlin. But till now, we are good to know that I can create strings, a constant string or variable string in the same way like this. So string A of type string equal to hello master coding channel. Also, I can print the string by typing string A. Let's run and see. Here we go. I have printed from the previous section. Hello, master coding channel. Okay, so in this way, we are specifying the data types and we have learned about the strings. But it is as simple as this. The right-hand side of this expression is known as string literals. We are creating a string literal. This way, string literals. Okay, we will talk about strings later on when we learn about the OOP. And of course, type inference applies here as well. So if you remove the type in the above declaration, the Kotlin does not or does the right thing. So if I remove the string, or if I remove the Boolean or character or double or anything, Kotlin will do the right thing and understand that this variable or this constant would be a string, a Boolean, character, and anything. So this is called type inference, okay? But I should learn you the academic way. I should start from zero, and we will learn later on by removing this, okay? Now, I should talk about something in strings called concatenation. Concatenation. You can do much more than create simple strings. Sometimes you need to manipulate a string, and one common way to do so is to combine it with other string. In Kotlin, you can do this is a rather simple way by using the addition operator, just as you can add numbers and you can add strings. Okay, what does this mean? I have created a string called, or I will start by creating a new string, string B of type string equal to hi. And second constant called string C of type string equal friends. Okay, these are two separate strings. I can write like this: print string A, or string B, sorry, string B plus string C. In this way, we are concatenating the two strings, exactly like in Java. We can concatenate the strings, and here you can concatenate the two strings. So I will put here ln and print ln, which is referring to print on a new line this thing. So you see, guys, that we have concatenated the two strings. We have displayed hi and friends inside this one single line by concatenating the first string and the second string. You need to declare, you can declare a variable here also, like val string d of type string equal to string b plus string c. Okay, you can do this, and you can now remove, and let's run and see. It's the same result. We have created a new string value, new constant, and inside this constant we have getted the value of string B and the value of string C, and we have concatenated them. Okay, there is another important thing that we can talk about it in the strings. It's called string templates. So string templates, you can also build up a string by using string templates, which use a special Kotlin syntax that lets you build a string in a way that it is easy to read. Let's create a value, or using the same string val string k of type string is equal to hello. I can put here a plus sign. Also, this is also called concatenation. My name is, so I am not talking about the concatenation. You can concatenate the two strings in the same way. Now, I'm going to talk about the string template as I told you. So I will create a val string n of type string. I prefer writing like this to understand Kotlin very well, and to the academic way, the academic writings. So I will create Jack as string name, and hello, my name is, I can put $sign and string n. You see, guys, I am putting the string here without specifying the name Jack like this, because if I change Jack, I need to change here also Jack. So this is very useful thing in Kotlin. I need to print string k. I need to print k, string k. So let's run and see. And here we go. Hello, my name is Jack. So Kotlin will go and search for string and get its value and return it back. So consider if you want to change it to a BBS Abbas. Let's run and see. And here we go. It is changed automatically. So this is string concatenation, string template, and the string class that we have talked about in this video. Oh, my friends, in this video, we are going to talk about the pair and triples in Kotlin. Sometimes data comes in groups. An example of this is a pair of x and y coordinates of a 2D grid. Similarly, a set of coordinates of 3D grid is comprised of an x value, y value, and z value. So for the pair, there is like a coordinates of x and y, and while a triple, think about it having three-dimensional point, which is x, y, and z. In Kotlin, you can represent such related data in very simple way using a pair or triple. Other languages use a type named tuple to hold similar combinations of value, like Python. Okay, so pair or triple are types that represent data composed of two or three values of any type. If you want to have more than three values, you can use Kotlin calls a data class, which we will cover in the future tutorials. Okay, so how to create like these variables in Kotlin? I will comment them. Sticking with pair for now, as an example, you can define a pair of 2D coordinates where each axis value is an integer, like so. So val, we start by variable, which is val, or a variable var, or you can make it as constant, which is a value. Okay, till now I will create a constant coordinates, which is a value. Coordinates, I will name it coordinates. I can give it its type. It is of pair. So you see, guys, this is the pair in Kotlin. And we need to make this shape, this like this diamond shape. And we specify here the data type that it would take. So the x would be an integer and the y would be of type integer. And we are going to cover this later on in the generic section. So how to make them and why we are using these data types. But till now, you need to know that we can create a pair in this form. So val, which is a value of a name coordinates. It is of type data type pair having an integer as x and y as integer. This is for demonstration, guys, but and for like making it simple. Okay, equal to pair of, and we put here the values of the pair that we are going to make. Okay, so to print them, we can use print and the coordinates, and we put here coordinates. Okay, you can convert a string concatenation to a template that we have seen before. Okay, let's run and see. And here we go, guys, the coordinates 2 and 3. The type of coordinates pair int int, the type of values within the pair is separated by commas and it's surrounded by these two angles, and these are called the diamonds. So inside the diamond, we have the integer, the data type, the first the pair, and the second pair, the second number inside the pair is of type integer. And you can specify any data type here. Okay, you see guys, any data type like string, int, and many other objects that you can create later on. The code for creating the pair is much the same, with each value separated by commas and surrounded by parentheses. Okay, so we have created it, and thanks for the type interface that can infer pair types too. So I can create this by removing the pair, okay, and the 2 points. So I can create directly a value, a variable also of name coordinates, and directly I can specify its data type by pair and 2 and 3. This is called the type interface. Okay, type interface. But we like to learn the basics and the academic way, and later on we can like use the type interface. Okay, so coordinates 1, this is 2. Okay, so I can create a variable like this, and by using type interface that is related to Kotlin, and without specifying the pair again of data type, it can directly get it and specify its data type. You can make this even more concise, which Kotlin loves to do, by using the to operator. Okay, so I can create here the same variable or the same constant, coordinates 3 equal to 2 to 3. This will make the pair. This is using to operator. Okay, so I can refer this, I can make a pair 2 3 by this. That's the academic way. This is the simplest and basics one. And I can create the same variable or same constant or the same data variable with directly specifying using a pair using the type interface. And I can create also in the same way 2 to 3. So I am using to operator. This is for pairs in Kotlin. You could similarly create a pair of double values like this. So I can create val like coordinates 4 equal to pair, and I specify directly 4.1 3.2.4. This is very advanced and very smart Kotlin helping and feature that it can directly specify and create and tell itself that, hey, he is creating a pair of doubles, okay, in the same way. And you can mix them by specifying an integer here and a decimal here. So also Kotlin will know that you created here a decimal and here a integer. Okay, and here's how to access the data inside the pair. So I can create, or the coordinates or the x coordinates, let me check, the x coordinates dot, and I can, you see guys, there is first and second, so it appears in this way. I can access the coordinates, which one I need, the first one or the second one. I need the first, so let me run and see to check And here we go. The x coordinates of the first variable is 2, and it is 2. Let me check the second. Okay. And here we go, guys. We have 3 here. Okay. We have discussed in the previous video the pair in Kotlin, and we talked about it as x and y relationship and a point in a 2D space system. Now let's talk about triples. Think about triples as a coordinate, a point having a coordinate 3D coordinates x, y, and z. So these are the 3 values of a triple, and from here it is named triple, containing 3 triple values. How to create a triple? So we start by the academic way, the basics. So coordinates 3D equal to, this is equal triple ABC. I specify here, I need the data type, as I told you, int. I am making a triple of 3 integers, and I create triple 1, 2, and 3. Okay, this is how to create a triple inside Kotlin. So let me print it. So print ln the 3D coordinates. You can make the concatenation, string concatenation, or you can use the string template by specifying the $, and we have talked about it inside the string lesson. And here we go. The 3D coordinates are 1, 2, and 3. In the same way, I can create val. You can create var or val, the same syntax, but the coordinates of 3D coordinates 3D, and this is the second one, equal directly a triple. Okay, so you specify directly it is a triple 4, 5, and 6. Okay, so in this way I can create a coordinate, a triple coordinate, so I can print it again in the same way. Okay, so this is the first type. This is the second type. How to put by specifying, by using type interface. Okay, you can specify it. Okay, this is how we can create a triple inside Kotlin. Now, how to use the data inside a triple? I can create a variable here, or a constant, because we have created a constant here, and the constant would be x or 3 equal to, or x equal to coordinates 3D dot first. I can get the y separately, coordinates dot second, and val z equal to coordinates dot third. Okay, you see, guys, that we have get the coordinates of 3D. This is the first element. The second element, and stored it in x and y, and the third element stored in z. Okay, so in this way we have get the data create 3 new constants and assign each part of the triple to them in turn. Okay, so this is how to get the coordinates data or the triple data in form of variables or constants, or you can directly print anything like x or z of denotes. We can specify coordinates dot third. Okay, and here we go. The z coordinate is 3. See guys, this is very simple. And this is that trip about the pair and triple in Kotlin. What's up guys, and welcome again to the complete Kotlin course. In this video, we are going to talk about 3 types: any, unit, and nothing. These words, these keywords, they are sometimes useful in Kotlin, and we are not going to use them basically or every time frequently, but we should know about them because maybe you will encounter them inside your during your process of coding. So the any type can be thought of as the mother of all other types except nullable types. Every type in Kotlin, whether an integer or string, is also considered as any. So any, see guys, this in Kotlin, this is covering or including the int, string, or anything except the nullable type. So every type in Kotlin except null. Okay. Except null. Okay, so this is like the object type in Java, which is the root of all types except the primitives. For example, it's perfectly valid Kotlin to declare an int literally and string literally as this. So using as any like so. So I will create val any number. This is called any number. And instead of using int, I can specify any. So it is 42. And I will create a new constant val, or you can use var, but I will use val. Any string, I will name it as any string, and I will give it the any type. And here it directly understand that the data type of any string would be a string. So any here refers to a string and any here refers to an integer. Okay, this is very simple, but we are not going to write like this because this is not a professional. We use the type interface to directly use the val and the constant in declaration. Okay, so this is how we use the any. Okay, we should understand it. Now, in order to use unit, there is a special type called unit. So unit is a special type which only ever represent one value, the unit object, which is referring the one unit object or unit object. Okay, this is very important. It is similar to void. It is equal to void, similar to void in Java, except it makes working with generics easier. Every function which does not explicitly return a type a string returns a unit. So anything that does not return anything like data types, strings, or integer, it returns unit. For example, I will create a function. Later on, we will learn about the functions. So, but till now, understand this. Add here, and I will create a val result equal to 2 plus 5 and print ln result. This function simply adds 2 plus 2 or 2 plus 5 and prints the result, but does not actually return anything. Not returning anything, guys. It's just printing. So the return type unit is implied. So the above function or this function would be the same as writing like this. Okay? So unit refers as a void in Java. So unit is equal to unit to void in Java. So this function, you can write this function without putting anything, and this will just print the result. And for demonstration, for using the unit keyword or unit type, it is not returning anything. This type corresponds to the void type in Java. Okay? This is how to use the unit. Now, nothing type. Nothing is a type that is helpful for declaring that function not only does not return anything, but also never completes. So, not a function is never complete. What does this mean? This can occur is if the function either causes the program to stop completely by throwing an exception, or if it simply goes on forever without ever finishing. How to do that, or what is the example, or what does this mean? I will create a function here, do and nothing for do nothing. And if I specify nothing here, this is the keyword, it will make, I will create a while loop, true. Don't make anything inside this while loop. Okay? You can cover while loops more in the next chapter. We will cover them in the next chapter by the basic control flow. But for now, understand that this function will simply run forever without ever returning anything. So, welcome to the land of nothing. It is just telling us that this will not make anything, and this function will not make anything, and it will not return anything. So nothing, it is a function that it is return nothing, do nothing. Okay? So this is the data type. This is the returning types or types in Kotlin that we should know. Any, unit, and nothing. So we will not use them frequently, but we should know about them. When writing a computer program, you need to be able to tell the computer what to do in different scenarios. For example, if we open the calculator, the calculator app would need to do one thing if the user tapped the addition button, and another thing if the user tapped the subtraction button. So 5 minus 6 is different from 5 plus 6. So these inputs, and these are the operators, and these will control the control flow. It will control the flow of the program. So in computer programming terms, this concept is known as control flow. It is also named, or it is so named because the flow of the program is controlled by various methods. In this lesson, we will start learning about decision making and repeat tasks in your program by using the syntax to control the flow. So you will learn also about the booleans that we have learned, that they represent true or false values, and how you can use these to compare data. So we will start by the comparison operators. Comparison operators. Okay. You've seen a few types now, such as int, double, string. Here you will learn more about another type, one that will let you compare values through the comparison operators. When you perform a comparison, such as looking for a greater of two numbers, the answer is either true or false. Okay? So Kotlin has a new type called Boolean, and we have seen it in the previous lessons, but just a demonstration about the booleans in Kotlin. So val, yes, variable, if type boolean equal to true. Okay, and val no variable, I will name it as like this, variable boolean equal to false. Okay, so I have created two constants of, I will name it, make them as variables. Okay, so yes variable or no variable of type boolean equal to true, and the other is false. So booleans only have two values, true or false. Okay, and because Kotlin's type interface, you can leave like this. You can like directly put its value, true or false. A Boolean can only be either true or false, denoted by the keywords true or false. In the code above here, you use the keywords to set the state of each variable. Now, we are going to introduce another thing and use the booleans inside the boolean operator. So boolean operators. So what are the boolean operators? Booleans are commonly used to compare values. For example, you may have two values and you want to know if they are equal. If they are equal, then true, and if they aren't, so it is false. So how to do that? By using the equality operator. Val, constant val, does, I will name it as does one equal to, this is the name of the variable, equal to, and here I can assign and check if one equal to two. Guys, look at here. One, is it equal to two? This is the meaning of is it equal? So Boolean expression can be simplified. This is simplified Boolean. It is equal to false. So this is the direct answer of this Boolean expression. But the Boolean expression here is telling and the checking equal sign. This is for testing. This is for testing equality. So Kotlin infers that does 1 equal to 2 variable is a Boolean. Clearly 1 does not equal to 2, and therefore it would be false. Okay, so this would return a false. If we go and try to print does 1 equal to 2 and run the program, it will return for us false. So let me run. It may take some time when running, and it is equal to false. So we have learned that the equality here, the equality operator is testing for 1, is it equal to 2? It is false, so it returns a Boolean. So these are the Boolean operators. These are Boolean operators, the 2 equal sign. If I put 1 equal to 2, it is very obvious it is wrong, because I cannot assign. This is assignment, are not expression. But if I put 2 equal sign, it is a Boolean expression, and it is a equality operator denoted by 2 equal signs. Okay, now if you need to check if they are not equal, so how to do that? It is very good operator to check if it is not equal. So we start by exclamation mark. Similarly, you can find out if two values are not equal using the does not equal sign, which is represented by exclamation mark and the equal sign. Okay, now let's run and see. And here we go, guys. We have it is true. So 1 does not equal to 2. So it is a Boolean of true, and it returns true to the system. Okay. This time the comparison is true because 1 does not equal to 2, and the prefix exclamation mark operator, also called not operator. This is the not operator. Toggles true to false and false to true. For example, if I need to change 1 equal to 2, this is false. And I can put here the not equal, the not operator. Not false. This is the answer of this would be false. But not here, not false, it would be returning true. Let's try to run and see how it works. And it's going here to display true. So this is the not operator. Here we have learned about operators, the Boolean operators. And the two more operators let you determine if the value is greater than. You can check like this, greater than this. 1, is it equal to 2? Greater than 2. Greater than or equal to, let's run and see, it will return absolutely false. Okay, because 1 is not equal to false to 2, and 1 is not greater than 2. Okay, you can use also the less than. This is the less than, and you less than or equal. Let me run and see, and it will return true. Okay, because it is less than 2. Okay, so this is less than sign operator. This is the less than or equal sign. This is greater than, and this is greater than or equal sign, and this is equal sign. Is it equal? And this is not equal sign. These are the 6 operators that we are using inside the Boolean operators. These are the comparison operators. You can see it. Check them, comparison operators. Okay. So it's very simple to understand this because they are logic. Well, hello, my friends, and welcome again to the complete Kotlin developer course. We have started learning about the basic control flow in Kotlin, and we have learned about the comparison operators, and we have learned about the 6 signs. These are the equal, checking for the equality, does not equal, the less than or equal, greater than, or greater than and equal. Okay, so these are the 6 operators. Each of the examples above tests just one condition. Thanks for Char Boolean. This is the who invented Booleans. He had much more planned for it than these humble beginnings. So he invented Boolean logics and the logic operators, which lets you combine multiple conditions to form a result. One way to combine conditions is by using and or operators. When you AND together two booleans, the result is another boolean. If both input booleans are true, then the result is true. Otherwise, the result is false. How does this mean in Kotlin? In Kotlin, the operator for boolean AND is AND. And operator is equal to double AND. Okay, and the OR operator is denoted by 2 vertical slashes. Okay, so let's start by the AND. In Kotlin, the operator for the Boolean, as I told you, it is denoted by 2 AND signs. So I will create val called AND constant equal to true and true. So this, in this case, it will be true if either of the values on the right was false, then AND would be false. So true and true, true. False and false, false. True and false, false. False and true, false. Let me run and see. So this, you can see here simply, you can see here, guys, if you hover your mouse, Boolean expression can be simplified. Simplify Boolean expression and it is true. Now let's check false and false. Okay, if we simplify the Boolean expression, it would be false. So false and false equal to false. True and false, if we hover and simplify, it would be false. And again, false and true would be false again. Okay, so true and true. If we print it, it will give us the same result. So print and constant. Okay, let me run and see and check. I will comment this from the previous exercise and it will give us true. So if we change false here, let me run again and see, it will give us absolutely false. Okay, so this is the AND operator. This is the logic operator of AND. Okay, another way to combine conditions is by using the OR operator. So I will move this to here and let me see. So the logic operators, the and we have taken an example about it, and the or operator, I will create a new constant here called or constant equal to. When you or together two booleans, the result is true if either of the input boolean is true. Only if both input booleans are false will result in false. So in Kotlin, the operator for boolean or is two vertical slashes like this. So true and false. As I told you, when checking for the or equality, the or operator and the logic, if one of the two is false, we can get it as when one of them is true is true. True or false, false. True. True, false, or false, it will give us false. False and or true, it will give us true. And the true or true, absolutely, it will give us true. So this is the usage of true. In this case, or will be true if both values on the right, this is the true or false. If both were true, then or would be true, and we have seen this. Okay. Now, in Kotlin, Boolean logic is usually applied to multiple conditions. Maybe you want to determine if two conditions are true. In this case, you would use and. And if you only care about whether one of the condition is true, then you would use or. Okay? For example, consider these codes. I will make exercises here. Val and true equal to 1 less than 5 and 15 less than 100. What do you think about this? 1 less than 5. It is, first of all, it is a constant called and true. It have an and operator, so it will compare the condition, the boolean. This it will and the boolean from the left side and the boolean from the right side. So what is the result, the boolean result of this on the left? 1 less than 5, yes, it is true, so I can put it true. 50 greater than let me make it 10. 50 greater than 10, yes, it is true. So true and true, it will give us true. So let me allow Kotlin to make this calculation for me. Simplify Boolean expression here, and it will give me false because I have made 100. Again, simplify, it is true. Now, if I put 100 here, it is false here and true here. true and false, it will result in false. Okay, now if I use the or true or false, it will return for us true. Okay, so this is the functionality, this is the logic how Kotlin will work, and how Kotlin separate the conditions and compare them by using the logical operators. Well, hello my friends, and welcome again to the complete Kotlin course. We have learned about the basic control flow, and we have said that we have comparison operators that include 6 operators: equality, not equal, equals, equal, not equal, less than or equal, greater than or greater than, and equal. And we have learned about the logic operators, the AND operator and the OR operator, which values between the and give us the value between the result between the two booleans. Now we are going to talk about the string equality. Sometimes you want to determine if two strings are equal. For example, a children's game of naming an animal in a photo would need to determine if the player answered correctly. In Kotlin, you can compare strings using the standard equality operator. In Java, this is different. We use is equal method. Okay, but in Kotlin, we can use the ordinary equal operator and its standard equality operator in exactly the same way as you compare numbers. For example, if I have val, I'm making a quiz, so I have stored x equal to, let me say, Kotlin. And the result val dog equals maybe y equals x equal to x. Is it equal to Java? So let me print y equals x, and it will return false. You see here, y equals x is a boolean that is in this case equal to false because Kotlin does not equal to Java. Simple. So just as within the numbers, it will compare x. It will go through here. It will put here val y equal x. Forget the equal sign here. It will separate like this. X, it will go and get the value of x, and it is equal to Kotlin. So here, the Kotlin, is it equal to Java? Is the same naming, it's the same letters? No, it will return false. So it will go and goes here to store it like equal to false. Okay, this is the logic of Kotlin and how it thinks about comparing the string equality. Okay, this is how string equality works. And also, just as with numbers, you can compare not just the equality but also to determine if the value is greater than or less than the another value. Okay, so how it works, I can create here val, let me say z equal to php less than Java. Let me run and see. or you can simplify the Boolean expression. It is equal to false because it is not less than. This syntax checks if one string comes before another alphabetically. So it is P less than J. No, J comes first before the P. In this case, the Z equals to false because PHP comes or Java comes before the PHP. J comes before PHP. Now let's see if A less than B. If we hover and simplify Boolean expression, and it is equal to true. So this is the string equality. We have learned about the basic control flow, and we said that it is comparison operators, logic operators, and string equality. Later on, we are going to talk about the advanced control flow, and but the way we are going to start with conditional statements and conditional expressions, and later on the advanced control. The first and most common way of controlling the flow of the program is through the use of an if expression, which allows the program to do something only if a certain condition is true. For example, consider the following code. If 5 greater than 2, go and print for me, hey, 5 is greater than 2. Let's run and see. And here we go. Hey, 5 is greater than 2. If we put 5 less than 2, hey, 5 is greater than 2, it's less than 2. Let me see. And here we go. Nothing happens and nothing is printed out. So if 5 less than 2 and it is not true, so the if condition, this between the two parentheses concerned and related to f, are not executed. So this is a simple if expression. If the condition is true, this is the condition. So between the parentheses is the condition. So these numbers are the condition. Then the expression will execute the code between the braces. So if the condition between the parentheses is true, then the expression between the braces would be executed. Okay? If the condition is false, then the expression won't execute. It will not be executed. And the code between the braces is not executed. So if this condition is not true, like if 5 equal or 5 less than 2, this will not be executed. The code between the two parentheses will not be braces are not be executed. Okay? Curly braces code will not be executed if the condition is not true. The term if expression is used here instead of if statement, since unlike many other programming languages, a value is returned from the if expression. The value returned is the value of the last expression in the if block. So despite the conditional statement, it will be a conditional expressions. Okay. Now let's continue with if expressions. You are not required to use the return value or assign it to a variable. You will see some more on returning a value next. So you can extend an if expression to provide code to run in the case of conditions turned to be false. How to do that? This is known as else clause. So if 5 is greater than 2, make this. Otherwise, if 5 is less than 2, what to do? It will print, oops, 5 is less than 2. Let me run and see. And here we go. Kotlin goes and start reading from here. If the condition 5 greater than 2 is true, then go and print this. And this is true because 5 is greater than 2. And it is executing all the code between these curly braces. Otherwise, else would be executed if condition is not true. Let me see. 5 is less than 2. So 5 is less than 2 or greater than. I will keep it. If 5 less than 2, condition one is true. Here condition 2 is true. Let me run and see. And it will return condition 2 is true. If 5 less than 2, and this is not true, so this code till here would be skipped because the condition is not true. So everything related to the first condition, which is defined by 5 less than 2, between the curly braces, it will not be executed. It will be skipped. It will execute the else condition because this is false. What is the true? This is the true. So it will be executed. Condition 2 is true and is executed. Okay? You see, guys, the conditional expressions and how they are working together and how the logic of this would be determined by understanding the conditional expression and thinking about the flow of your program, and you are going to use 99% of this control flow in all of your programs. Okay. Now, one another thing before we finish the conditional expression lesson. If I need to check if 5 equal to 2, here f is less than 2. Otherwise, it will return if 5 greater than 2. But if I want to check if 5 equal to 2, then I need not to use else. I need to use else if, and I need to insert a condition. So f greater than 2, so condition 2 is true, and otherwise I will put else and print condition 3 is true. If 5 less than 2, print this. Else if 5 greater than 2, it will print this. Otherwise, it will print 5 equal to 2. 5 equal to 2. Let me run and see. And condition 2 would be executed because 5 is greater than 2. It is not less than, and it is not equal. Now let's test with a real constants. So val x equal to 5, val y equal to 6. Now let's check for real values of these. So if x less than y, print x less than y. If the condition 2 is x greater than y, y or x is greater than y. Else x and y are equal. Okay, let me run and see. It prints for us that x is less than y because it goes and verifies x less than y, 5 less than 6. Yes, it is true. So go and execute this code between these curly braces related to the first condition and drop these conditions. Okay, now let me change it. And here we go. We have else if is executed. So the condition 2 is executed because 15 is greater than y and it tells us x greater than y. Now let's change y also and give it an equality to x. And here we go. It tests for x less than y, 15 less than 15, no. Else if 15 greater than 15, no. So skip this line. Now, else they are equal. If x less than y, no. If x greater than y, no. Therefore, x equal to y. These are the three conditions. And you can put many conditions here and so on as your program and your application dictates. So, thank you guys. I will see you in next video. We'll continue with the conditional expressions, and we are going to take a new example about finding the minimum and the maximum between the two numbers. So if I have two numbers, x and y, and I need to get the minimum, so val minimum of type integer, int if a less than b, then minimum equal x less than y, so minimum equal to x. Otherwise, I would put else and put the minimum y equal to minimum equal to y. Okay, this is very simple. I will create a val max of type int if x greater than y, then max equal to x. Else max equal to y. Okay, I'm finding the minimum and the maximum between the two numbers. By now, you know how this works, but it's a lot of code. Okay, let's take a look at how we can improve this using the fact that if-else expression returns a value. As I told you, we said that they are conditional expressions and they are not conditional statements because expressions return a value. And this value, this returning value, we are going to use it making use of conditional of returning value of expressions. How to make use of them? Despite writing all of these codes to find the minimum and the maximum, I can and assign them to min and max variables. I can put like this. So I have created above the variable x and y, and I will change the code val minimum and val maximum into simple lines. So val minimum equal to if a or x less than y, then put it as x. Assign it to x. Otherwise, assign it to y. It's very simple, guys. It goes and minimum, because I have created minimum here. Despite writing all of these codes, if x less than y, put m a minimum equal. I write it with one line. Val minimum equal to. This is the expression. It returns the expression. So this will return expression. So if x less than y, it return x. Otherwise, it will return y. So minimum equal to x if x less than y, and minimum equal to y when it is x greater than y. So the returning value of the expression of this, if x less than y, it returns x. This is the difference between the expression and the statement. In other languages like Java and Python and other things, they will not return the value of the expression. So we have learned how to make the minimum. Now let's create the val of maximum equal to if x greater than y, it will return x, else return y. Okay. In the first example, the condition is ax less than b or x less than y. If it is true, the result assigned back to the minimum will be the value of x. If it is false, the result will be the value of y. So minimum is set to, if we go up, 7 less than 5. So minimum is set to 7, and maximum in the same way would be set to the 15. Okay? In this way, we have learned how to make a very simple and make very simple coding. And despite writing all of this code, we make use of returning value of expression, and we have used it in one line to detect the minimum and the maximum. Okay, it's very simple, and I hope you benefit from this video and this course. Please rate us 5 stars on Udemy to support us making new videos. Loops are Kotlin's way of executing code multiple times. In this video, we will learn about one type of loop, the while loop. If you know another programming language, you will find the concepts and maybe even the syntax to be familiar, like Java. So if you want, you can go to the complete Java developer course and see the loops syntax and learn more about them, and you will see them familiar as Kotlin. So the while loop. While loop repeats a block of code while a condition is true. You create a while loop like this. While, you write the while code and the keyword, and here is the condition. So here is the condition that you need to put, and here is the loop code. Okay, so this is the condition and this is the loop code. Okay, this is the formula and the syntax of the while loop. The loop checks the condition for every iteration, and we are going to learn about the iteration in next couple of minutes. So if the condition is true, then the loop executes and moves on the another iteration. If the condition is false, the loop stops, just like if expression. While loops introduce a scoop. So the simplest while loop takes this form. While the condition is true, so while true, you can put like while true, go and execute the loop code. I will make an example to see you how to make it. Var x equal to 1. Okay, I will create a variable called x and assign a value 1 to it. Now, I will create a loop while equal to x less than 100. Go and make x equal to the old x plus x plus 1. This code calculates a mathematical sequence up to the point where the value is greater than 100. And every time you execute it, print ln the value of x. Okay, now let's run and see. Here we go. We have this output: 3, 7, 15, 31, 63, and 172. Okay, now how these numbers have been calculated. This is the run tab. 3, 7, 15, and 31. How to run and how it will be executed. If we look how the while loop has been increased and how the iteration works, we find that x here represent the old x. So this is the new x. This is new x, new, and this is the old x. Okay, let me rename them and see how to work with it. So at first iteration, x equal to 1. It enters here while x less than 100. Yes, the value, this condition is true. So go and execute this code inside the loop. Okay, let me use the eraser here, the pen. Okay, so we are going to execute this code many times until the condition stops to be true. X, the new x at the first iteration, equal to x, the old x, plus the old x again, 1, and plus 1. So this would make x equal to 3. So the printing would result at the first time with 3. Now, let me move to the second iteration. Goes up and checks if the condition still validated. So 3 now is less than 100 and it's true. So go and execute this code again. The new x equal to, in the second iteration, is equal to the old x, which is 3, plus it is a substitution of x, the value of x, 3 plus 1. Okay, so 3 equal 3 plus 1, which results in 7. Okay, so this is the second iteration. Now, it prints out the result, which is 7, and goes up again to the third iteration. Okay, so I will use now the pen with another color to ensure that you understand everything. It goes up. Now 7 less than 100. Yes, 7 is less than 100. So goes and execute this code again. X, the new value of x, equal to 7 plus 7 into, plus 7 plus 1 into, and 7 plus 1, 8, plus 7 equal to 15. Okay, so this is the value, the third value that we have got it. Now, it prints out the result and goes up. It checks if 15 less than 100. Yes, 15 is less than 100. So it again execute the new x equal to old x, which is 15, plus 15 into 50 plus 1 is equal to 16 plus 15, which is equal to 31. So this is the result of the fourth iteration. Now, I will change the color to be like this blue. So 31, it print out the result and goes up to validate the condition. 31 is less than 100. Yes, so go and execute the code again. So the new x equal at the fifth iteration equal to 31 plus 31 plus 1. Okay, so 31 plus 1, 32, plus 31, it is equal to 36. It prints out the results, 63. Now, it goes up again and it checks for 61 is less than 100. Yes, it is less than 100. So it repeats again, x equal, the new x equal to 63 plus 1 plus 63. 60 plus 60, 120. Plus 7 equal 1, 2, 7. It prints out the 1 to 7 and goes up. So I will change the color and goes up to here, to the x, to validate the condition. X is 1 to 7. Don't miss this now, because we have the number here. Okay, so 1 to 7 is less than 100? No. So go and exit the loop. And it will give us 3, 7, 15, 31, 63, and 127. From this way, the Kotlin calculates and deals with the loops. And this is how the loop works in Kotlin and other programming languages, but mainly in Kotlin. Hello, my friends, and we will continue with the loops. We have introduced in the previous videos the while loop, and we have learned about iteration and how while loop think and how while loop will be executing its code according to the condition validation. Now we are going to learn about a new type. It is called of loops. It's called do while loop, or repeat while loops. A variant of the while loop is called the do while loop, which is do while loop. Okay, this is do while loop. It differs from the while loop in that the condition is evaluated at the end of the loop rather than at the beginning. Okay, so it differs from the while loop in that the condition is evaluated at the end of the loop rather than the beginning. Please write it down, this note, because it's very important to distinguish between and how to use and when to use the loop, while loop, and the do while loop. Okay, you construct a do while loop like this. Do, we start by do, and here is the loop. This is the loop code, and the while condition, here is the condition. Okay, so we start by the do and execute and evaluate the condition at the end of the loop, not at the beginning of the loop. So here is the beginning of here is at the beginning of the while there is a condition validation, and here in the do while the condition is evaluated at the end of the loop. So it will execute the code loop for the first time even if the condition is not true. This is very important trick, guys. Okay, so here is the condition. How to do a quick example to understand it. We will make by the do. I will variable x, I will use it, I have created before. So do loop code x equal to new x plus the same way plus x plus 1. I will do it again. So while condition, the validation of the condition, sum equal to less than 10, or x less than 10. Okay, in this example the outcome is the, let me make it 100 to be making it the same as before. Okay, I need to comment this, and I need to print ln, the value of x. Okay, so let's start again. And here we go. In this example, the outcome is the same as before. However, that is not always is not always the case. You might get different result in different conditions. Okay, so what are the conditions? Consider that if I will change the first one, while x less than 1, or I will make it as 10. So if x less than 5, do this. And the same thing I will make while x less than 5 or 10. So I will give x for the first while loop and see if it will print x. And I will pass it the same x for the do while. Okay? If it is, it would be increased and give us 11 or not. So let me run and see. And here we go, guys. It is 21. So the first, here is the difference. Okay? Please concentrate with me. If you are using the while, it will validate the condition at first and then allows you to enter the code inside the loop. So here, x, which is 10, is not less than 5. So 10 does not equal or less than 5. So this code will never be executed. Okay? So it skips this loop. It goes down to do and then validate. So it execute the code. It put here the new value of x, which is equal to old value of x, which is 5, and 5 plus 1. 5 plus 1 is equal to 6. It is equal to 10. Okay, so the value of x is equal to 10, not 5. 10 here and 10 here. 10 plus 11 is equal to 21. Now x is equal to 21. Print it. It allows us to see inside the console that it is 21. Then it validates the condition. If x, which is 21, less than 10, no, it is not true, to go up and do it again. Okay, this is the syntax. This is the algorithm, how the do while loop and the while loop execute and works inside Kotlin. Okay. Sometimes you want to break out of a loop early. You can do this using the break statement, which immediately stops the execution of the loop and continues on the code after the loop. For example, if we go here, I will delete the do while loop. If we go up to the first loop that we have created before, and I will assign the x equal to 1, and while is equal to true. So I always make this. So how to stop this infinite loop? If I run now, it will go and in an infinite loop. So you see, guys, there is an infinite loop, and maybe make some memory leaks, memory. This, you see, guys, these are the infinite loop. It goes up and it starts. Let me run again. It starts by printing numbers. It calculated it before and then a -1 because it is reaching the memory leaks and memory infinite loop. Okay, so how to provide this, or how prevent it, or how to make a breaking out of the loop. This is an infinite loop because always the condition is true. I'm telling you that the condition is always true. Nothing will control or change the condition, make it false to break out the loop. There is another there is another way to make if x greater than or equal to 100. Let me show you. Then what to do? Break statement. So it start by while true, it will always execute this x equal and start again that we have seen in the previous video with executing this sequence. And there is a condition here. If x greater than or equal to 100, when x reaches 100, break, go outside the loop. So break, it will give you a break outside the loop. So this is the loop. The break is responsible for getting you out from the while loop. So it will execute this print like ln outside the loop. I am outside the loop. Let me run and show you how this works. It starts by 3, 7, 15, 31, 63. It reaches 1 to 7 by the sequence, the last sequence that we have seen in the previous videos. And it checks if x, yes, 1 to 7 here, 1 to 7, greater than or equal to 100. So go outside, break this loop, go outside and continue executing the other codes, which is print I am outside the loop. Okay, so this is how we break outside the loop. You've seen how to write the same loop in different ways, demonstrating that in computer programming there are often many ways to achieve the same result. You should choose the method that's easy to read and conveys your intent in the best way possible. This is an approach you will internalize with enough time and practice. Okay, so the choice of between the while and how to achieve things in different ways will come with the practice and time and exercises. Hello, my friends, and welcome to exercise number 1. In this exercise, we are asked to give the result of these constants. We have 4 constants, and we have these Boolean expressions, and we need to get the results. So let's consider the first variable, or the first constant. It's named Q1 and having true and true. So true and true. By the logic, it is equal to true. So as we said in the previous videos, true and true gives true. True and false will give false. False and true will give false, and false will give false. So whenever you see the and expression and there is no true and the true here, it will give false. Okay, so this, if we use you can print out the result like print ln, but I will use here the Kotlin. We have, if we hover the mouse, simplify Boolean expression, and it is equal to true. So it is the same result as we print the Q1. Okay, now Q2, what is the result of Q2? False or false will give false, because as we said in the previous videos, true or true, true, true or false, true, false or true, true, false or false, false. This is the only expression in or that will give you false. And this is the only expression in true that will give you a true in end. Okay, so if we hover, simplify Boolean expression, and it will give false. Okay, it's very simple. These are the simple mathematics and simple logic mathematics. Now we have Q3. We have this expression here, and we have or. You see, guys, this is the or, and we have a second part here. We need to simplify first the first part and the second part later on, and we make the or between them. So inside this, if we take this and we put it here, what it is equal to? It is also divided into two parts, the first part and the second part, and we have and expression between them. So how to do that and how to think in logic? True and we need to get this. 1 does not equal to 2. So 1 does not equal to 2 is true. Okay, so 1 does not equal to 2. So I am verifying a true and a true. And since we have calculated it in the previous question, it's a Q1. So true and the true will give true. So it is very simple. Okay, it's very simple. So the first part in this question is equal to true. So let me put it here. This is equal to true. And we have or between the two. And we need now to calculate for greater than 3 and 100 less than 1. So I can give you now the result directly. Since true or anything will give us true, so the Q3 would exactly give us true, despite it is true here or false. Okay, but let me check the other equation to allow you to solve and think like Boolean expressions. Okay, for greater than 3, and we have and sign here, and 100 less than 1. For greater than 3, yes, it is true. And 100 less than 1, no, false. And we have learned that true and false will give false, because true should, with and, it should be true here to always give us true. Okay, so it is false. Now we get true or false will give us, now it is true. Okay, it is very simple, guys. It is about expression, Boolean expression, and logic. If we hover the mouse here and simplify Boolean expression, it will give us true, exactly like what we have done. Okay, now I want from you also to make this expression and give me the result in the comment below. Okay, so pause the video and comment the question and the answer below. So did you think about it? Okay, let me solve it. We have here Q1, Q4. We have two expressions, 1 and 2, and they are separated by and. So let me start solving this. And this, we need to make the division first and make the evaluation. Is it equal, greater than 3 or not? 10 over 2, it is equal to 5. So 5 greater than 3. Yes, it is equal. It is greater than 3. So it is true at the first one. We get this equal and the sign and sign, and we need to verify this. So 10 modulo 2, if we divide 10 over 2, it is equal to 5. If there is any remainder, any thing remainder, no, because 5 times 2 will give us 10. So remainder is equal to 0. Is it equal to 0? Yes, it is equal to 0. So it is returning true. So true and true will give us true. Okay, now let's use this simplify Boolean expression. You can click Alt plus Shift plus Enter to get the simplified Boolean, and it is equal to true. And good work, guys. We have solved the exercise number 1, and it is very important to start thinking about Boolean expression and think about how Kotlin deals with the expressions, the operators, and how the logical things works in coding. In the previous lessons, you learned how to control the flow of execution using the decision-making powers of if expressions and the while loop. In this lesson, you will continue to learn how to control the flow of execution, but in an advanced way. You will learn about another loop known as the for loop. So let's discover what is the for loop and what is the usage of for loop. Loops may not sound very interesting, but they are very common in computer programs. For example, you might have code to download an image from the cloud with a loop that could run that multiple times to download your entire photo library. Okay? So you will also learn about the when expression, which are particularly powerful in Kotlin, and we will introduce it later on. But before we dive into the for loop, we will start by things called range. Okay? Before you dive into the for loop statement, you need to know about the range data types, which let you represent a sequence of countable integers. Okay? So it's a method to represent. Please write them down to understand them, and later on, if you want to review your codes and studies, you can get them directly from your notebook. So represent a sequence of countable integers. Okay, let's look at two types of range. The first type, it is called closed range. I will create a constant called CR, closed range, 0. And look, guys, how to make the closed range. 0 to 5. Okay, so in this way we have created a closed range. The two dots indicate that this range is closed, which means that the range goes from 0 to 5 inclusive. So from 0 to 5 inclusive. Let's print CR to see the result and run. And here we go. We have 0 to 5. It is the range. This is the range of the closed range with CR. Okay, so that's the number 0, 1, 2, 3, 4, and 5 are included inside CR. The second type of ranges is called half open range. Okay, which would you represent like it like this? Val half open, I would say half open range, HOR, equal 0. And look guys, we are going to use until, so it is a keyword here, until 5. What are the difference between these two ranges? The first one, here you replace here you replace on the second one, the half open range. Here you replace the two dots with until. Half open means the range goes from let me comment, from 0 to 4 inclusive. Okay, so but not including 5, that these numbers are 0, 1, 2, 3, and 4, and above the numbers are 0, 1, 2, 3, 4, and 5. Okay, so this way we have learned about the closed range and the half open range. Okay, this is the ranges in Kotlin. There is another thing that you should learn. 1.5 open ranges created with 2 dots and the until operators are always increasing. They are increasing. But somebody will ask me how to make the range decreasing. So how to make it? Making a decreasing range. We start by, in other words, the second number must always be greater than than or equal to the first. To create a decreasing range, you can always use DownTo, which is inclusive. So val decreasing range dr equal to 5. Look guys, down to 0. Okay, and this will include all numbers but in decreasing order. So it is 5, 4, 3, 2, 1, and 0. Okay, these are the ranges in Kotlin. This is what are the difference of different ranges, and they are commonly used in both for loops and when expression, which means that you thought the rest of the lessons you will use ranges as well. So we are going to use these ranges in the loops and the when expression. So I hope you understand this, that the closed range is from 0 to 5 and inclusive. So half open range is 0 until 5, and 5 is not included. And to make it decreasing range, we use 5 down 0, 5, 4, 3, 2, 1, and 0. And 0 is inclusive. So 0 inclusive and 5 inclusive. Thank you guys. I hope you rate us 5 stars on Udemy to support us making new tutorials and new courses. In the previous lessons, we have looked at the while loops. Now that you know about ranges, it's time to look at another type of loop called the for loop. We have said that the ranges have closed range 0, 2 dots, and 5. So 0, 1, 2, 3, 4, 5 are included, while the half open range 0 until 5, it is from 0 to 4, 0, 1, 2, 3, 4, and 5 is not included. So only 0, 1, 2, 3, 4. And we have said that to make a decreasing range is from 5 down to 0. We have used the down to keyword. Now, in order to make a for loop, we construct the general for loop is like this. So please write it down, guys, in order to understand it well and make a very brief notes. So for, and we specify here the constant. So constant in range. Okay, this is the for loop condition. Now, the code here, we can loop code. Okay, so this is the loop code. Okay, guys, the loop begins with the for keyword. You see, this is the for keyword, followed by a name given to the loop constant. More on that shortly. Followed by in, so the constant, in followed by the range. So we have here the range. So remember, guys, for, and we specify the constant in range, constant in range. This is the trick. This is the key of the for loop. Okay, so I will comment this. And I will create a new example in order to understand the for loop. I will create val count equal to 10. I need to count to 10. So var sum and make the sum for equal to 0. I have created one constant, and second is variable called sum, and the count is constant because it is having a value 10, and val, while variable is sum, and I need to add a summation to this variable. Okay, how to do that using a for open parentheses I in one dot, I specify here the constant the constant is I, and in range, so we specify the range as I told you from 1 to 10. Okay, I can remove count from here in order to better understand things. So I am specifying here the range, and I need to make the sum equal to sum plus I. Okay, what we have done here, we specified that it is a for loop. The constant I, which is an integer that we have created here using the for. So if we look at the Java codes, we see that we have created int I. So we write in Java for int I equal to 0. I am specifying here the first condition and creating a new variable called I. In Kotlin, it is directly created. So for I, this is the constant here, but in range, I need the range from 1 to 10. I need to get the summation, all the sum of numbers from 1 to 10. Sum of numbers. Let me write it here. Sum of numbers from 0 to 10. This is the program that we are creating using the for loop. Okay, so the sum, this is every time the code, every time it is iterated, the loop iterates from 1 to 10, the summation, the new summation, this is sum new, this is the sum, this is the new variable that we have created here, is equal to the old result, to the old summation, to the old variable, plus I. I is in the range, so I would be 1 at the first, second 2, 3, 4, 5, 7, and 8, 10, 9, and 10. So I would have 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10. Okay, so let me run and then explain what are the results. I will print every time the sum. So every time the loop will be executed, it will print out the summation. So back to here, to the program. Okay, and waiting for the Kotlin. And here we go, guys. We have these numbers. We have 1. It starts by 1. 1 plus 2 is equal to 3. So if we go up here, I equal to 1 now. Okay, because it starts from I equal to 1. Sum is equal to 0. We have created it before. So 1 is I, and sum is equal to 0. So the new sum now is equal to 1. Print sum, so it print out the 1. Again, it is in range, okay? Going up, yes, it is in range. I increased by 1. So when we specify for loop I, the increment would be by 1. I equal now 2. So 2 is in 1 and 10, yes. So continue and execute this code. The new sum, this is the variable, equal to the old sum, which is 1. 1 plus I equal to 2. So I plus 2, 1 plus 2 is equal to 3. Print sum is equal to 3. Going up, 3 is in 1 and 10, yes. So sum, the new sum, create like update the sum and replace the sum with the old sum, which is 3, and the I equal to 3. So 3 plus 3 is equal to 6. Okay, so sum is equal to 6. Going up, I is equal to 4. Yes, is equal to 4. 4 in 1 and 10, yes. So replace I with 4 and go and create, update the sum. So remove the old variable and create the old variable, which is 10, the old value, plus, sorry, it is equal to 6. And plus 4 is equal to 10. Then print the result and equal to 10. So in this way, the algorithm of the loop, the for loop, continues to execute all of these, okay, till 10. So if we count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 10 results. So we can like analysis or interpretation, like we are getting 10 values from 1. 1 is included. So we have learned this in the ranges 1, 2, 3, 4, 5, 6, 7, and 8, and 9. 10 is included also. So we have 10 times this code have been executed. Okay, so this is the function, this is the role of the loops. And by the way, we can create like sum is equal to sum, the old sum plus I. We can replace it by plus equal sign. Okay, this is the same as sum equal to sum plus I. Okay, Okay, guys, so we have this for loop and we have learned about it more in details. Sometimes you only want to loop a certain number of times, and so you don't need to use the loop constants at all and the ranges, like this example. So in that case, you can employ a repeat loop like so. Okay? Instead of using like this for loop, I am going to use a repeat loop. We start by a repeat keyword. So repeat keyword. And how many times I need to repeat it? You see, guys, that there is a notation telling us times in int. So how many times you need to repeat this? I need to repeat it 10 times. And I will specify the same codes as before, sum equal to I. You can, or I need here to create a sum equal to 0. We have created it before. And I need to create var last sum equal to 0. Sum equal to last sum. And I need to create a variable here called constant equal to temp equal to sum. Okay, I'm storing the sum inside a temp first, which is equal to 0. Let me show you. Sum is equal to 0. I'm storing it the first time at temp and getting sum equal to the sum, the old sum plus the last sum, and then last sum equal to temp. Okay, print ln the sum. I will comment this. Oops, we have zeros. Okay, the sum would be 1 here. Okay. And here we go. We have 1, 2, 3, 5, 8, 13, 21, 34, 55, and 89. Okay, so in this way, we can create the same coding, the same thing, but using the repeat loop. Okay, we specify the index here, how many times you need to repeat this. Okay, now we will continue with the for loop, and we said that we create a range from 1 to 10, and we are looping through this with this range. Okay, now it is possible to only perform certain iterations in the range. For example, imagine you wanted to compute a sum similar to that of triangle numbers, but only for odd numbers. We need to make the odd numbers. So we use here step keyword, and how the ratio would be jumping, how many times you need to jump, how many numbers, or what is the way, what is the pattern you need to jump. I need to jump 2 numbers. So this way has a step operator in the for loop statement. The loop will only run through the values that the step falls on. In this case, rather than step through every value in the range, it will step through every other value. As such, I will always be odd because the starting value is 1. Okay? So it takes 1, it takes 1, Then it took 2. No, it took 3 because it is stepping 2. So these are the numbers that it is included in the pattern. And now we need to jump over these numbers. So we start by 1, stepping 2, 1, 2. Okay, so 3, 3, step 2, 1, 2, so 5. So we have 1, 5, 1, 3, 5, 7, 9, because we are stepping 2 numbers, not iterating through every number. So this way, we have inside this loop the iterations of I, and the value of I would be 1, 3, 5, 7, and 9. Okay, so this is the way how to step 2 numbers, or how to modify the stepping and the iteration. Okay, this is normal loop. Here we have used step 2 loop, and there is a countdown loop. Imagine that you need to count down the loop. Despite starting from 1 to 10, it is inversely starting from 10 to 1. How to do that? You can even count down in a for loop using DownTo. In this case, if count is 10, then the loop will iterate through the following numbers. So if we use in 10 down 2, okay, down to 1. Let me run, and or what is the result that the loop will take as I? Think about it, guys. We have specified by I is constant in. In what is the range? It is from 10 down to 1. Okay, guys, you need to segment, you need to partition and divide the loop into many parts to understand it. I in, what is the range? It is here from 10 to 1. So the loop will start from 10 to 1. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 1 is included and 10 is included. But there is something here. It's called step 2. And step 2 starts from modifying and getting the only and jumping 2 numbers by 2 numbers. So let me clarify this. It is here I am writing 10 to 1. Okay, so it start by 8, 7, 6, 5, 4, 3 to 1. Okay, 1 is included and 10 is included because we are using down to 10 to 1. Okay, since we have used the step 2, we can remove this. So this is the correct one, down 2. Okay, let me write it down to loop. Again, if we use the step 2 here, step 2 here means that we are going down decreasing order and we are jumping 2 numbers and from the beginning. So 10, the next it will not be taken, the other will be taken. So 10 jumping 1, 2, 8, 1, 2, 1, 2, 1 and 2, and then so the numbers that the loop will iterate, or the values of I in this iteration in this loop, would be 10, 8, 6, 4, 2, and only these numbers. Okay, down step 2, down DownTo loop. Okay, so we have covered the almost all the ways that iteration and the loop works in the normal mode and the stepping 2 by 2, and then we covered it inversely, like going down to, we specify that the numbers are in decreasing order, and we have learned that it is, we can use step 2 and jumping 2 numbers by 2 also in decreasing number. So this is the loop. This is the for loop. And we have learned the down to, the step, and how we work with. In this video, we're going to continue with the advanced control flow, and we will learn about the nested loops. So what are nested loops? Nested loops are simply a loop inside loop for specific targets and a specific goal. What are these goals? Imagine that despite making a loop that prints like these numbers from 1 to 10, you need to print a table like this, from 1 to 3 and 4. I need to print this. And again, I need to print 1, 2, 3, and 4. I need to print this table. And I will copy, paste. Okay? I need to print this table for specific reasons. Okay? How to do that? I will not create a loop here, and then a loop here, and then a loop here, and then a loop here to loop through these numbers. I will create one loop. Inside it, there is another loop that will take care about these conditions. So, first of all, I need to clarify very important thing. So let's analyze this example. In the ordinary looping, in the one loop, in one iteration, we are going using the I. So I index will go through 1. It is increased 2, 3, 4, 5, 6, 7, 8, and 9, 10. So we have used the index I. So the index and this iteration have been increased one time every loop. Okay? In here, we have a different scenario. If we need to print this table, okay? If we need to print this table, we need to start and segment our table into two things: the columns and the rows, okay? These are the rows and these are the columns. There is a very important step that think about the rows as a ordinary iteration like this. So for that, I need to use I. So I will loop through the rows, okay? Think about this. So I will loop through the rows. I for rows. How many rows I need? I need to make 4 rows. So I will be from 0 to 3. Okay? Now, how to print the column? I need to make a loop and think about a nested loop, another loop inside the loop. So every row, the same is repeated. So I need to make a loop every time would be executed and make this list as a row. So it will continue 1, 2, 3, and 4. Okay, so it will loop through the 4 numbers. Okay, so here I will create it as J. So J is in blue. I will make J here. So J will be equal and loop through 0 to 3 because 3 is included. So 0, 1, 2, and 3. Every time I is increased, J will be printing the same thing into the table. Okay, so when we move one row, a column will be executed. So a loop will be executed till the end. So when the second loop ends, we go to the first loop and make this. Think about it as a big loop. Inside it, there is another loop. So this is the outer loop, and this is the inner loop. Okay, this is the inner loop. Now, despite using these theoretical things, let's go to the code and see how this works. So we need to print this table inside the nested loops. So I will create a for loop. This is the outer loop, and I will name the constant as a row. So in 0 till 3, as I told you, okay? Because I need the 4 rows, I can start 1 to 4, okay? But the index in Kotlin and other languages like Java starts from 0, okay? This is better. So 0, 1, 2, and 3. These are the rows. Inside the rows loop, I need to create a for loop, another for loop, and make a constant here called column. So this will represent the column, and the range is also from 0 to 3. Okay? Okay, guys? It's very simple. Now, I will create here, I will print like stars. First of all, I will print stars, and then I will show you how to replace the stars and asterisk with the numbers. Let's run and see. Okay, I need to print ln here. Let's run again and see. And here we go, guys. We have a box of 4 rows and 4 columns printing the stars. How this works? It starts from the outer loop and still executing. Okay, row is equal to 0 now. For column, it starts with this 4. When it ends from this 4, it will print a new line, and again it will go up and check for the condition. We go through this through this nested loop, and we see that inside the inner loop there is a for loop telling us there is a constant called column, and its range is between 0 and 3. So what we will do, it will print a star. So it printed a star, okay? Again, it will go and print another star, 3 and 4. 4 stars are printed, so we have finished from this for loop. It will execute a print line, and this is what happened. We have printed 1, 2, 3, and 4 stars, and we go to another line by print ln. Now we need to print again. Going up, it checks rows now equal to 1 because it is increased by 1. This is Kotlin, how Kotlin algorithm, and we have learned it before in the loops, that inside the for loop it will increment by 1 unless you put here step 2 or step 3 or step whatever you want. But if you don't specify the step would be 1 directly. Okay, so row is now 1. 1 is between this range 1, yes, between 0 and 3. So continue. Now go and print again 4 stars and print a new line when you finish. Okay, printing 4 stars and then printing a new line when you finish. I is now equal to 2, or row is equal to 2. It is between 0 and 3, yes. So go and print 4 stars and print a new line. So 4 stars and print a new line. Again, it's going up. So row is 3. Is 3 is between 0 and 3. Yes, it is inside it because 3 is inclusively included when using the range, the 2 points. This is the closed range that we have learned in the ranges lesson. Printing again the for loop, which is the 4 stars here, and printing a new line. Going up, row is now equal to 4. 4 is not between 0 and 3, so stop executing this for loop, and occasionally this is stopped with a program and printing 4 rows and 4 columns. This is how nested loops works in Kotlin. Now we need to make this table like accurate and the same way that is printed. So how to make this? I will make sum equal to 0. So after we have learned about the nested loops and how they think and how they work, so I will create a variable called sum. The sum, let me check. Okay, and there is nothing above. Okay, so for 0 and 3, we will remove the print here, and I will make sum plus equal to row times to column sum. Or maybe I will not make this at first time. Let me keep it for the next exercise. I will print the multiplication table. But till now, I need to display this. So I need to print the columns. Print column. Okay? Printing the column. You can specify it with like this. And let me run and see. And here we go, guys. We have created it. Now, if we need to change the zeros and start from 1, we just make this range because we are printing the column variable. So I need to change the column variable. And here we go. We have this box 1, 2, 3, 4 and 4 columns, 4 rows. Okay, so this is about the nested loops. In the next video, we are going to make an example about the multiplication table, and then we will learn about the continue keyword. Well, hello, my friends, and welcome to exercise number 2 in our Kotlin course. So we are asked to print out the multiplication table like this below. We have numbers 1, 2, 3, 4, 5, and as column 1, 2, 3, 4, 5, and here is the result of multiplication 2 by 2, row times column equal to 4. If we get 5 times 5, we will have a result of 25. And so, how to make this? Please pause the video and think about it and try to write it in your computer and test it. And then let me show you the solution. So I am waiting you guys. So you guess it, you try it. Let's start with solving this exercise. I am going to show you how to think and how to make your algorithm works fine. The things that we succeed in approaching millions of people, like in our applications, like master coding application on Play Store, or whether the Udemy courses that complete Java or the complete Android developer course on our Udemy pages and our YouTube, is that we teach algorithm. We teach how you need to think, how to solve, how to problem solving all of your exercises, problems, and many things. So we are helping you in developing your thinking, your algorithm, your problem solution, problem solving techniques with these courses. So please, guys, take into consideration that these exercises are very important, and to take notes are also very important thing. How to solve this? We start and we look that we have one row, second row, third row, and it is repeated. So the rows are repeated, like 1, 2, 3, 4, 5. We have iteration. So we have a row iteration. And we look that there is a column iteration. So we are working from column 1, 2, 3, 4, and 5. Okay, guys? So this will trigger for in our brain that we need to use the for loop. But there is one trick that we have to use the nested loops. If we use the loop, the for loop, we can print only like this line, or we can print only like this line, 1, 2, 3, 4, 5. Okay, or we can print like this, 1, 2, 1, 2, 3, 4, 5. Okay, this can be printed with using one loop, and this will be printed using one loop, but we don't need like this. We need a table. So always when you have a table, use a nested loop. So we start for, we make a row as in a constant, and in 0 on 0 to 4, because we have 0, 1, 2, sorry, rows 1, 0, 1, 2, 3, and 4. Okay, again I need to print a for loop, and I will call the constant column, and it is in 0 also to 4. Okay, now what we need to print inside every cell, so we have here an access to the cells, so each cell I need to print it out. What we are going to print? We are going to print the row times the column. It will give me the result in this cell, which is 25. So how to do that? We start by creating a new variable called sum equal to 0. Okay, so var equal to sum equal to 0. And now let's create a sum equal to the row times column. Okay, let me clarify something new. Sum plus row times column. It's the same writing, the same syntax, and I showed you in the previous video how to make the syntax works. So plus equal is the same as sum equal to sum plus row column. We are making an update every time to the sum variable, so the new sum is equal to the old sum plus row times column. So sum is equal to 0. Let me go to the first one. 2 times 2, it is equal to 4. But sum is equal to 0. So 0 is equal to 4. Sum is equal plus column times row equal to 0 plus 4 is equal to 4. 2 times 3 is equal to 6. So 2 times column. Okay, and so on. Okay, guys, we have introduced the sum as 0. Okay, so you can write, if we hover it, we replace it by plus. Now we need to print ln the sum. Okay, and when you finish from the loop, from the column, the first printing the first row, go to the second row by making a new line. Okay, okay, guys, so let me run and see. And here we go, guys. Oops, I have used print ln. Let me run and see again. Okay, let me pause. So we have some errors. How to do that? How to check them? I need to print the sum with the spaces and the variable sum. Okay. And let's print out and see the result. Zeros, zeros, and here. So if I print the sum is not equal to plus, let me check. It's equal to product. Okay, so row and times column. We have zeros here and zeros here. This will be because we have started from 1. Let me change it from 0 to 1. And here I need to change it to 5. So I start, despite starting from zeros, I will start from 1. So let me run and see. And here we go, guys. We have this table have been verified correctly. So despite using this, I will create a variable called the product. Sorry. And it is now good. Product. Okay. So we have created this table of multiplication. 5 times 3 is equal to 50. Okay, so in this way we have solved exercise number 2, which is creating and printing out a multiplication table. So we have created it, and we learned that how to solve the product by changing the zeros to ones, because we need to start from 1 times 2 times 3 times 4 and times 5. Thank you, guys. See you next exercises. Sometimes you would like to skip a loop iteration for a particular case without breaking out the loop entirely. You can do this with the continue statement, which immediately ends the current iteration of the loop and starts the next iteration. The continue statement gives you a higher level of control, letting you decide where and when you want to skip an iteration. So we have seen in the previous video how to make the multiplication table in the exercise number 2, and now we need to make the iteration table, but we need to skip these lines. Okay, so how to do that. We have said that it is a nested loop, okay? And it is going to make the product and give us and print it the result here. We need, for skipping the iteration, I told you that we need the continue keyword. So I have deleted the number 2 and number 4 rows, which are even. So I'm going to check if the row modulus 2, which is checking for the even and to parity, if it is equal to 0, use the keyword continue. So this continue will make check for the row, is it equal to 2, which is checking for the parity. Modulus 2 equal to 0. So if we divide 2 over 2 is 1, so the remainder will be 0. Row modulus 2 would be equal to 0 when the case equal to 2, when case equal to 4, when case equal to 6, 8, and so on. Okay, so this is how we check for the parity, and for that we continue. Otherwise, we are going to make this happen. Okay, so let's run and see the program. Please rate us 5 stars on Udemy to support us making new videos. Okay, so here we come, guys. So when the first row is printed correctly, when we came to the second row, which is 2, so when the row modulus 2 equal to 0, we continue. So we have skipped this iteration. So this will not be executed. It increased row, but didn't increase the column. So, and increase and execute this in the row modulus 2 case. So, guys, when row equal to 2 or when the row is even, we used continue. Continue will continue making the loop but skipping the current state. So when the row modulus 2 equal to 0, when there is an even, go and skip this whole thing and go up, and row now equal to 3. 3 modulus 2, is it equal to 0? No. So execute this. Row equal to 4. Row equal to 4. 4 modulus 2 equal to 0. Yes, continue. So skip all of these and go up, put a row equal to 5, and so on. Okay? So when the row modulo 2 equal to 0, the row is even. In this case, continue makes the for loop skip to the next row. The break statement you saw in the last video used with the while loops also work with the loops, for loops, and takes you to the next statement after the for loop. Just like a break, the continue keyword works with both for loops and while loops. So you can use continue with for and the while loops. Okay? Here we have introduced and learned more about the algorithm of the loops and how they works, and we have introduced the new keyword called continue. What's up, guys, and welcome again to the complete Kotlin course. In this video, we will continue with the advanced control flow, and we will learn on something interesting called when expression. You can also control flow via the when expression. It executes different code depending on the value of the variable or the constant. Here's a when expression that acts on an integer. Val number equal to 10. Okay, we use when, so you can make this when, and we specify here the number. I am making an execution on when, on an integer or number. So when it is 0, make this print ln it is 0. When other, make this print ln non-zero. Okay, it's very simple. Let's run and see. And here we go, we have non-zero. So it works. So when we use when keyword, we are checking for the state of the past thing, variable or and a variable or constant. So think about it like a switch. When we have this number, when we have 0, make this. Otherwise, when we have anything rather than 0, go and print non-zero. Okay? So the purpose of when expression is to determine whether or not a number is 0 in this case. But it is not as simple as this. I promise you to get more complex. Yes, to handle a specific case, you add the value followed by dash and this diamond shape, this flash, okay? And making this arrow. So it is like an arrow. So this arrow followed by which indicates the code that will be executed if the condition is met. So if I change the number is 0 and try to run it, it will give me the code needed, and besides this arrow, it is 0. So when the condition 0 is met and is satisfied, it will execute this line of code. Okay, and this is what happened now. Then you see how the else configuration can be used here also. So if and else are the conditional statement, and you can use them with using else with when. Okay, unlike other languages such as Java, there is no need to indicate a break statement in each branch, as the when expression will only use the first matching branch and then return. In Java, we use the switch, and in all cases, we need to put a break statement. Unlike Kotlin use this smart and very fast thing that we can make by specifying only the condition and this arrow and what we are going to execute when the condition is met. Okay, so it's very simple, it's very logical. It is like a switch that I said to you. If you have any prior example experience with Java or other languages. Okay, now let me make it adding some complexity to it. So I will change the val number to name. Okay, and I will name it as master. Okay, so or Udemy. I am checking for the case of the name. If it is equal to Udemy for multiple choices, for multiple possibilities. We can add them by separating the choices or the condition by this apostrophe. Okay, YouTube, or not YouTube, like Coursera, like Linda, like plural sign, and other print learning systems. Otherwise, if they are not included, the not learning systems. Okay, let me check. If we run and I have passed the name as Udemy, and the result would be the learning system. If I pass Coursera, it will give me the same thing because it is of the first matching states. So if you have multiple states, multiple choices of the same result, I'm going to print all of these choices, printing only learning systems, so I can use the apostrophe here, separate the multiple choices, the multiple cases by the apostrophe. Okay, so in this case, we have learned the when expression, and we see it is an advanced thing, and it is controlling the flow of the program. Hey, my friends, and welcome again to the complete Kotlin course. So we have learned about the advanced control flow, and we talked about the when expression. And by the way, we are talking about a when expression, and we have said about it as an expression. So expressions will be returning a value. Let's discover the returning values of when expression. You can also give your when expressions more than one branch. And due to the fact that when is an expression, you can use it to return a value, just like you can with if expression. You can also ignore the value if you want to just use when as a statement, as we have seen in the previous video. A when expression will return a value from the first branch with a matching argument. If you want to determine the name of the number, you can assign a value with a when expression, exactly like that we are going to do here. Okay, so I will assign a number name equal to when expression. So I am using a number here. I'm passing a number, and I will create a val number here equal to 9. Okay, I am making a constant here and assigning it to a when expression, and when we have when expression, it will return a value, and I'm going to store this value of the returning value of the when expression inside number name constant. Okay, so for that, it may be sometimes complex, but you should understand it. I will return to 3 3 5 and 9. Okay, and else print ln unknown number. Okay, this else and print ln. I need to print the number name. Okay, so what we have done, I have created a val a number equal to 9, and I have created a val number name which will be a returning value of the when expression. So it will give 2 or 3 or 5 or 9 or unknown number. These are the possibilities and the returning type of a when expression, and they are going to be stored inside number name, and then we are going to print the number name variable. Let's run and see. And here we go, guys. We have 9. So we have passed 9 number, and it checked it from here. It will return it as a string. So number name, think about it now, is equal to 9, like this. Okay. And we are printing it just as a normal variable or constant. Okay, so this is the importance of the returning type of the when expression. Okay, these are the common things that we have to do with the when expression, and we can make it more and more complex. And later on in the expressions and the exercises and the next videos, we are going to make it more and more complex. So be ready. Rate us 5 stars to continue making this course the biggest course on the earth, talking about Kotlin. And we are going to solve the Kotlin exercise. Hello, my friends, and welcome again to the exercises. So in exercise number 3, we are asked to write a Kotlin program that checks the position of a 3D point with respect to the 3 axes. So we need to create a program that checks for a point on which plane it is, on XY plane, XZ plane, YZ plane, or an ordinary point. For that, we need to create a 3D point. How to create a 3D point? We have 3 things to enter them. So we are going to use triple. This is the trick. So val, I can name it as and pass the 3 variables x, y, and z because I need to check them. Okay, so it is of type triple, and I'm making the 1. I will pass 10, and I will pass the 0 at the 3rd variable. So I create a tuple of x, y, z variables, and I need to check if this triple is on which axis. Okay, for that I will use a when expression. When this when expression, I can pass here the triple, but it is directly using the variables. So since x, y, z, since I write it like this way, I am declaring a global variable x, y, z, and is putting them inside a triple. Now I can use x as a separate variable. Okay, you see, guys, this is the power of Kotlin. If x equal to y and y equal to z, this will result in print ln x equal to y x equal to y equal to z. Okay? Now, if z equal to 0, equal to 0, this case, go and print ln that it is on the x y plane. If y equal 0, this will result in printing ln, a message telling us that this point on the xz plane or axis. Okay? If x equal to 0, this will result in print ln on the yz plane. Okay? Else it is an ordinary point. So print ln nothing special or ordinary point. Ordinary point. Okay? This is the program that will check the relationship of this triple of 3D point related to the axis. And it is on XY plane because the Z axis is 0. So it is on XY plane. Let me check if it is 0 here and if we have this number. It will result in YZ, I think. Yes, it is on YZ plane, and so on. So in this way, we have checked the point and its relationship to the axes. Okay? So, hello, my friends, and welcome again to the complete Kotlin course. In this video, we will start talking about functions. So what are functions? What are their usage and how to create them? Functions are a core part of many programming languages. Think about a function that it is letting you to define a block of code that perform a task. Then, whenever your app needs to perform and execute that task, you can run the function instead of having to copy and paste the same code everywhere. In this lesson, we will start learning about functions, how to create your first function, and how to make it complex in later videos. So, imagine you have an app that frequently needs to print your welcome screen, your name, your date, your whenever you want. Let's start by printing the welcome message. You can write a function to do that. Okay, so despite of printing every time, print ln like welcome to our course, despite of copying it every time I need to put it inside the code, I remove them and include this inside a function. So in order to start making a function, we start by a keyword called fun. Fun is the function. And I put here the name of the function, print welcome. Okay, and I pass here the two parentheses. I write here two parentheses. Till now, we don't have arguments to pass, and keep it empty. Okay, and we put curly braces. I will move this line of code to here. So our function will be like this. Fun, the keyword, the name of the function, it is print welcome, and the parentheses and the curly braces. So the code inside the curly braces will be executed whenever I call this function. The code is known as a function declaration. You define a function using the fun keyword. After that comes the name of a function followed by parentheses. You will learn more about the need of these parentheses in next lessons. So after the parentheses come, an opening brace is followed by the code you want to run in the function. So if we go up, we have seen and defined a fun and called main. This is the main function in Kotlin, and we write everything that you need to run inside it. So I will cut it and go outside this function and paste this function. Okay, so we have two separate functions. This is for the main, this is for running the program. You see this green triangle, and I need here to make the code. So I need to print the welcome message. Despite printing it like print ln, I can put it inside print welcome function. And now I need to call the function. So how to call a function? It's very simple. I just put the name of the function that I have created. So guys, look at here. Print welcome. It is now defined as a function here. So we have a function symbol here in the IDE. And when calling the print welcome, its color is changed. Its color is changed from not used to used. So when it is yellowish, it will be like indicating it is a used function. So let's run and see. Waiting for the Kotlin for compiling. And here we go. We have welcome to our course. Okay, what happened here is we are calling the function print welcome. So inside the main function. So it goes here and execute all the codes that we are needed to put it inside the curly braces. Okay, so despite putting this like here and run the program, we can use the function to call the block of code and be executed whenever we want. This is a very simple example, and this is not mainly the target and the purpose of the functions. This is very simple. The purpose is for complex things, the code boilerplate. We don't need, as a professional coders, to write the code every time, and copy paste every time. If you want, if we ask it to write print ln many times and in many ways, so I just call print welcome method and it will make the function and trigger the action to print inside the codes inside and execute the codes inside the curly braces. In the previous video, we have learned about functions and how to create a function that prints a welcome screen. And we have called the function in the main function. And we run the program and we have the following message has printed out to the screen. Welcome to our course. Now, if we need to make a customized message like if the user logged in. And we need to say hello and welcome, welcome Jack, welcome Ali, welcome Abbas, welcome Pamela to our course. So how to think about it, how to make a printing message for all of these. Maybe you are thinking about making an if statement and saying that if it is if the name equal to Jack, like this, go and uh, print ln, like, or print welcome Jack to our course. This will work, but it is not a professional coding, and it will make the complexity more and more. And you are going to cover all the names of the persons in the entire world. Okay? So it is not applicable. The solution is making the function make this by a parameterized function. Okay, so how to make this? You need sometimes to parameterize your function, as we have said before. So let the function perform differently depending on the data passed it via its parameters. We said that these parameters is void and empty now, but we can pass data and allow the function to work depending on these parameters. For example, as I told you, if we need to make a welcome screen for the logged in user, I pass here the variable called name user, if you want, and I will put 2 points, and I specify the data type that we are going to work with. Since we are going to display a name of the user, so are going to use a string. Now print ln welcome Jack to our course, welcome Pamela to our course, welcome Mira to our course, and so on. So I specify here the $ of name user. Okay, so this is a variable. This now it is a variable function. It is a parameterized function. It is depending on the name of the user passed to display this welcome screen. You see, guys, above, if we have we go to the main screen and the main function, and we call the print welcome welcome function. I need here no value passed for parameter name user. There is an error. So error and preventing me from running the program. Okay, and it's telling me that there is an error. No value passed for parameter name user. I need to pass here a parameter of type string in order to allow the function to work. So I can't name user pass it as an integer. I need to pass like the name of the user as a string. Now everything works fine. Let's run and see. And here we go, guys. You see this welcome screen now welcoming Jack to our course. So welcome Jack. You see, guys, here the parameter name user is passed as a variable and displayed it to the message. So we have allowing the function to perform differently depending on the data passed. If I pass here like Ali and run, we have different behavior. Welcome Ali, not Jack, or not the constant thing. Okay, so this is the powerful and the power of parameters inside the functions, and we are going to work with these functions with parameters many times, and covering all of our projects, all of other videos. And it's very important topic in programming languages and especially in Kotlin. Okay, now let's make some complex parameters and allow it to take a multiple parameter. So this function would be more complex by passing multiple parameters. So if I want to pass like rating, I name it rating and of type int. Okay, I'm making a rating here and passing it as an integer. Welcome to our course. You rated your rate is, and $sign rating. Okay, so I am passing a new parameter called rating of type integer, and I am going to display it within the welcome screen and welcome message. So welcome Jack to our course, your rate is 5, for example, and welcome Ali to our course, your rate is 6. Okay, and you see guys here there is an error, so no value passed for parameter rating. I have passed a parameter for the argument Ali, but I didn't pass any of the rating. And you see guys, in the IDE, this is passed, and now you need to pass a rating of type integer. I can't pass a string because it will give me an error. So the rating would be like 8/10. Okay, so the rating is, or 5. Your rate is stars. Okay, let me run and see. And here we go, guys. You see, we have multiple parameters. Welcome Ali to our course. Your rate is 5 stars. So you see, this is the second parameter and this is the first parameter. Okay, these are the parameters. These are the arguments of the function. So when we have, sometimes it is helpful to use named arguments when calling a function to make it easier to understand the purpose of each argument. Okay, so Ali is named as name user. So the IDE IntelliJ is naming this. It will give you a naming like name user and rating to help you to detect and remember what the type of the parameter. Also, what is the parameter you are going to pass in order. Okay, so this is the parameters in a function. This is the concept of it and how to use the functions and the parameters. And it is very helpful. We are going to make things more complex, but we are going to simplify it with step-by-step teaching. All of the functions you've seen so far have performed a simple task, like printing a welcome screen. Functions can also return a value. The caller of the function can assign the return value to a variable or constant, or use it directly in an expression. We have seen this concept in expressions, and we have used it in the if expressions and in the when expressions. This means you can use a function to manipulate data. You simply take in data through parameters, manipulate it, and then return it. Here's we are going to demonstrate how to return a value from a function. Okay, I'm going to remove this function. This is for printing a welcome screen, but I'm making a complex function that will make a multiplication. So multiply numbers, and this function will take number 1 or x, it is equal to x, and of type integer, and the second parameter would be y of type integer. Okay, and we start by return. We have a return function, and the return keyword. So when you need a function to return a value, even a string, number, boolean, or whatever you want, you need to use the return keyword. So I need to return x times y. I need to perform this action, okay? But there is a type mismatch, required unit found in, okay? There is a unit, and we have seen that unit is not, it is like void in Java. For that, to prevent this, I need to tell the compiler that, hey, I need to return an integer from this function. You see, guys, that the error has been removed. I'm returning a result of 5, example 5 times 5 is 25, and it is of type integer. Okay, so I need to tell the compiler that this function called multiply number, having this parameter, it will return integer. Okay, so this is how we tell the function to return an int or a returning value. I need to also to make a return keyword and put here what we are going to return. The value of the returning thing would be and must be exactly matches the same type that you have declared. So I am telling here a function multiply numbers having these parameters will return a type integer. I can't return like a string hello, like. So this hello, it is a string type mismatch required int, because I tell the compiler to allow it to make it as an int. I need from this function to return for me as an int. And it is founding a string, returning type a string. So this is at the compiling time, compiling time will make an error telling us that there is a mismatch in type. So the solution is to make and pass the correct data type that matches with the returning type we have declared for the function. Okay? Now, I need to call the method here. As I told you, to call the method, I need to call it directly. And I need to pass, you see, guys, x, int, and y here. I need to pass 5 as x and y as 5. Okay? Now, let's run and see. Nothing will happen because nothing will be printed on the screen. 5 is passed and 5 wipe is passed, and the calculation is performed, but nothing will be displayed because we didn't make any print on the screen. So for that, I will store this inside a val equal to result. And this result is calling the function multiply numbers. Now, inside the main print ln the result. Okay, let's run and see. And you see, guys, it is printing our multiplication of x and y. 5 times 5, 25. It stored it inside a result. Now val result is equal and storing result of this multiplication operation, and it's printing it again on the screen. So this is what we have talked about, the expression storing the result of this function. It is returning an int. So it is a returning int. It's returning int. I have stored it in a val called result. And this result is of type int. Then I have printed it here. Okay. So it's very important to think and understand how functions work and how they compile and how they work with your codes. Hello, my friends, and welcome again to the Complete Kotlin course. In this video, we are going to continue with functions. And we have seen before that functions can return a value, and we can store this value inside a variable or a constant. Now, there are many thoughts, many questions that you can ask about functions and their working. I will give you a hypothesis. If I need to make a function that prints the entered value, so I can pass like I will create fun like display number, and I pass here value of type int. Okay, and display print ln welcome or you entered and display the value. Okay, you are asked to make a function that display the entered value as a number. So I call the method display number and I pass 6. Let's run and see. And it's working fine. You entered 6. Now, the question here or the thoughts, if I pass like 6, it is of type string, but it complies. The user can enter a number in string. Okay, so the letter in letters. Okay, you entered 6, but there is an error preventing me from running, and we have said there is a mismatch in the types. Mismatch inferred type is a string, but int was expected. It needs int here, but the passing string will be, or the passing value would be string. I need to create a function like display letters, and it took value as parameter of type string and print ln you entered value. Okay, and I need to change display letter. Now it works. Okay, you entered 6, but this is not the solution. I can't make many functions and call the exact function that the user will enter. I'm not with him during the runtime to tell him, hey, I need to use display letter function. And now you are using display number. There is a whole bunch of problems. The solution is by making an overloading functions. What does this mean? What if you want more than one function with the same name? This is called overloading and lets you define similar functions using a single name. So I can create display number. It's the same naming. Okay, you see guys, no error here. However, the compiler must still be able to tell the difference between these functions within a given scope. Whenever you call a function, it should always be clear which function you are calling. This is usually achieved through a difference in the parameter list, a different number of parameters and different parameters types. Okay, so for example, defining these two methods will result in, if I call it display number. Okay, now it called this method. If I pass here 6, it calls this method. You see guys the difference in the color of the naming. You see, this is called the method that have an integer value. If I pass 6 in letters as a string, it will call the display number this function. Okay, so this is called a method overloading or function overloading. Let's run and see. And here you entered 6. If I call the same method and I enter 6, let's run and see. And here we go, guys. This is the very important thing about method overloading and function overloading. You entered 6. The compiler knows here that it is a string, so it calls the second function. The function display number with 6 as a number. It knows that it is the display number, that it accepts the integer type. Okay, so method overloading depends on the type of the parameter and the number of parameters. Let me show. We have seen the type of parameter like int or string. It define and it distinguish between them. So here we have known that it is the display function. This is the function that we need. There is the second thing that method overloading works on it and detect it is function display name is the same name, display number, and I need to pass value 1 as a string, as an int. I need to pass value 2 as an int also. And here print ln you entered value 1 and value 2. Okay, you see guys that we have defined the 3 functions, one for and with same name, one having an int as parameter, the second is the string parameter, and the third having 2 parameters of integer type. And only one is called because we have defined this function, and I'm calling this function above. Now, I will call the display number here, display number. And we have, for the IDE, we have three possibilities. I can pass an int, I can pass a string, or I can pass two integers. Okay, I will pass 14, and if I pass the second parameter, it is a very smart IDE. It removes value, it continues with int, but we have, this is the possibility, the bigger possibility to enter a second number. So value 1 and value 2 is entered. Now let's run and see. We have called the first method to be entering 6, and the second method is passing 14 and 7. So you entered 14 and 7. Okay, this is the importance of overloading. The methods above or here have the same name, perimeter types of number of and the number of parameters, but we have here different number of parameters. So as I told you, method overloading depends on the type of parameter. Please write them down. Method overloading, please write this node down. Overloading depends on one type of parameters. The second thing is the number of parameters. Okay, this is how the method overloading works. Well, hello my friends, and welcome again to the complete Kotlin course. We have learned about functions, the returning type of functions, and how to make parameterized functions. And also we have learned about overloading. Now we are going to work with functions as variable. This may come as a surprise, but functions in Kotlin are simply another data type. You can assign them to variables and constants, just as you can any other type of value, such as an int or a string. To see how it works, consider a function called add. So func add, it took x as an integer for the first parameter and y as the second parameter of type integer. Okay, and it will return here, an integer. Okay, it will return x plus y. Okay, it's very simple. The returning type is an integer, yes, because y plus y, int plus int will result in int. So the returning type complies and exactly matches the declared and the integer in the returning type of the function creation. Okay, this function takes two parameters and return the sum of their value. You can assign this function. First of all, before we assign, if we need to call this method, add 4 and 5. Okay, so it will add them. Okay, but we can assign this function to a variable using the method reference operator. Let me write it down. Method reference operator. It is denoted by 2 points, 2 points and 2 points. 4 points you can make. Look like so. Okay, now how to use this. Here we can make a var variable, and I call function, I name it as function, and I assign it equal to 2.add function. Okay, here the name of the variable is function, and its type is inferred as int. You see, guys, this is the function, the variable, and is inferred that its returning type is inferred as int because this function add has two parameters from f, and int will return an int, so the returning type of this function would be an int. Okay, from the add function you assign it. The function variable is of a function type that takes two parameters and return an int. Okay, we have assigned, we are telling that this variable called function is of type function. Okay, let me rename it as v or t. So the variable t now is a function type that takes two parameters of type integer and return an int. It may be sometimes be confusing for you, and especially if you have an experience in Java or any other programming languages. But please concentrate with me. I have created a function containing two returning types, returning type of integer and two parameters. This would be stored inside a variable, and it is transforming, not storing, it is transforming the function into a variable. Now I have created a function, a variable t of type function add. Okay, so this is the method reference operator, two dots. Okay, and I am referring it now. T is a variable that takes two parameters. You see, guys, we need to pass x and y, 5 and 5. Okay, this is how we can call this variable. Now you can use the function variable in just the same way you had used the add function. Okay, now to print it, I need to just print t. Let's run and see. Oops, print t. It's returning type and what result. Okay, I will remove this, and t now is the returning type of the function. If we have seen that function add Kotlin int and Kotlin int, and it return an int. I need the fact that you can assign functions to variables come in handy, because it means that you can pass function to another function. How to do that? This will make some confusion to you, but it is very simple. Okay, I will create a method called here function print result, and I pass t, the variable that we have created, of int and int, and we need to make this as an integer, to be passed an integer as a returning type, and we have a as integer and b as an integer. So we have passed 3 parameters, 1, 2, and 3. Okay, what does this function makes? It will store inside val result equal to t of a and b. Okay, I am calling this method t, which is a function variable, and I'm passing this variable 1 and the second variable inside its parameters, and then I need to print result. Okay, and the print result would be passed here. I will call it in the main function. So print result, and I pass here the data, I need to create it first, the variable t. So variable t is a function variable, and now print result, and I need to pass the reference. So here I can put add, or I can pass t. Okay, 4 and 2. Let me run and see. And here we go. We have the addition takes place. How? Let's make a recap. We have created a function add. I have assigned it to a variable. I have created a function variable that the method reference operator is assigned to it. So this variable now is called t, is a function having 2 parameters and return an integer. And I have created another function that took this t, this variable, this function variable. The second one, the second parameter is an integer, and the third parameter also an integer. Now I create a val result t, a, o, and b. So this will make addition of the second parameter and the third parameter using the function variable called t. So I'm using this variable, this first parameter, and I have passed in the side the first parameter a and b as its parameters. It is think of about it as a nested parameters. So function inside a function. So I'm having a variable. Think about it as a function, a normal function having variable a and variable b as parameters, and returning type of it will be an integer because we have defined it here, and we stored it inside the result variable, and we have printed it. We call inside the main function we have created the var t. This is the method reference operator telling that t will act as add function, and the print result passing the function variable, the a and b variables, and took place the addition operation and printing out. So it's very simple. It may be confusing, but we are not going to use this many times and many things or many ways that we can directly make a function and call it without using a method reference operator. But we should mention it to make it very simple. Thank you, guys. I hope you rate us 5 stars on Udemy and support us in many fields by comments and a like. Hello, my friends, and welcome again to the complete Kotlin course. In this video, we'll start learning about something called nullability. So all the variables and constants you've dealt with so far have had a concrete values. When you had a string variable like var name equal to, let me say, Jack, you associated a value to this name. And if we remove this, we have instantiate it with empty name. Okay, no name, but it have a value with a no space and no characters, but it have a value. This is the difference between var name, var equal to var name equal to empty string, and var equal to null. So what is null and what is the usage of this? Sometimes it's useful to be able to represent the absence of a value. Imagine a scenario where you need to refer a person's identifying information like a name, and you want to store his person's name, age, and occupation. Name and age are both things that must have a value. Everyone has them, but not everyone is employed. So var like age equal to 29, and var occupation, maybe it is for you as a student, no occupation. For me as a developer, so I can developer. Okay, so, and the name, everyone have a name, so like Jack, 29, and is developer. But what if I become an unemployed? So maybe I have reached enlightenment and wish to live out the rest of my days on top of a mountain. This is when it would be useful to be able to refer to an absence of the value. Okay? So this will indicate, if I remove this, it will indicate that I am having an occupation. Okay? I am having an occupation, but it is not null. So if I refer as a null, it would remove all, and it will indicate the absence of a value. Okay? Null is the name given to the absence of a value. Okay? Absence of a value. And you are about to see how Kotlin incorporates this concept directly into language in a rather elegant way. Some other programming languages simply use sentinel values. Some have the concept of null value, but is merely a synonym for zero. It's just another value like zeros. But null is not making absence of a value. Kotlin introduced a whole new set of types called nullable types that handles the possibility of a value could be null. Okay? If you are handling a non-null value, then you are guaranteed to have a value and don't need to worry about the existence of a valid value. Similarly, if you are using a nullable type, then you know you must handle the null case. It removes the ambiguity introduced in using other values. So think of a nullable as a box. It either contains a value or it does not. Let me show you how. So as I told you, think about nullable as a box here, and here another box. It either contains a value or it does not. When it does not contain a value, it is said to be containing none. So here, nothing. If I put here null, it contain a value having a null. Okay, so I can't put anything here in order to introduce it as a null. So nothing. It is void. It's nothing contained inside this box. So this is nullable box containing no value. If I store inside this box value 5, so it is not null. Okay, it is not null box. It's very simple. A string or an int, on the other hand, does not have this box around it. Instead, there is always a value such as like hello or 1. Remember, non-null values types are guaranteed to have an actual value. Setting the value is very simple. We can clarify this by making setting the occupation later on equal to developer. Okay, so I have changed it by this, but there is an error here telling change type of occupation to string, and we need to make this step in order to make it nullable and allow to edit it later. Okay, this is the assertion. This is the assertion. This is the concept of changing the printing out the value of a nullable, or we have changing the value of a nullable. Okay, so here it was a nullable value, nullable variable. We introduced a string. Does not this is the string and question mark. We are going to learn more about it in the next videos. And when we change the nullable, we need to make this assertion, and we have to introduce the new value. So if I print occupation, it will give me a developer. You see, guys, how to change a value of a variable that it was initialized as a null. This is how we do. Okay. Hello, my friends, and welcome again to the complete Kotlin course. We have started the nullability section, and we have talked about nullability. Now let's check for a null. It's all well and good that nullables exist, but you may be wondering how you can look inside the box and manipulate the value it contains. In some limited cases, you just use a nullable as if it were a non-null type. Take a look that if we have created a variable called result, and this result would be of containing an integer and having an exclamation mark here, setting that it is a null, a value of nullable. And if we print ln result, this will make things happen, and we have print 30 correctly. Now, there is one another thing about this. If we add +1, what we will do? There is an error here. If we zoom in, operator call correspond to a dot qualified call result dot +1, which is not allowed on a nullable receiver result. Okay, it does not work because you are trying to add an integer to a box and not a value inside the box, but to the box itself. That does not make sense. If we remove this, we are setting that var as a result is equal to a normal value, normal variable of type int, and 30. And if we print now, it will result in 31. But if we are adding this exclamation mark here, saying that for the nullable, and it is preventing us from making this. Okay, now Let's learn about the not nullable assertion operator. The error message gives an indication of the solution. It tells you that the nullable is still inside the box. You need to remove the value from its box. It's like Christmas. Okay? So we are making a box here and we need to extract the value from it and add one to it. How to do so? If we make variable or if I need to add one to it, I make a variable uh, result plus one is an integer in and here equal to result does not equal 2 times. This is the operator, not null or assertion operator, plus 1. And now I need to print result plus 1 variable. What we have done here is using this not null assertion operator. Okay, the double exclamation mark after the variable name tells the compiler that you want to look inside the box and take out the value. The result is a value of a non-null type. This means the results plus 1 is a type of int and not int exclamation mark. The use of word assertion and the exclamation marks probably conveys a sense of danger to you, and it should. Okay, so you should use not null assertion sparingly. To see why, consider what happens when the nullable does not contain a value. So if we have var result equal to null, and I'm trying here to add one to it. Okay, there is an error. And if I need to print result directly, so your result is variable result. Okay, let's run and see. Is equal to null. But if I put here like this and I make does not equal to null plus 1, I'm adding to the result plus 1, there is an error here. Okay, so let's run and see. There is a null pointer exception telling us because the variable contains no value when you try to use it. That's worse is that you get this exception at runtime rather than the compile time. This is for the compiling time when using the IDE IntelliJ. But if you have a pointer, if a result here like equal to null and we didn't assert it, we didn't try to assert it, and check it for the nullability, it will be making and causing runtime error. Okay, so this will lead to null pointer exception. How to make this? By using the smart cast. We are going to learn more about nullability in the next videos. If you ask the user to enter his name and he didn't enter anything, the value would be as null as by default. But if you are going to display this result, you will display his name as null. This will make some problems. In order to prevent entering a nullable value or having a nullable value, and under certain condition, you can check whether a nullable has a value. And if so, you can use the variable as if it were not null. I will create variable name of type string. When you define a name of variable or create a variable name of type string, the default value is null without assigning anything to it. Okay, so the default value of any string would be null without defining anything to it. So without the equal sign, it will be null. Okay, another var name not null string, but it has a exclamation mark. Sorry, question mark. To check for the nullability, if the entered name like name or the entered name does not equal to null, I will create a variable here called var entered name equal to Jack. So I'm checking for not null by using exclamation mark and equal sign. Checking does not equal to null. Go and make the name equal to entered name. Otherwise, else make the name the nullable author, which is name not null, equal to name, entered name. Okay, I'm checking now for the not null and to prevent anything or any null pointer exception error. You will immediately notice that there is no exclamation mark here when using the nullable name, entered name. Using nullable checks in this way is an example of Kotlin smart cast. This is how the smart cast works in Kotlin. If the nullable contains a value, the if expression then executes the first block of code. This is the code within which Kotlin will smart cast the name to the entered name or the entered name to the name to a regular non-null string. If the nullable does not contain a value, then if expression execute the else condition. Okay, so you can see how using smartcast is much safer than not null assertion, and you should use them whenever a nullable might be null. Not null assertion is only appropriate when a nullable is guaranteed to contain a value. Using smartcasts for nullables is only helpful if the nullable being checked is not or cannot be changed after the null checks occur. For example, if the nullable is assigned to a var that is not changed after the smartcast occurs and before usage or is assigned to a val. So we need to check that these are the last things that for checking for nullability. Okay, this is for safety and safe casting of the variables, and these should be at the last when you finish changing the variables or for using for the constants. Okay, so this is how the checking for nullability occurs in Kotlin. We will continue with the nullability, and we are going to introduce Elvis Operator. There's another handy way to get a value from a nullable. You can use it when you want to get a value out of a nullable, no matter what. And in the case of null, you will see and use a default value. So we are going to use Elvis Operator. What is Elvis Operator? The operator used on the here to extract the nullable value is called Elvis Operator. Since it resembles a certain rock star when you rotate it by 90 degrees clockwise. So this, if we rotate it 90 degrees, it will resemble an Elvis star, rock star Elvis. Okay. Now, how to use it? Var nullable int equal to 10. Okay, I'm creating a nullable int, and now I need to extract the result and add them. Result equal to nullable int the Elvis operator and 0. Okay, this is how we use the Elvis. And what this means, using the Elvis operator means that the result will equal either the value inside the nullable int or 0 if the nullable int contains none. If this is nullable, then it will use 0. Otherwise, it will use result in equal to nullable int. Let me check this. Print result. Let me run and see. And here we go. We have printed result. So it is equal to the nullable int because nullable int is not null. If we put here 0 or we didn't assemble it to anything of type int, and we assign 0 to it, check it, it will return also 0. Let me check, it is 5. Let me run, and it is 0 because we have int, var int is not null. If we put here null, okay, if we assign, cannot be assigned to an int. If we don't assign anything to this, null, and remove this. Now let's run and see. And now result equal to 5. So it checks if nullable int is null. Oh, it is null. So it will remove this side and took 5 as a result and assign 5 to the result. If null int, in case it is equal to 10, it is not nullable. Yes, it is not nullable. So go and put this result the same as the nullable int. So it will print for us 10. Okay, so this is the importance, and this is the usage of the Elvis operator. Well, hello my friends, and welcome again to the complete Kotlin course. So far, you've mostly seen data in the form of single elements, although pairs and triples can have multiple pieces of data. you've limited to combining only 2 or 3 items with them. In this section, we will start learning about collection types in Kotlin. Collections are flexible containers that let you store any number of values together. We will see the arrays, lists, map, sets, lambdas, and in details. So we will start in this lesson with the arrays in Kotlin. Arrays in Kotlin correspond to the basic array type available in Java. Arrays are typed just like regular values and variables and constants, and store multiple values in a contiguous portion of memory. Before we create your first array, take some time to consider in detail what an array and why you might want to use one. So, what is an array? An array is an ordered collection of values of the same type. This is very important. It is a collection of values of the same type. You can't make an array that contains strings and integers. Okay? The elements in the array are 0 indexed. So the first element is Ali in this array of strings. The first element in the array is indexed 0. So Kotlin start with element 0, just like Java, which means the index of the first element is 0, and the index of the second element, Bob, is 1, and so on. Okay? This is very important note. Knowing this, you can work out on that the last element's index is the number of values in the array less than 1. So we have 6 elements in this string array. The index is 6 minus 1, which is 5. Okay? All values are of type string, so you can't add non-string values like integers inside this array. Okay? So when are arrays useful? Arrays are useful when you want to store your items in a particular order. You may want the elements assorted, or you may need to fetch element by index without iterating through the entire array. Let's go to our IDE and let's see here how to make the array. Okay, the easiest way to create an array is by using a function from the Kotlin standard library called array_of. This is a concise way to provide array values. We start by, I will store it inside a val, like odd numbers equal array_of. When you see array_of, so you are creating an array. Okay, since the array only contains integer, Kotlin infers the type of odd numbers to be an array of integer values. This type is written as array int. So if we click on control and hover the mouse, let me show you how this works. Kotlin, if we hover the mouse, array_of, you see guys this array and t. So array t, this is in the generic that we are going to discuss it later in the generic. So the type inside the angle brackets defines the type of values the array can store, which the compiler will enforce when you add elements to the array. This is called type safety, and we will see them in the generics, that to provide compile time error, and not runtime error. Okay, so it will indicate if you add here, this will be used if we add here a string called Ali or hello. Okay, this will make an error at the compile time. Okay, this is the type safety that we are going to talk about it inside the generics. So you see, guys, when we hover also on the odd numbers, it is of type int. It's telling Kotlin that it is an array of integer. The syntax of the array type is an example of a type argument or generics that you will learn more about in the later sections. It's also possible to create an array. Let me show you here how to print it. We start by print odd numbers. Let me run and see. And here we go. We have printed the index. So this is how we have some errors, and you may encounter these errors. These are not errors, we are printing the index. So this is the index. At is the index of this variable inside the memory. Okay, so prints dot, we can put get, iterator, set, and so on. So we need to make this works. So we are going to learn it in this video. So it's possible to create an array with all of its values set to default values, like val. I need 6 sixes. Okay, I can use array, and I specify here I need 6 elements of this. Okay, so this will print, or this will result in 6, 6, 6, 6, and 6. Okay, this you will learn more about the syntax in the section lambdas. So this is one of the lambdas that we are going to use. Okay, as with any type, it's good practice to declare arrays that aren't going to change as constant using val. For example, if we are going to create a constant array that contains like vowel letters array of, and we specify here a string or like A, E, I, U, O, U. Okay, these are constant because they are not going to be changed. And vowels is an array of strings and its type cannot be changed. Okay, but one important note, that when using array of, we are creating no non-primitive data like this. So if we use array of and use 1 and then we insert 1, here 1 is represented as an object, because if we see the array of type t, this is t and it is of integer, of object call of type integer, and not a primitive data of integers. When using array of and creating arrays with types such as array int, the resulting array in a list object of types. Okay, in particular, if you are running on JVM, Java Virtual Machine, the integer will be boxed inside integer class. This is called boxing and in unboxing. Okay, so using the primitive types over their boxed counterparts will consume less memory and result in better performance. Unfortunately, you cannot use primitives with list. Okay, we'll talk about the list in the next video. So the Kotlin standard library contains function other than array_of that makes it possible to create arrays that correspond to arrays of primitive type. For example, if I want to make the same array here, but for primitives, so val even numbers equal int array of. Okay, see guys, int array of. We store 2, 4, 6, 8, and so on. When running Kotlin on JVM, the even numbers is compiled to a Java array of int array. This will result in compiled in int array, while the first one is compiled of array list of type integer. Okay. Other standard library functions include float array of. You can see float array of is the same. Okay. Double Boolean array of, and so on. So these are the primitive data arrays, and you can make an array, but this is of array of objects. Okay, so using array of deals with elements are as objects, while int array of deals with it as a primitive data. And this is more faster, and we are recommending using int array of despite array of when using primitives like integers, char booleans, and so on. Okay, lists, a type that is very similar conceptually to an array. Like Java, the list type in Kotlin is an interface that has concrete realization in types such as array list, linked lists, and others. Arrays are typically more efficient than lists in terms of row performance, but lists have the addition feature of being dynamically sized. That is, arrays of fixed size. This is the very important note between the list and the difference between the list and arrays. Arrays has fixed size, while the list has a dynamic size. So you can grow up and shrink the list as needed, as you will see in the mutable list later on. So how to create the list? We go to the IntelliJ and we start creating our list. Let me go up. Okay. So, like arrays, we start with a val. We are storing an array, a variable, storing a list inside a variable, and we assign it. So, like the arrays, the standard library has a function to create a list. Okay, like planet list equal to list of, like an array of. You see, guys, array of, we have used it with arrays. We start with list of, and we specify here, remove this, and Mercury, Earth, and Mars. This is, we have how to create a planet list using the list. The type of inner planets is inferred to be list of string. We have seen that here we need to put the angled brackets, this diamond shape, and we need to specify as a string. But thanks for the latest updates of the Kotlin, that we can detect, or the Kotlin detect directly that it is a list of Mercury. So no need to put and insert here the type parameter, which is a string, inside these diamond shaped angled brackets. Okay, so it directly knows that it is a string list. So this is an array list in Java. Okay, list of string. You see, guys, it is detecting it as a list of a string. Now, if for some reason you explicitly want to make array list, to have the type array list, there is a different standard library function that you can use, like array list of. You see, guys, array list of. Okay, so we can make this also in an array list, but we prefer making it list of. Okay, as or an empty list can be created by passing no arguments to the list, because the compiler is not able to infer a type from this. You need to use the type declaration to make the type explicitly. Empty list, call val empty list equal. We need to infer type, because we are not detecting, the compiler will not detect what is the type of the list he is going to do. So I'm going to tell him that I need to make a list of strings, okay, equal list of. Okay, this is the function that we are going to use to create an empty list. You could also put the type arguments on the function. Okay, like list of, can make like this, remove this, and we put list of here as string. Okay, so we are creating an empty list of strings that we are going to add and learn in the next videos how to add data inside the list and remove them. Okay, since the list returned from list of is immutable, we won't be able to do much with the empty list. Empty lists become more useful as starting point for a list when they are mutable lists. So what are mutable lists and how to make them? We start, once again, the standard library in Kotlin has a function to use, is called mutable list of. Okay, so I will remove this and make mutable list 1. Okay, this is called mutable list of. We see, guys, we are using the functions of the standard library. I will start by using 1 here and 2. I'm making a mutable list of strings having 2 elements, 1 and 2. Okay, you have made this mutable list number 1 a mutable list just in case you are going to discover more and add more mutable elements inside this mutable list. You can create an empty mutable list by passing no arguments to the function, or you can make like this. I can remove them and I need to make, a mutable list of, and we pass the type of data that we are going to make the list. So this mutable list one is going to be a string list, but it is empty. Okay, so this is empty list, but it is of type mutable list. Mutable lists. Okay, so the mutable list have the capability of a dynamic addition, insertion, deletion, and iteration, and so on. Okay, but till now I will make it having 2 elements. Okay, this is very simple. We will learn in next video how to access elements, how to add elements, and so on to the lists. Being able to create arrays and lists is useless unless you know how to fetch values from them. In this video, we are going to learn the several ways to access the elements in both arrays and the lists, and they are very similar. So what it is applicable for a list is 99% applicable to the arrays using the properties and methods. So accessing elements here, one, using properties and methods. Imagine you are creating a game of cards and you want to store players' name in the list. The list will need to change as players join or leave the game. So you need to declare a mutable list that we have learned before. Okay? Like the mutable list. Okay? So I will consider this mutable list as the list that we are going to access its elements and to work on it. Before we start the game of making it, making the game for the players, we need to check if there are enough players, and for so we need to use the is empty, and it's the same as we are going to check for the mutable list if it contains elements or not. So I will start checking and using the properties and the methods for the list. So mutable list one, and we see dot, we have many properties and methods. We have add, replace, add all, remove, set, size, and so on. We are going to use now, learn about is empty. This is empty method or function is for checking if it is if the list is empty or not. It returns, the returning type of it is a Boolean. So Boolean, it will return a true or false. So true if it is empty, and false is for it is containing elements. Print if mutable list one is empty. Let's go up and run to see the result if mutable list is empty or not. And here we go, we have false because it contains 2 elements, 1 and 2 as strings. Okay, this is the first method we are going to talk about it. The second method that we are going to talk about it is the size, and it is it is not a method, it is a property. The list is not empty, but you need at least like 2 players to play the game. So you are going to use the size. And again, if you need to make and get the size for like checking for certain reasons like a game, we use dot size. So let's go up and see how it works. Let me print ln, print new line, and print line, run again, and here we go. Is checking for it is not mutable, not empty, the mutable list one, and we have two elements. You see, guys, mutable list dot size contains two elements, and it is correct because this is the first element and this is the second element. Okay. Now we will continue with properties and method, and we are going to learn about the first method. So imagine that the list that you are creating, we need to get the first element inside it. So print ln mutable list dot first. So we have a method called first, and I need to get the last element. So mutable list dot last element. Let's run and see. You see, guys, that the first one and is for empty. The size is the second line, and the first element inside the list is 1, and the last element in the list is 2. And this is correct because this is the list that we are going and that we are performing our actions on it. Okay, so this is for the methods and properties. Now let's use the indexing to indexing. The most convenient way to access elements in an array or list is by using the indexing syntax. That we are going to talk about it in the next video and see how to iterate through the elements. The most convenient way to access element in array or list is by using the indexing syntax. The syntax lets you to access any value directly by using its index inside square bracket. So we are working on a mutable list, and it contains two elements, 1 and 2, of type string. Okay, now let's index and try to access these elements. I will create a print ln. I put here first element, and I try to put here the mutable list dot, not dot, we are not going to make the first, or we are going to use the index. So we are going, first of all, I will remove them not to be confused, and later on I will add it. I put, to use indexing, I will put the name of the list, and inside a square bracket, okay, I put the index. As I told you, in Java and Kotlin, the numbering and the indexing start from 0. So the first element inside the mutable list called 1 have an index 0. So I need to access this element. I specify the index here. Let's run and see if it is printing the last one. And here we go. It is, the first one is printing, and it's called 1. So the element 1 is accessed. Let me add some data to the 3, 4, if I need to access the third element, 0, 1, 2, and 3. So this is the third element, but it is an index 2. So I need not to put 3, I need to put the 2. Okay, so 2 means the third element. Let's run and see if it changed from 1 to 3. And here we go, we have 3. Okay, this is how we use the index to access the elements. Because arrays and lists are zero indexed, you use the 0 to fetch the first object. The indexing syntax is equivalent to calling get method on array or list and passing in the index as an argument. Another way of making this, I need to get the element, so I put here the mutable list 1, and despite putting here the index, I can put dot and I call the method called get, and I specify the index, which is like 1, which is a second element inside the method, which is the list, which is 2. Let's run and see. And here we go. This is the second element inside the array of the list, and we are going to use the get. So we have used the properties and the methods first and last to get the first element and the last element. We have used the indexing by putting it inside angle brackets, and we have accessed the element by using the get method. So we specify also the index inside the brackets. Okay, this is how we work and access with the elements. Now we are going to use the range for slicing. You can use the slice method with the ranges to fetch more than single value from an array or list. As I told you, this for the list is applicable for the array, so we can specify all of these data inside and all of these methods, we can perform them inside the arrays, but we are preferring to work with the list to be clarified. Okay, so if I need to slice, I will put here slicing val sliced equal to mutable data or mutable list dot slice. You see, guys, this is the method, and it will return the indices in iterable, and we will learn about iterable in the next videos. So if I need to slice the range from 1 to 3, and then print ln sliced. Let's run and see. And you see, guys, that we have sliced the elements from 1 to 3 included. This is the range. You remember the range? So we are using and slicing, putting them inside a variable called sliced, and we have started from 1, 2, and 3. So we have 3 values, and here we go, 2, 3, 4. Okay, this is how we work with slicing, and it is it's good method, but we are not going to use it many and frequently. Okay, now we are going to check for an element. You can check if there is at least one occurrence of a specific element by using the in operator, which returns true if it finds the element and false otherwise. You can also use this strategy to write a function that checks for given a name inside the names array. So we will start by simple typing. So if I want to check for the existence of an element inside array we start by I will print directly the error. So I am checking for let me say Jack. It will print this ln, just a normal message. And as I told you, we are going to use the n operator. So print ln if, guys, please concentrate on this writing. If Jack in names array, we are checking if Jack, the same typing, the same letters, capital J-A-K, because it's case sensitive, okay? Jack in names array. We have used the n operator, okay? Let me run and see. And here we go, checking for Jack, normal printing, and true because it found Jack inside the mutable list. Now checking for like Johnny or John. Let me run and see if it is included inside the names array. And here we go, we have false, okay? So this is the checking of an element inside the array, okay? Now, if we are going to write this inside an element, inside a function, and we are checking for the existence of the element, how to do that? We start by function is found. I pass a parameter name of type string, and it will return a Boolean. Return name in, and you specify here if I need to is found to check the name inside this array, so I need to pass this array also. So I'm going to make names array of type array of string, okay? Names array, and I will name this as array1. So this function is very important because we are checking the existence of a given name inside an array. So it took two parameters, the array that we are going to search inside it and the element that we are going to search for. So if I need to call inside the main function is found, so is found here, I need to pass two parameters, the name of a string and the array of strings that we are going to search for or inside it. Now I need to search for George inside array1, okay? Type mismatch, mutable list, mutable mutable list. Okay, I have modified the mutable list type parameter. Now I need to print out this to see if it is found. As I told you, you can directly put is found. It will return a Boolean, and we will see if George exists inside the mutable list array number 1. And here we go, George is not included. Now let me try Ali. Ali, let's run and see. And here we go, we have true. So Ali is existed inside the array 1 and so on. So in this way, we have created a function that checks for the existence of an element inside an array. And it's very important to learn the algorithm, like passing the name that we are going to search for and the name array, the array that we are going search inside it. Okay, so this is the in operator, and it's very simple. You can make all kinds of changes to mutable lists, such as adding and removing elements, updating existing values, and moving elements around into a different order. In this video, we will start working with the modifying of the list, and we will start by appending elements. Okay, so modifying the list would be appending elements. Okay, so if we need to add more names to this mutable list, how to add it? If we need to sign up, if you make a system for a company and you need to add new users and new subscribers or new customers, and you need to add a sign up functionality for these subscribers or customers, how to do that? You can by using the mutable list. It's very easy. You can make by calling array1 dot, and we have many functions, as I told you in the previous videos, and we use the add function. So add function, we have here two things like element and string and index of type int and element string. So we can, what does this mean? You can either put a string so it will be added directly, or we can add an index and the element inside it. We will see the both functions. Don't worry. I will add what is the name, like Sarah. Okay, I will add Sarah to the array. Now let's print the array 1, and let me see that if it is adding Sarah or not. And here we go, guys. Ali, Muhammad, Jack, Perla, Sarah. Sarah have been added to the array 1 correctly. But guys, see this, that we are appending elements. Appending is adding the elements to the last index. So at the end. Okay, so it search for the last of the end of the list, and we add it to the empty space. Think about an empty space here, and we are adding new elements inside this array or this mutable list, and at the end. So appending elements is done or takes place at the end of the list. Okay, this is the very important note I should mention to allow you understand the concept and the algorithm of adding elements. Okay, now there is another way to write this. If I need to add more elements to the array 1, as we have learned in the operators and the variables, I can make array 1 plus equal. So this plus equal means that the new element, the new array, is equal to the old array plus what I need to do. I need to insert one element again. Okay, so plus equal to let me say Carla. Okay, now let's print ln the array 1 to see if Carla have been added to the, and here we go, guys. You see Carla have been added to the names array. Okay, correctly, and we are appending. So Sarah is added to the end of the list, then followed by Carla. Okay, this is the importance of understanding the different writing of this in order not to be surprised or waste time searching for what people made or what people write their syntax. Okay, now if I need to add multiple data, how to do that? Okay, how to insert elements, how to delete elements, or how to make some modifications to this. Okay, this is the importance of understanding the data structures and how to deal with them. So in the next videos, we will start learning on the inserting elements and deleting elements and many. In the previous video, we have started modifying the lists in Kotlin, and we have learned about appending elements, and we have learned the two ways of writing or appending elements at the end of the list. But think about what if I need to add elements at specific position. So in this video, we are going to learn adding or inserting elements inside the specific position inside the array. So inserting elements, if I need not to add the elements at the end of the array or a list or a collection. And as I told you, these concepts and these algorithms are applicable for all collections inside Kotlin. Okay, so if I need to insert a new string or new name at a specific position between Muhammad and Jack, like this, or Jack and Perla, so I need to put here one like Lara. What I can do? So inserting elements at specific position at specific position or specific index, okay, is done by the add position. Remember, in the previous video, I have showed you that add here have this noting and this hint that it accepts an element as directly of type string, as we have learned in the previous video. So we have added Sarah directly, and it is appending the element. It's putting it at the end of the array, while using the second one, the second case that we can make is index int and element string. So it accepts two parameters The first one of type int that represent the index, and the second one is of type string. It is representing the element. Okay, what does this mean? If I need to insert, as I told you, Lara between Jack and Perla, the index 0, 1, 2, and 3. If I need to insert it at index 3, so Perla would be index 4. So I put here 3, and I need to specify Lara, the element. Okay? Now I need to print ln array 1. Let's run and see. And here we go, guys. Ali, Muhammad, Jack, Lara, and Perla. We have inserted Lara between Jack and Perla. Okay, guys? This is very important thing that you should understand and you should take aware of it. Okay? The first argument defines where you want to add the element, and the second one, what is the element you are going to add to the list. Okay? This is inserting element and specific index, and this is the appending elements without specifying the index. It would take place at the end of the list. We will continue with modifying the lists and arrays, and we have seen how to append the elements and how to insert elements in specific position. In this video, we will learn about removing elements from array or list. Okay? So, as I told you, our array is a mutable list of Ali, Muhammad, Jack, and Perla. These are of type string. Now, we have added Sarah and Carla, and we have added at the specific index Lara. Now we need to remove. So, you will encounter like in the company that a subscriber or a customer, we need to remove it from our database because his license is valid or is not valid, or it is expired, or he need to cancel the subscription to our company or anything. So we need to remove it from the array or the mutable list that we have stored it inside the collection of an array or a list. So how to remove this? We make the coding simple by array 1, by calling 1. This is the variable, this is the immutable list that we have, and we click in control and space. So we have these bunch of methods, and we see here there is a method called remove. So this method remove, if we see, there is an element string or an element string, and the index is deprecated in the later version of Kotlin. Okay, so remove method removes a single instance of the specified element from this collection if it present, returns true if the element has been successfully removed, and false if it was not presented in the collection. Okay, now let's try to remove Jack. Okay, and again I will print the array 1. Let's run and see after removing Jack. And here we go. Jack is absent and have been successfully removed. Let's try to run and see. As I told you, it is successfully have been removed. Now, this method does two things. It removes the element and then returns a Boolean indicating whether the removal was successful or not, so that you can make sure that the cheater has been removed, like Jack have been removed from the list. How to print this result? It's very simple. We can copy the cut and we replace it to print the result. So true, it will indicate that Jack has been removed. False, that Jack is not Jack is not presented in the list or the array and has not been removed. So true is indicating for us that Jack was in the list and we have removed it successfully. Okay, now let's try to remove Fadi. It will indicate false. So because Fadi is not enlisted inside the list or the array and it's not found in the elements that we have added, so it will remove because it not be removed and return false because it is not found inside the elements of the list. Okay, it's very simple. Now to remove an element, removing the element at specific index, we can specify it like remove at. So I will array1 dot remove at. This is the method that it is used, and here we have index int, so we specify the index int. I need to remove the first element, which is Ali. So I go down and remove at index 0. Now if we print array1 and click run, we will see that the list, this is have been removing Ali from the first. Okay, so this is how we can make the removing at specific index. So we remove an element by its value, or we can remove an element by its index. Remove and remove at are used to remove the elements from the list or the array. We will continue learning about modifying the lists, and we have seen how to append the elements, insert elements, and remove elements from the array. Now, how to update the elements. If I need to update like Perla, I need to replace it with its sister like Pamela. So I need to update the elements without removing its current state. So think about updating, like Perla need to give her account number or her subscription in your company to its Pamela, to its sister Pamela. Okay, so I need to replace Perla with Pamela. It's at index 0, 1, 2, and 3. Okay, and we have removed 0, index 0. So Perla would be at index 2. Okay, so how to update the array or the list? I specify array 1, and there is no method like this to directly make it. We specify the index of the element that we need to update, and it's very simple, like specifying what's the new value, Perla, and we specify it by Pamela. Okay, So we are going to replace Perla with Pamela. Okay? Just indicate the array element, the array name, and the index between the two brackets. If we print the array, we see that Perla has been replaced by Pamela. Okay? This is how we update the elements inside the array and the list. But there is a very important note. Be careful not to use an index beyond the bounds of the list, or your code will be crashed. Example, if I'm going to replace array 1 and having index 12, there is no index 12, there is no 13 elements inside the mutable list. Okay, we have added Sarah, Carla, and Lara, 3, and we have removed Jack and Ali at 0. So we have added 2 at 3 and removed 2. It will be 0, 1, 2, 3, 4, and 1 only 5. So 12 element is not existing. The 12th element is not existing, or the 12th index is not existing. Let's run and see. And here we go. We have an exception. So exception having the error index 12 out of bounds for the length 5. Okay? Because we have only 5 elements. 5 elements. We can't replace the element at 12 position with Pamela because this index is not existing. Okay? We have only 5 elements. We don't have 13 elements to replace the index 12 as the element at index 12 with Pamela. This is the error. This is the error origin, and we need to pay attention for this while updating the elements. Okay? One important note that I should mention this. And here, like updating the elements, if you have an ordered list or an ordered array, and you need to sort this element after like updating, like removing, like inserting, there is a method called, I will put it here, like sorting elements. Okay, so how to sort the elements? It's just by putting array1 dot sort. Okay, now let's see array1 dot or print array1. Okay, we still have this. And you see, guys, our elements or our array is sorted correctly in alphabetical order: C, L, M, P, and S. So it's very important to use like this method if you are going to sort the list or the array. So in these videos, we have learned how to modify the list, how to insert, append, remove, and update. And we have learned about the sorting of the elements. So in the next video, we are going to learn about the iterating through a list. And we will learn how to deal with data structures. So data structures are very important concepts. Every programmer needs to advance his career and need to be professional. He needs to master data structure. Okay, so thank you, guys. See you next. In the previous videos, we have learned about how to make modifications to the list and also arrays, how to append, how to insert, how to remove, and how to update elements. Also, we have introduced the sorting. Now we are going to iterate through a list. Okay, so iterating through a list. While we are going to make an iteration, the iteration means that we are going to search and loop through every element inside the list. Okay, so how to loop through and how to iterate through a list. We have introduced the for loops, and we have seen that the for loops have their specific ranges and their limits, and the algorithm how to increase and the increment of the iteration and the index. So the loops work through the indexes and the iterating numbers. But here we are going to introduce another like form and the shape of syntax for the for loop. Okay, so this is known as for each loop inside Java. Okay, now I will start by, since we are going to loop through the array1, which is a list of strings, we will consider every element inside this list as a user in, and we specify the name of the array that we are going to loop through. So I'm creating a variable called user. This is, if you see, if it is included and it is designed as a string, created as a string, and automatically Kotlin will create it in temporary memory, and it will make it as a user inside array1. What does this mean? Every element inside array1 will be treated as a user. So think about every element inside array1 is temporary for like 1 second, is called user. Okay, and this is 1 second is very long for iterating through our array. Okay, but till now, think about it. Every element inside array1 in each loop is treated as a user. So what we need from this user is like print the user. Every time, every element in array1 will create a temporary val called user. And this user will be treated and used to be printed by print user. Okay, let's run and see this modification. But first I will print ln. Okay, I will remove this. And we start by running. What we have done here is iterating through the list, and every time the loop iterates, it will start and create by a user and treat it by printing the user name. So Carla, Lara, Muhammad, Pamela, and Sarah. Okay, these are the elements of the array1. We are treating every element inside the array alone by making it and storing the element Carla inside user. Okay, this is how we work with the for loop and how we iterate through the for loop. Okay, this is very important. This is a very classical one, which be used in Java like for each loop, and we are going to iterate through every element inside the list. The same concept and the same syntax here, but without putting the in Java, we use another syntax. So for each element inside array 1, go and store this element inside a user such that we need to use this user to be used inside this curly braces. And inside this curly braces, for now, we are just printing its name. Okay? We are just printing the name. This is how we iterate through the lists or array list. And they are very important and very simple. A map in Kotlin is an unordered collection of pairs where each pair is comprised of a key and a value. So we have the keys to the left and the values to the right. Think about this map as a collection of the students. These are the students and these are the marks or the grades that they have achieved in a given exam. So if I need to store like Ali have marked 17 over 20, Muhammad 20 to 20 over 20, Jack 19 over 20, Sammy 12 over 20. I will give the keys Ali and the values the marks, okay? But what is the benefit from this data structure? As shown in this diagram, keys are unique. The same keys cannot appear twice in a map. This is a very important note. In the keys, I can't put Ali here again because keys are unique. But values, they can be like 19, 20, 20, 20, and so on. They can be duplicated, but the keys must be unique. All keys have to be of the same type and all values have to be of the same type. The keys, I can store all the keys of the same type. These are the type of strings. Also, the values should be of the same type, which are the integers. Okay, I can't store 17 and now I will write a string here. Either string or integers or any other type of object. Maps are useful when you want to look up values by means of an identifier. For example, the table of contents of this course names to their pages number, so you can make an index, making it easy to skip to the chapter you want to watch. Okay, so maps are very important. How is this different from an array? With an array, you can only fetch a value by its index. So in the array, we have given, if we go back to the Kotlin course .kt file, with an array you can only fetch value by its index. So we have an array here or mutable list, and we can access and fetch the data by its index. So we have updated the elements by using its index, and arrays, we are going to access elements by their index. Okay, so with an array, you can only fetch a value by its index, which has to be an integer, and all indices have to be sequential. In a map, the keys can be of any type that we have seen in the presentation, and are generally is no particular order. Okay, so let's create a map and see the advantage of using a map over like an array. Remember, guys, everything, every concept, every problem has its own data structures and the best that fits. Okay, so don't like make comparison between arrays, maps, and you need to understand when to use map when to use arrays, when to use lists, when to use sets, and so on. Okay, so this is the trick about data structures. Okay, now how to create map. Creating map. The easiest way to create a map is by using the standard library map of function that is included inside the library of Kotlin. This function takes a list of Kotlin per object separated by commas. If I need to make the map that I have created before, let me show you this map: Ali 17, Muhammad 20, Jack 20. These are the keys and these are the values. How to create them inside Kotlin? I start by var students map equal, and we use map of. Okay, this is the method that we are going to use from our from the Kotlin library package. Now, please concentrate with me. Here we need to specify the keys and the values. The first key we have is Ali and 17, the value. So I put the key first, Ali, and I use to operator and its value. So I am assigning Ali to 17. I am telling that Ali is a key and 17 is a value. Okay, this is very important. This is how we create the values. Now I need to enter another one, so I separate that by a comma. The second is Muhammad and 220, the same as for Jack 19 and Sammy 212. Okay, we have created a map here. We have created a map here telling that a key is Ali, value 17, and so on. Exactly like this map. Okay, the Kotlin pair objects are created using the infix2 function. Okay, this is the infix2 function. Note that map key value is an interface. Remember, map is an interface, which you will learn more about it later on. The concrete type that is created depends on which standard library function is called. The map of function returns an immutable map of fixed size. For that, you need, this is a mutable type. We are having mutable or non-immutable. Immutable map, which is fixed size. Fixed size map. If I need to get or to create a mutable map of variable or dynamic sized map, we need to make a var students map2 equal to mutable. You see, guys, mutable map of, and we start putting what you need from keys and values. Okay, so when you print the students, or this is the key and value, we can't add anything to it. While the mutable map of, we can add the keys and the values that we are going to add them later on. Okay, so always use mutable maps of if you have elements to be added, keys and values, and map of if you have a fixed map. Okay, for sake of demonstration, I will use immutable map and the same thing here, but for the student map too. So we are going for the next videos for accessing values and using index operators. We are going to use a mutable map of to add and make the make operations on these elements. Okay, now let's print this map, student map. Let me remove this, or I can comment it, and let me start working with this, print, and here we go, guys. We have this result, every key and its value. After we have learned about maps and we have created a first map and printed it. Now, as we have learned in the previous video, we need to access these elements. So if I provide the key, it will give me the value. This is the importance and the usage of the map. As we have said that arrays, you provide the index and it will give you the value or the element. But here you provide the key and you will get the value. And this is very important data structure, which is a map, that are used in many different types, like the students marks that we have seen in the example, or any other companies, like any other projects and so on. So as with arrays, accessing values is very simple by providing the index. So there are several ways to access map values. Okay, so using the index operator. Also, we can, like a key, provide the key and we get the value. How to do that? Maps support using square brackets to access values. Unlike arrays, you don't access a value by its index, but rather by its key. Okay? When talking about or when dealing with maps, you are dealing with keys. And while you are dealing with arrays, you are dealing with indexes. Okay? If I need to access the first one, the first index, this is not index. This is a key and value. So I provide the key, it will give me the value. How to do that? If I try to print down the result of, please concentrate with me, guys. I need to get 17. I need to get the value. So I provide the key if I know the key, which is Ali. So it's very important, very simple. So I will start by specify the map, students map 2, and inside the angled brackets, I specify the key, which is the string. Okay, so this is the string. I provide ALI, and it will give me the value. Let's run and see. And here we go, we have 17. Okay, so this is the value that is associated with the key Ali. Okay, this is how we access the students, the map, and by providing the key and giving us a value. Okay, now there is another property by getting like this. So in addition to using the indexing, this is the method of indexing. Okay, I will make it accessing maps by index. or by key. Now we are going to learn how to access maps by a get function. So in addition to using indexing, you can also use the get function to access a value. So print ln the student's name, we specify the student's name map, and get. You see guys, this is the method get. And I will specify the key. It's telling me that the key you should be providing is a string. So if I provide an integer, there is an error because we are not giving the correct type of key. Get like Jack. So Jack is having 19. Let's run and see. Okay, and here we go. We have 19. So we have accessing the elements of the map by the get method. Okay, you specify either the index by this, like the key in the angled bracket, or use the get function. Okay, it's very simple. Maps share many of the same properties and method of other collection types. For example, both the arrays and maps have is empty and the size of members. So if I properties, if I specify print, I can access like this students map dot size. I can get it and it is returning an integer. Okay, so the returning type of this property is an integer, specifying the size. And the students map dot is empty. I can check for this. So is empty, it will return a Boolean. Returns true if the map is empty. Okay, contains no elements, and false otherwise. And size, this will returns the number of key value pairs in the map. These are some of properties of the maps. Okay, we have learned about maps in the previous videos, and we have introduced how to access the map elements and how to see the property of a map. Okay, and use it. Now we are going to learn about how to add elements inside the map, or how to add elements to the map for the mutable maps. Okay, so as we have learned that map of function will provide us with a constant map, while mutable map of function will give us a dynamic map. It will return us a dynamic map. So we are going to use a dynamic map to see how to put data, how to insert data inside this map. Okay, students map 2. This map is of type mutable map. Imagine you received more information and more data for any element. Okay, so like Ali 17 and the partial and final 16. So how to do that? Okay, and you want to add them to the map. This is how to add it. Adding data. Okay, so adding new data, or adding a new data fields for keys. Okay, so student map, we start by student map dot put. What is the key? I will give the key data fields for map. New data field or new data. I will add for this map like Ali, Muhammad, Jack, Sami. I need to add another student like Jamil. I will insert value here. See guys, if you are going to try to add and put elements, you need to use put, and here key and value. Okay, here thanks for Kotlin and thanks for the IDE that will give you a hint that the first one would be a string and the second will be an integer, like this. So you are here like strings and integer. Okay, there is even short way to add pairs, like using subscripting, like this, student maps. If I need to add one another student like called Rami, I will give it the value here like 15. Okay, so in this way I have added a new data. I have added a key Jamil and value 14, and I have added Rami and value 15 with another syntax. Let's run and see. I need to print students map, and here we go guys. You see these are the pre-made or pre-inserted data students, and we have added successfully Jamil and Rami. Okay, we have added 2 new students. This way we need to add and put the new values to the map by using the put method or by using this sim. We have learned how to create a mutable map in Kotlin and how to access its element, how to see its property, and how to add new elements to this map. Now we are going to learn about how to update the values inside a map. It appears that it is very simple if you have learned the arrays and the list and how to update and access the elements and how to deal with these data structures in Kotlin. In the same way, if we need to update a value in a map, it's very similar to array. So if I need to update like Jack, I need to update its value from 19 to 14. So how to update it? We start by calling them this, writing the name of the map, and here we have a key, a string, because we have specified the keys as a string. I need to update Jack. So it's very simple and very similar to arrays. Just you put equal sign, and this is the index, this is the key when working with maps, and you specify the key. So I'm telling that I need to go to the student's map, search for the key Jack, and updates its mark to 14. Okay, it's very, very simple. Let's print the whole student maps and see if Jack was 19 and now it's 14. Okay guys, now Jack is 14. This is very simple. Okay, now if I need to remove the elements from the map, removing pairs. Okay, we need to remove all of its information, like its key and its value. So the first call to remove method will remove the keys, will remove Jack and its Jack and its associated value or from the map, which is the grade. So I need to remove, I put students map dot remove, and here we specify the key string, or you specify the key and its value, or you specify only the key. I will specify the key Ali. I want to remove Ali from the list. Now let's run and see after printing students map. Let's run and see. And here we go, guys. We don't have Ali in the map. So we have successfully deleted Ali from this map. Okay, so this is how we remove elements and pairs from the map, and how to update the value of an element inside the map. We have learned in the previous videos how to iterate through a list or a map. Now we are going to learn about iterating through maps. The for in loop works when you want to iterate over a map, but since the items in a map are pairs, you need to use a destructing declaration. How to do that? The same as arrays, I specify here the data type that I'm going to create temporarily. I specify in operator and the name of the data structure that I'm going to iterate. But in maps, there is one single difference, which is the key and value. So since I'm iterating and getting every time a key and a value, I need to store this key and a value in two different variables. So I put here the name and I put here the grade. These are two variables that I will create every iteration and specify and make them temporarily assigned to the element of a map. So what is the name of the map? It's called student map 2. Every time or every element inside the student maps 2 will make in each iteration will be assigned to the temporarily created variables called name and the grade. Let's see in the practice how this works. Print ln, and I will create here the name, and I will put here also the grade. Okay, each time or each loop I will create its key and value. And you see, guys, I have all the elements here inside the map containing key, value, key, value, key and value, and key and value. This is how we make this happen and how to iterate through iterating the map. It's also possible to iterate just over the keys. So if I need for specific reason getting the keys only, I put here name in students map to print name. Okay, print name. But there is an error. As I told you, I need to specify the two variables, to create two variables when you're dealing with maps in student maps. But since I need the keys, I need to put here and tell Kotlin that, hey, I'm using I need the keys on. Okay, I'm getting all the keys. Let's run and see. And here we go. I will put them print ln. Here we go, guys. We have get it Ali, Muhammad, Jack, and Sammy. Okay, these are the keys. And the same way I can get the values. So for grades in students map dot values, the same way, but I put here values. Okay, print ln, and I put here the grades. This is for getting values, this loop for getting keys, and here we get keys and values. Let's run and see. And here we go, we have getted all the grades from this loop. We have getted all the keys from this loop, and we have getted the key and its associated value by this loop. So you will consider what to do with the map and what to use the specific loop and the specific iteration, like key value, keys, or value. Well, hello my friends, and welcome again to the complete Kotlin course. In this video, we are going to learn about the sets. So a set is an unordered collection of unique values of the same type. This is the definition of the set. This can be extremely useful when you want to ensure that an item does not appear more than once in your collection, and when the order of your items is not important. So sets is an unordered collection of unique values. Okay, the set is an unordered collection but of unique values. It does not accept duplicates. Okay, so how to create the set? First of all, creating set. You can declare a set explicitly by using the standard library set of function. For example, val names equal to set of, I need to create a set of what are the data that you are going to make. I will make as a string. So it took the element of a string directly. The same, Muhammad and others like Hadi and Sam. I'm creating a set of these. Okay, now print ln the names. Okay, let's run and see. Ali, Muhammad, Hadi, and Sami. It's very simple, but there is a trick here, guys. Let's try to add an element, duplicate element like Ali. And let's run. We have 5 elements, but by printing, it will print Ali, Muhammad, Hadi, and Sami. The second Ali will not be printed because, as I told you, a set is an unordered collection of unique elements. Okay, so it will delete this duplicates and skip it for the duplication. Okay, it's very simple. You can getting set from array or creating a set from array. It's very simple. Sets can be created from an arrays. I will create an array like grades array equal to array of, and I will make 8 and 3, 5, these random numbers. You can create a set from this array by passing the array into a standard library function, set function, and using the spread operator. How to use spread operator, or what is spread operator? I will create a var grades set equal, I need to create a set from this array, mutable set of, and here we need to concentrate. The spread operator is the asterisk here, and I pass the grades array. So I'm making a variable of set, grades set. It's a mutable set of, and passing this array, transforming it into a set. The array is spread into elements. This is the spread operator. The array is spread into elements when creating the set. You don't have to explicitly declare the variable as a mutable set of type int, since the type is inferred from the argument passed into the function. Okay? Now, if I have here an array, like I would make a duplicate of 8, and I need to see the power of using this. So I need to print grade set. Okay? Print ln. Let's run and see. As I told you, the set will not print the duplicates because it is having a unique elements. So the var of grade set is now a set of this array. So it eliminated this 8, it deleted it, and passed it into inside the grade set, because 8 is not unique, it is duplicate. Okay, it's very, we have learned about sets in Kotlin and how to create them and how to create a set from an array. Now we need to learn how to access the elements of the set. So in order to do that, you can use the contains method to check for the existence of the specific num element, or you can use the in to check for the existence. We will see both. So print ln to see if inside the names set dot contains. This is then the method that we use to check inside the set called names if it contains like Lara. I will see if it contains Lara. So let's run and see. And it returns false because in the set that we have created in the previous video, we don't have Lara. Now we will check for Ali, and we will see if it contains it. And here we go, guys. We have true. So we have this element called Ali inside the set called names. Now we can check for the existence using the in operator. Okay, print ln. I can check for Jack in names. Okay, now let's see if Jack is contained inside this set. and it is false. Okay, let's try to check if Hadi is inside names. And here we go, guys, it is included. So we can use in or contains method to check for the existence of the names or the existence of elements inside a set. You can also use the first method and the last method like this, names dot last, or first method, which return one of the elements in the set. However, because sets are unordered, you won't always know exactly which item you will get. Okay, for example, print this. Let's run and see. And here we go, we have Ali, but this is for small elements or small set like 4. If you write like Ali in the first, it will not be kept at the first in the set because it is a random hash set. Okay, it's storing them in a random manner. Okay, now we will try to add and remove the elements from the set. So we will try to make application on adding and removing elements from a set. This is done by the add function to add the elements to a set. If the element already exists, the method does not do anything. Okay, so let's try like we have created names dot add. I need to add, this is the names. I will make it as a mutable set in order to be to allow it to be flexible and add the elements and remove elements from set. So you see, guys, this add unresolved reference add because it is not a mutable set. I will call it mutable set of. So now the error here have been disappeared. So I can now add the elements that I want. Larry, Laura, names dot add Carl, and so on. We have added 2 elements to the set. Okay, let me show you names. Print the names to see the set now, how it looks. And you see we have appending them into Lara and Carl. Okay, now how to remove? In the same way, I can make names dot remove. I need to specify the element. Okay, so I can specify here one. If I put 1 because it is different from a string, it will give me an error. So I need to remove Ali. How is that done? Is by putting here the element. If the element exists inside the list, the set, this will return true and it will remove it from the system or from the set. If it does not, it will do nothing and will remove and will return false. And here we go. We have removed Ali from the set. So this is how we add and remove elements from the set and make operations on. In the previous lessons, you taught about functions, but Kotlin has another object you can use to break up code into reusable chunks. These objects and other objects are called lambdas. So, what are lambdas? These have many uses and become particularly useful when dealing with collections such as an array and map. A lambda expression is simply a function with no name. So, lambdas simply a function. A lambda expression is simply a function with no name. You can assign it to a variable and pass it around like any other value. This lesson will deal with, we will learn about the lambdas, and we will continue through this section to learn about the lambdas and the basics of lambdas. So, lambdas are also known as anonymous function and derive their name from the lambda calculus of Alonzo Church, in which all functions are anonymous. Lambdas are also synonyms with closures and go by that name in many other programming languages. So, variables and constants used within the body of a lambda are said to have been captured by the lambda. Okay, you may ask, if lambdas are functions without names, then how do you use them? To use lambda, you first have to assign it to a variable or constant, including as an argument to another function. So, how to declare it? I will start by a var multiply lambda is of type int. We start by this, taking two parameters. These are the 4 parameters. They are of type int, and this will give us an int. So this is the lambda expression. We specify what data type you are going to use and what are the parameters that you are going to pass for the multiply lambda function, and what is the returning type and how it will return, and what are the relation of these two parameters for each other. We will see. Don't worry, we will clarify everything. Multiply lambdas to take two int values and returns an int. Okay? Took two values of type int and return a value of type int as a returning value. Notice that this is exactly the same as a variable declaration for a function. Okay? It is the same as fun multiply lambda multiply function. It's taking two parameter a of int and b of int, returning type int, and we have here the body return a times b. Okay, this is the function, multiply function. We are making this the same as lambda, but we are specifying here the minimum codes. So remember, lambdas are functions, anonymous functions with no name. Okay, so we are not making this, we are making a var multiply lambda. We specify the data type and what is the solution or the result of this and returning value of this function. Okay, now you assign a lambda to a variable like so. How to use the lambda? We start by multiply lambda, the same as calling function, equal 2, we assign a as int, b as integer, and here we put int a times b. Okay, a times b on a new line in order to see here that lambda expression on the next line. This is similar to a function declaration, but there is subtle difference. There's the same parameter list, but the arrow, this is the arrow symbol, indicates the returning type. The body of the lambda begins after the return type. So the body of the lambda is in the new line, a new line. So it will begin after the return type. The body of the lambda begins after the return type, and the lambda expression returns the value of the last expression in the body. So if I have like a plus b here, or a minus b, it will return the last line inside the body of the lambda. So these will be executed, but at last the value will be returned a times b. Okay, so this is very simple. With your lambda variable defined, you can use it just as it were a function. So how to make this? I will create a val lambda result equal to multiply lambda. I will pass like 7 times 10 and see the result. Print lambda result. Okay, now let's run and see. And it's very clear that it is 70 and we are working fine. So we have created our first lambda and we have specified that the first parameter is 7 times 10, it will result 10.
Well, hello my friends, and welcome again to the complete Kotlin course. In this video, we'll learn about the shorthand syntax of lambdas. We have introduced lambdas in the previous video, and we have said that a lambda expression is simply a function with no name. Okay, so compared to functions, lambdas are designed to be lightweight. There are many ways to shorten their syntax. First, you can use Kotlin's type inference to shorten the syntax by removing the type information. I will transform this into this multiply lambda into a shorthand lambdas. How to do that? I will make shorthand lambdas. Without specifying the type, we can directly write multiply lambda equal to a, b will give us this a times b. Without specifying the int, we can directly write a, b is a times b, and we have agreed that a times b, the lambda expression, would be on the new line. So the new line will determine the lambda, and we have said that the returning type of this function or this lambda would be the last line inside this between two curly braces. Okay, first, or remember, you already declared multiply lambda as a lambda taking into two integers and returning an int. So I can remove this and keep on the shorthand lambda. Okay? So you can let Kotlin infer these types for you. Now, we are going to introduce the it keyword. Okay? So we have learned about the multiply lambda, which is in lambda, and we have written it into a shorthand lambda. Now, in lambdas, we will need to, we can use a further operator called int. So for a lambda that has only one parameter, you can shorten it even further using the it keyword. Okay? It keyword. I will create var double lambda equal to this is for one parameter a. This is the one and 2 times a. The returning type or the returning value of this lambda would be 2 times a. We are doubling it. Since there is only one parameter and the lambda type is now specified, the lambda can be shortened by double lambda. You can shorten lambda by specifying double lambda equal to 2 times it. You see, guys, this is the keyword called it. You can also use it in the new declaration, like var square of int will give us int equal to it times it. Okay? It times it. See, guys, this is the square, and you can use it for the only with lambdas with only one parameter. Okay, this is the it keyword. Okay, now lambdas versus as arguments, you can make them as an arguments. So you can make a function and make it the result looks like a repeated one or recursive by declaring a function that make a lambda as argument. Don't worry, we are going to see this in the next. Hello, my friends, and welcome again to the complete Kotlin course. In this video, we will learn about the custom sorting with lambdas. Lambdas come in handy when you start looking deeper at collections. We have learned how to sort an array in the previous video. So if I need to sort an array, I will create an array called names equal array of like 1, 5, 2, 4, and 8. And I need two numbers here. And I need to sort this array dot sort. Okay, it will sort the array by specifying a custom lambdas passed by to compare by a method which returns a comparator for sorted with. So if I need to make a lambda that it is specifying a custom condition, how to do that? I will create a lambda names by like names by length equal. Here I need to specify the array. So I will create a new array called names equal to like AAA N if I need to make another one, this is array of, sorry. If I need to make a new like P or RR and CC. Look guys, here if I call the names dot sort or sorted, here we are sorting the arrays according to the alphabetical order. Let's print this and you will see why I'm doing this. So if we look here, we have this print names. Let me check again. Okay, I'm printing the index, the address. Here we need to use arrays dot toString. Okay, and let me run and see. Here we have sorted the array according to the alphabetical order: A, C, N, and R. Okay, please concentrate with me, guys. This is the order of for the compatible interface. This will be comparing objects of the string according to the alphabetical order. Now, if I need to sort these elements of an array in a different concept, in a different criteria, so I need to sort the names according to the length of the name. So from the biggest to the from the longest, which is CC, N, A, and then R. How to do that? I told you that lambdas will help you making this with Kotlin, and we start by the array name sorted with, this is the method that we are going to use, and compare, we are comparing by, compare by method. Okay, this is very important, guys, and we are going to compare it dot length. Okay, we are specifying, we are passing the compare by, and this is the lambda expression, and we are comparing by the length. So it, we see the it operator in the previous video, and we are making a lambda expression here and telling that we need to sort this array called names into according to the length of the elements. So the longest one would be the first, which is CCCC, N, A, and RR. Okay, this is how we make this comparison. Let's print and see. Arrays again. Arrays dot toString and names by length. Okay, or we can specify directly this print ln. Okay, and here we go, guys. The first ordering is the ordinary. This is the original and natural ordering for any string or any object, like comparing it with alphabetical order, or if we have an object of type int passed to the arrays and we need to sort this array, it will sort it by increasing order. Now, if we need to modify the criteria of making and sorting things and sorting objects of the array, we could use the lambdas. So lambdas are very important in terms of using them with the collections, like sorting and modifying the natural things. Like here, we have sorted the array by the length of its element and not in the alphabetical order. In Kotlin, collections implement some very handy features often associated with functional programming. In this video, we are going to learn about iterating over collections with lambdas. These features come in the shape of functions that can apply to a collection to perform an operation on it. Operations include things like transforming each element or filtering out certain elements. These functions make use of lambdas. The first of these functions let you loop over elements in a collection and perform an operation like this that we are going to do. Val, for example, val values equal list of and numbers. Okay, values dot for each, you see guys, this for each, and without using the for each, we are going to the for each with the parentheses, we are going to use it with the curly braces and print ln. This will print for each one a variable. This is the variable it, so it will print it, and it will print its square. So how to do that? This is very simple, like specifying here what we are going to do. It times it, we have seen the square here. I need to remove it and this. Okay, we have seen this example, it times it, in the previous video, where we have talked about the square, and it here just for telling that every time you pass me a perimeter, I will display it. Display it means I will display every element I am passing. So it refers to the perimeter. So value of the perimeter is it. Now, the value of perimeter is then timed by multiplied by the same value it. So for example, 1 is passed here, 1 is multiplied by 1 times 1, which 1 times 1 is equal 1, and it return 1 as a constant value, which is here referring to a string in green, and the variable, the result here would be in a dollar sign, this dollar sign in orange sign. So this result would be the variable. Okay, so again, if I pass 3 times 3, it will be passed for every, the perimeter will be passed for every it and replace it. So it refers to the parameter passed. 3, this is the constant. Variable it would be, or 3 here, would be 3 times 3, 9. So it would be 9. And this would be passed as after calculation to 3 dot is equal to 9. Its square is equal to 9. Okay, let me try to run this and see the results. And here we go, guys. 1, 1, 2, 4, 3, 9, 4, 16, 5, 25. This loop through each item in the collection, printing the value and its square. This is iterating over a collection using the lambdas. Another function allows you to filter out certain elements, like the filter. So you understand this very well, okay? And it's very simple. Now, if I need to iterate to allow to filter other certain elements, okay, how to do so? So if I need to filter a list, if it is above 10, so I will create var like values equal to list of, I will remove list of, and like 6, 8, 10, 17, 5. I use var val larger than 10 equal to values dot filter. This filter would be passed like it dot or greater than 10. Okay, now if I print larger than 10, here we go, we have larger than 10 is 17. If I put equal, it will give me 10 and 17. So this way we work with lambdas in collections. Okay, so collections are very powerful when using lambdas, and lambdas are created for the purpose of using them with collections. Okay, and you can make map, you can make user input map, you can map not null, and many things with the lambdas. And it's a very big thing to use, a very big concept using lambdas with collections. Okay, don't worry, we are going to practice exercises, and we are going to make building many types and many things later on, many data structures using the lambdas. So don't worry, we will clarify everything if there is anything being done. Hello, my friends, and welcome again to the complete Kotlin course. We will start the object-oriented programming in Kotlin. So you will get acquainted with the classes, which are named types. So classes are one of the cornerstones of the object-oriented programming, a style of programming where the types have both data and behavior. In classes, data takes the form of properties and behavior is implemented using functions called methods. Okay? So a class will have data takes. Think about a class as a template of creating the objects later on. And the object have, or a class, data takes the form of properties. Okay, and the behavior is implemented using functions called methods, or using methods. Okay, so data takes the form of properties and the behavior is in form of methods. So we have a method and a property forms of inside the class. Okay, so a class consists of behavior and properties, data and behavior, properties or methods and methods. Creating the class. How to create a class? Consider the following class definition in Kotlin. I will make this. I will remove here. In order to create a new class in Kotlin, we go to the source, we open the project, select the project, go to source here, and we select onto new Kotlin class or file, and we select the name of this class. I will name it as person. So this person have been created here. You see, guys, we have a class here, and our main one is here that we have created in the previous videos. I will close it. And now the person here is the class that we are going to work with. A class will begin with a class keyword. Okay? The name is person, is the same as the file. Okay? It's very simple. Now, I will modify this and later on I will clarify it. First name of type string of var last name of type string also, and here I will make val full name is equal to get function equal to first name last name. What I am doing, what is this writing? That's simple enough. The class keyword is followed by the name of the class, as I told you. Inside the parentheses after the class name is the primary constructor. So this is called the primary constructor. When you see a method like a method here and having the same name naming as the name of the file of Kotlin, so consider this as a constructor. Okay, this is the main constructor or the primary constructor of a class. And for a person, you are indicating that there are two mutable string properties. I am telling this I need for the constructor to have two variables, a string of type string, the first name and the last name. And then you will see how to create other constructors later on in the advanced classes, but everything in curly braces is a member of the class. So curly braces here, and this is the member of the class. You create an instance of a class by using the class name and passing in arguments to the constructor. How to do that? This is the class name. And if I go to the Kotlin course again, in our main function, and I need to create a new object, creating an object here, an object from the class, from person class. How to do that? I will create val and for Sylvester Stallone, this Sylvester Stallone equal to is a person. He is a person having the first name as Johnny or John. Sylvester, sorry. And I will pass another, like, think about it as a parameter. Another Stallone string is for his last name. Okay, the class instances are the objects of object-oriented programming, not to be confused with Kotlin object keyword. Okay, so person have another property named full name with custom getter that uses the other property in its definition. How to get this? We see that the person accepts a first name and a last name, but inside the class here we have another algorithm, like a full name is a getter method. It will return the first name parameter space last name as a string. So it will get the full name val, what it is containing inside the full name is the first name and the last name separated by space, and they are returned as a string. Let's see how this look and how this work all together by println Sylvester Stallone dot, and you see the properties here that they are appeared in the list: the first name, full name, and the last name. I need to get the full name. Okay, let's run and see. And here we go, guys. These are the first name and the last name. This is the full name of the person that we have created, called Sylvestal. Okay. In Kotlin, an instance of a class is a mutable object. Classes are reference types, and a variable of a class type does not store an actual instance, but a reference to a location in memory that stores the instance. If you were to create a simple person object or class instance with only a name like this, so if we have a var from this type, we consider making a var1 with a reference to its value. So I'm making a reference type of simple person named Jack, and the reference here is for the var. So how to do that in Kotlin? It's very simple in Kotlin. If we go to here and make another Kotlin class called simple person, and I will scroll up, and here I need to pass its constructor parameters val name and of type string, and I need from this to make a var1 equal to simple person constructor. This is the where we need to get it. You can make a printing for the class, but I will not make it here. Now I will create an object from this class like var person1 equals simple person, and I will pass like Jack. So it's the same as here. We have a reference var and referencing for a Jack object. Okay, so this person having a simple person and an instance of the simple person class, but there is something that it is special for the referencing. Going here, we have reference in var1, but if we have a reference var2 having the same reference, it will give us the same object, the same value. So this var2 have different reference, and sorry, the var1 and var2 are different, but the reference are the same, so it will give the same result as Jack. So the main important point I need you to understand that when dealing with the reference, you have the same reference, so you will get the same result despite they are of different objects. So var1 is different from var2. They are the same type, but different type of the different location in memory. But the reference of this would be the same. So var1 is a Jack and var2 is Jack. How to do that in Kotlin? It's very simple. So I'm making a var2 or person2 is equal to person1 is equal to person1. This is the referencing. I'm telling that person2 reference is having the same reference as person1. So go and get person1, which is get a Jack. So I will print, if I have printing, so I will try to print. Let me show you person2. Let me show you if it will print a reference. Yes, this is the reference. They are having the same reference. See, guys, they are of the same reference. Okay, so this is how to deal with the references. This is the type reference in Kotlin, and there is a very important note that I should mention this before we end the reference type. When you create a reference type such as a class, the system stores the actual instance in a region of memory known as a heap. References to the class instances are stored in a region of memory called stack. So reference is stored in the stack, and the actual instances of region in memory known as heap. Okay, unless the reference is part of a class instance, in which case the reference is stored on the heap with the rest of the class instance. Both the heap and the stack have essential role in execution of any problem and the program. Okay, so this is a very important thing that I should mention before ending this and moving towards the more and more advanced things. Okay, so thank you. Hello, my friends, and welcome again to the complete Kotlin course. In this video, we will make a real class exercise that will contain classes, contain collection, and we will practice the operations and the execution of functions inside the classes. So welcome again, and in this exercise we are asked to make a grade class and a student class, in which a student have a first name, last name, a collection of grades objects, and a credit, while the class grade will contain the letter that it's specifying the name of the subject, the points, and the credit of this this subject. Okay, so first of all, I will create a class called grade. Okay, I will remove this simple persons, and I will create here source new Java class. Sorry, not Java, we are working with Kotlin. Yes, so I will create grade Kotlin core grade Kotlin file, and this class will took inside it in a parameter as a parameter for its constructor letter of string. Okay, it will take val points as double and val credits as double. Okay, this is the grade class. Okay, it's very simple class. Okay, now I will create a new Kotlin class. It's named as student. So val first name string type string val of type string called last name. This is here, sorry. This is the constructor. Last name of type string. Val grades of mutable list. This is the mutable list of grades. Okay, this is the mutable list of grade class that we have created before. Okay, so I'm making a list of all of grades in his subjects. Okay, equal to mutable list of. This is how we create it as a parameter inside the constructor of class student var credits double equal to 0.0. Okay, it's very simple. Now I need to put here the function like record grade and grades. I am putting this function will add the grade, the past grade to the collection called grades of type mutable list of grades. Okay, so I'm making a collection called a list of all grades of this student. So when I need to add a new record, a new grade for any student, I will call the function record grade. Okay, grades.add grade. Okay, and credits plus equal to grade dot credits. Okay, I'm adding also the credits, which is equal initial to 0. I'm adding the credits that the student has been marked. Okay, guys, it's very simple. Now if I need to use these two classes, I will go to the main function. If you want to make it runnable, But for purpose of demonstration, I make it in a separate file called Kotlin course, and this will be in a function and runnable function, because we are going to test it and display the result. So val, I will create a student1 equal to student. This is a student, so I need to pass here the parameter. So if you look here, the first name of type string, I need also to pass a string for the last name, and I need to pass a mutable list of and credits. Okay, so student like Jack Sparrow I will create a subject to make it as a grade. So in science subject equal a grade. So he marked he marked B in science. He achieved 9/10, or sorry, it's achieving 15/20. He is clever, yes, and credits is equal to 3. Okay, here it is a double 0 and 0.0. And now val in mathematics, math subject is equal to grade. He marked letter A. He's very clever in mathematics, and 19.0, and here the credit is 4. Okay, now student1 dot, you see guys here there is grades, credits, first last name, and record grade, because now because we have created an object, an instance from student1 student class, and we can access all of its components like first name, last name, grades, or credits. And also we have access to the function record grade. I need to add this grade by calling record grade, and I will call science as subject, and also student1 will record grade math subject. Okay, note that record grade function can mutate the array grades by adding more values to the end. Like any mutable list, grades can be added to even though the grades reference itself is mutable. This is independent of the fact that student1 is marked as an immutable val reference. Similarly, the credits double value can be changed in record grade because it's defined as immutable var within the student class. So this is the example, or this exercise like clarify all things about creating the classes and making a collection and making a function that deals with this object and add to the mutable list to this collection a grade. So this is how to deal with the functions, how to deal with classes, and how to deal with collections. It's very simple and it's complicated in the same time. So please, if you understand everything, every concept in its separate way, it's very simple. But if it is complicated because you didn't understand every concept, so please go back to the course and watch again the classes, the functions and the collection to ensure that you understand all of these exercises. If you understand this exercise, and it's very simple, so you are clear to go through the course and watch the next video. Kotlin introduces a new keyword that is unavailable in the other languages to which it is often compared, such as Java and Swift. It introduces the object keyword. Like Java and Swift, Kotlin supports object-oriented programming. As you saw in the previous videos, in the class video, you use classes to define custom type, and instances of the class are called objects. Kotlin uses object to denote a custom type for which is only a single instance can be created. So object is for a single instance, while objects are for using the custom types and references types. The name choice for the object keyword can sometimes lead to a confusion with class instances. Okay, so since they are called objects, as you will see in this video and later on, we will use object to create anonymous object for which multiple instances are created each time the anonymous object is used, another potential source of confusion. Don't worry, the object keyword lets you easily implement a common pattern in software development. It is a singleton pattern. We will learn these patterns later on in the design patterns course, so don't worry, we will clarify everything later on. The singleton pattern is one of the more straightforward of the design pattern used in software engineering. The most object-oriented languages, the pattern is used. You want to restrict the class to have a single instance during any given run of an application. So when you're creating a global state or global object or global instance, you are making a singleton pattern. Now, let's go to the source folder here, and I will create a new Kotlin class file, and I will name the file X. Okay, here. And here we go. Now, I will add here inside the class X an object X. Okay? Despite using class, I will make an object X var X equal to 0. Okay? Now, choose tools, then Kotlin, then show Kotlin bytecode. Open a Kotlin bytecode panel. And in this panel, I will show you. We have a decompile, and these are the codes. Now I will click on decompile. The decompiled Java for the simple object will open a new editor window, and it's telling us it is of a public class X, final class X, having a static int X and instance X, not null. We have get X and set X. These are the getters and the setters, and this is the empty constructor. Okay, and this is a static. So comparing the Java and the Kotlin version of the code, which is here, you will see that the boilerplate singleton setup code has been significantly reduced by using the object keyword. So despite making these in Java or in Kotlin, we can use object keyword X var x equal to 0. Okay, it's very simple. So where we use singleton. An example use case for a singleton is an in-memory repository for a set of data. Consider an app that needs a registry for students who are defined with a data class, like student that we have seen before. Using object, you can create a registry that maintains the list of students in a mutable list. How to do that? Okay, we need to add all the students in one mutable list. How to do that? I will remove this. I will close this window, and inside the source, I will create a new Kotlin class. I will name it as student, and I will put here data. Later on, data class. We will see it later on. What does this mean, data? But till now, concentrate with me. I'm making an ordinary class that we have created before, val ID of the student, int val first name of type string and val of last name. Okay, val last name also of type string. Okay, so var full name equal to last name separated by first name, comma. Okay, so I'm creating this data structure, this data class is called for the student. Now, if I need to create a class instance of the student, I will go to the main and I will make like a val student1 equal to student, and I will pass the parameters that I need. So one like ID is equal to Ali, first name, so val student2 equal to student ID 2, first name is Jack Sparrow, and so on. Using the object keyword, you can create a registry that maintains the list of the student in a mutable list, lets you add and remove student from the registry, and lets you print out the full name of all the students in the registry. How to do that? I will create a new Kotlin course, Kotlin class, sorry, and I will create it as a student registry. Okay, this is the student registry, and I will remove the class and make it as an object. Okay, so this object would be a singleton. And what is the benefit of using singleton? Is ensuring that we have one instance of this object at runtime. So what we will do, I will make a mutable list, as I told you, all students, it's called all students equal mutable list of and of type students, containing all the students. Okay, now I will create three functions, one for adding student, add the student. It took student a variable of type student, all students dot add student. I am adding to all students this mutable list, this data collection. I'm adding the past parameter called student to this collection all student by calling add student. Okay, now the same way I will create a function called remove student of type student, and I will all student dot remove, that remove. We have seen these functions in the collection framework in the previous videos. Okay, now I need to remove the student. This is the student. Now I will create a function that list all students. So print all students. It is a void. It will not take any parameter. All students dot for each, and you see here I'm using lambdas that we have seen also in the previous videos, and println it operator dot full name. Okay, I have created an object called student registry. It has a val all student. It's a mutable list. It contains 3 functions, one for adding student, one for remove, and one for printing all the students. Okay, you call methods defined on the object using the object name with dot syntax, exactly like any object in the Java or anything. So student registry dot, you see guys, these methods print, add, and removes, and all student, this is the val, this is a mutable list. Okay, so you can access them. Add student, and I will add like student1, and then I will make a registry for student2. Okay, dot add student2. Okay, now I will make student registry dot print all students. If I go here, it will give me a print out for each student name or each element inside the collection all student. Okay, now let's run and see. I have here the first name or the last name and the first name, last name and the first name of all the students that I have in my database. So to think about object is an database that you can store it in this example. I'm talking about this example, student registry, where I have stored all the students information about in the all student mutable list. Okay, so it's very simple. I have added 2 students. I have created 2 students references and data types, and then I have added to the object. This is an object which is a new type in Kotlin. I have introduced a singleton one, which is student registry, and I have adding them add student, remove student, and print all student functions, and then I have printing all the elements. Okay, it's very simple. This is how we use the object in Kotlin. In the previous video, we have learned about creating a student registry object and the student data class. And we have used them inside a runnable main function. And we have said that it is a class, the object student registry, and it is a singleton pattern or a singleton class that ensures that we have one single all students. And a student here is a class, an ordinary class of data class type, and accepting the ID, first name and last name. But what about not passing the ID of the student? Making it an auto increment. So we need a static variable called ID. But in Kotlin, there is no static keyword. So the static keyword is used in these all other languages like Java to denote a class member that is common to all instances of the class. So in this case, the student have an ID that should be a static and shared among all the instances of the class, and it is not specific to each instance. Static members remove the need to duplicate items that are common to all instances. But removing this code duplication is useful. So how does Kotlin allow you to define static members? You do so by creating a companion object inside the class. So what are the companion objects? This is similar to the static variable and the objects. And you can create a companion object by appending companion to an object defined in the class. So we go here to the class student, and I make here this val, and I will make here a companion. We start by companion object, and we define here var equal current ID that I am going to make it a static for all the object and shared among all instances of this class. And here I will create function new student, and I will put here the first name as string and the last name as a string, and it will return a scientist or the students list, student list. Okay, so there is one thing that I should mention, that when using this function and making a companion, you need to remove the data and make it private constructor. Okay, so making this private constructor will ensure that you understand every concept in making a new ID, a new instance, and make all these IDs are shared among the instances of students. Okay, so every time you create a student, there is an ID that it is would be added directly like this, student list. I will make it later on, and current ID I will add it every time by 1. So return scientist or this students list, current ID, first name and last name. Okay, this is how to make the class a private constructor and modifying the constructor and the data that you should share among all instances by making a companion keyword. So the var current ID will be increased every time you create a new student, a new instance of the student. This is the purpose of making the use and using the student. So now if you create a new student, no need to make here the ID. So I can pass here no ID. Okay, and you can see here I have changed this from primary. Okay, you can remove this and everything will be fine. In the previous videos, we were introduced to properties as the data members of Kotlin classes and objects. We are going to go deep with the properties of the class, and we are going to make an examples to understand the getters, setters, accessors, and data types later. So I will create a new Kotlin class. I will name it as car, and it is of type class. And inside this class, this constructor, later on we will talk about constructors, so don't worry. We are going to talk about properties in this video, later on the methods, and later about the constructors. So val, it will make a make of type string, and val color of type string. Okay, I'm creating just a basic car class having two property supplied in primary constructor, and they store different string values for each instance of car. Properties can also be set up with custom accessors, also known as getters and setters. The properties supplied in the class primary constructor use default implementation of the accessor, storing the data in the backing field. What does this mean? Later on, we'll talk about the custom accessors and initializers. Don't worry. So the constructor properties here, as you may have guessed from the examples in the previous video, you were already familiar with many of the features of properties. To review this, imagine you are building an address book. The common unit you will need is a contact, like a card here, like make and contact. If I change, I will create a new class here, new Kotlin class. I will create contact, and here I have to pass also the var full name of type string and var email address of type string. Okay, now you can use this class over and over again to build any array of contacts, each with a different value. The properties you want to store are individuals, full name, and email address. Okay, these are the properties that you are going to store. These are the properties of the contact list or contact class. You provide a data type for each, but opt not to assign a default value, because you plan to assign the value upon initialization. After all values will be different for each instance of contact. You create an object by passing values as argument into the class primary constructor that we have created in the previous videos. So properties or properties here, I create a val called contact1 equal to contact. I will put the name of the instance that I'm going to create, the full name. You see guys, there is a full name of type string and email address of type string called Jack Sparrow, and the email. Oops, there is a bug here inside the IntelliJ, but don't worry, I will contact the company and I will tell them about this. So contact again var, I am just retyping them, string var email address type string. Okay, now if I want to create a new contact, as I told you, I will create a new object val or a new type reference or reference contact one equal to contact, and I pass here the name Jack Sparrow and the email address is Jack Sparrow, Jack S at Gmail, Jack Sparrow. Okay, so we have created a new contact and we have added the full name in the email address. Now, as with any function call not using default values, using named arguments in the primary constructor is optional. You can access the individual properties using the dot notation. Now, if we need to, we have created this instance of contact1. We need to access these properties. So access the properties. Val name equal to contact1 dot full name and val email equal to contact1 dot email address. Okay, you see guys, this is the dot notation. If I put here alt plus control plus space, I can access all the methods and the properties for the instance contact1. Okay, for that I will access the email address. Now I will print the name and then I will print and the email variable. Okay, emaily and namey to distinguish them. Okay guys, now let's run and see. And here we go, we have the name and the email have been successfully getting them from the contact1. Okay, we are extracting the full name and the email address by the dot notation. You can assign values to properties as long as they are defined as variable. Since these are defined as variables, if we go to the contact and we have var here, so here is the var, so we can change them. This contact1 is Jack Sparrow. If I want to change it without changing the email address, so I simply make contact1 dot email or name, full name equal to Harry Potter. Okay, now if I print the name, it will be Harry Potter. It is changed to Harry Potter. It is contact one dot full name. Okay, we are printing the val. I will store it in U, or I can directly print contact one. So contact one dot full name again, Harry Potter. Since val name is val and it's not changed, I can put it as var. You can make it like this. Okay, so you can change the value of the contact name and the properties. You can change them by making the dot notation, and you specify here the equal sign. This is the equality sign that is assigning you a new variable, a new value. Okay, if you would like to prevent a value from changing, you can define a property as a constant instead using val. Okay, it is very important. So you can make here the contact without using a var, it will be as val. Okay, these are about making the properties and using properties inside the class. We have learned in the previous video how to create a contact class and how to make an instance from this, our type reference. Okay, so and we have told you that the contact has a default constructor here that accepts a full name and email address. Think about if we are going to add a sharing and a common variable or a default value for any contact we need to make. So if you can make a reasonable assumption about what the value of property should be when the type is initialized, you can give the property a default value. How to do that in Kotlin? It does not make sense to create a default name or email address for a contact, but imagine there is a new property type R to indicate the kind of this contact. So I will make a var type, and it is of type string. I will put them on here, and I can give it a default value as a friend. Okay, so this would indicate that the default value for any contact that I'm going to create is a friend. You can modify it later on, like making it a close friend, like college friend, like coworker or friend of work, or anything that you need to do. But a default value for this contact is a friend. But by assigning a value in the definition of type R, type here, type R, type of relation, you give this property a default value. Any contact created automatically would be a friend, unless you change the value of type to something like work or family, as I told you. Okay, so if I go here, there is no error, so no need to pass a third parameter. Okay, I will create, or before I will create, print contact one. I will print it. It will give me the address, I think. Okay, the address to string. Let me see. Okay, not making this contact dot. I have access of type R, full name and email address, and type R is not specified here. I just specified the full name and the email address. So if I print the type R, let's run and see. And we get the friend type. Okay, so this is the default value. If I need to change this default value, type R equal to close friend, or like friend family. Now print contact one dot type R. Let me see if it is changed. And here we go, we have the family. Okay, these are the default values in the creation of instances of the properties. Can also be initialized outside of primary constructor using literals and values passed into the primary constructor using a property initializer. So in this video we are going to talk about the property initializer. Okay, consider the contact class. Here we have a class that has a full name. I will change this. I will remove this first name and the var, another var, the last name, string. Okay, and here we go, we have a val full name that it is equal to the concatenation of the first name with the last name. Okay, in this class contact, the full name property is initialized using the values that are passed into the primary constructor. Okay, so if I create a new contact here, Jack, and here I make Sparrow. If I put here print contact one dot full name, so if I print the full name, it will concatenate the Jack and the Sparrow, the first name and the last name. You can set the value of properties with their declaration and also in the initialization block, which is init block. Okay, let me consider a new class called address, and in this class I will make the initialization block, init block. So I will create first of all address one type string var address 2 string equal to null, and var city. You see this is an error because it is not initialized. So if property must be initialized, this is what I'm talking about. Property must be initialized or abstract. Okay, we will see how to solve this error and why we are doing this. I will create also new city and a var state of type string. Also, we need to initialize these two properties, state and address. Okay, this is very important. Now, in order to initialize this property, initialization, how to do that? It is very simple. Init, we use the keyword init. Address 1 is equal to, by default, to empty space, empty string. Okay, and the state here is also equal to empty string. Okay, in this way I am initializing the properties. So in address, the address2 and the city property, address2 and city property are well defined and initialized in their declaration. The address1 and the state properties are initialized inside the init. Okay, this keyword, this is the new keyword that we have introduced in this lesson. So since all four properties of address are given values inside the class definition, you can create an address instance using an empty constructor call. So how to do that? We go to the Kotlin course. I will remove this and I will create the val address equal to address, and this is the parameter, this is the constructor of this, and we are using the default access and default initializers. Okay, so if we print address dot address1 or address2, let me run and see. Address2 is equal to null because we have initialized it with null. Okay, now I will see address1. Address1, let me run and see, and it is an empty space, so, or empty string. So this is the initialization property. Init block, you can initialize the variables, not by using these, you can use by doing this. Okay, you can make initialization and giving the value default values, or initializing values of variables by init block. Many properties work just fine with the default accessor implementation, in which dot notation returns the value directly and an assignment statement just set the value. Like this address, we have an access to, if we press Ctrl and space, we can get and access the default values or the initialized values. Okay, so anything we can access it by the dot notation. But properties can also be defined with custom getter and setter methods. If a custom setter is provided, then the property must be declared as var. We will see as this in the next couple of minutes, but let me talk about the custom getters. So the custom getters here, custom getters, think about making a new class, a TV class. I will create a new Kotlin TV Kotlin class, and this TV class will have as in its default constructor var height double, and we have var width double. Okay, now if I need to calculate the diagonal and see how the measurement of a TV would be done. The measurement of a TV is the perfect use case for a custom accessor. The industry definition of screen size of TV is not the screen width or height, it's diagonal. So we need to calculate the diagonal and return it as a diagonal. So how to do that? We start by val diagonal int, we go to get, and we start by getting the and calculating the diagonal. So result is equal to math dot square root. We are using the library of math here, and the square root, we are calculating the square root height times height. So height square plus width square the result of this addition will be square rooted, like radical height square plus width square will give us the result. Then we will return result dot round to int. We need it in inch, and it is without the float, because we don't need the point and the floating and the decimal part. We need the int part, so I used the round to int. See guys, this custom get, what will do? What does this will do? Going through this code one step at a time. You use an int type for your diagonal property. Okay? Although height and width are each a double, the v sizes are usually advertised as nice round numbers such as 50 inch rather than 49.52. Okay, so because that we have used the round to int. Okay, instead of the usual assignment operator equal to assign a value as you would for a normal property, you use the get. Okay, so without making the calculations, and then we use the dot notation, we can use the get with a custom declaration here. Okay, once you have the width and the height, you can use the Pythagoras theorem to calculate the length of the diagonal, and we have make it the math square root. Okay, now since you have provided a custom getter, no value is stored in for diagonal. It is simply returned based on a calculation. From outside of the class, a property with a custom getter can be accessed just like any other property. How to do that? I will remove this. How to access the TV? So I will create TV, instance of the TV height is equal directly to like 53.93. Let me say width 95.87. Okay, this is the width. I can remove it. Now val size equal to TV dot height, width, and diagonal. I need the diagonal. Okay, it is around 110. You have a 110 inch TV. Let's say you decide you don't like a standard movie aspect ratio and you would instead prefer a square screen. You cut off some of the screen width to make it equivalent to the height. So for that, I can make like TV dot width equal to TV dot height. Now val diagonal equal to TV dot diagonal. This will give you a 76 inch. Okay, now you only have a 76 inch square. The computed property automatically provide the new value based on the new width. Okay, so this is how we can get the custom dialog. So diagonal is a val property, and it is returning of type int, or its type int, and we have get method that will do these mathematical calculations and return a value for this diagonal and store it inside the diagonal. So I can access this diagonal by directly calling the dot notation dot diagonal. Okay, print diagonal. Let me see the diagonal. It is around 76. Okay, and here we go. This is the 76. Okay, this is how we can access and create a custom getter inside Kotlin. In the previous lesson, we have learned about custom getters. In this video, we are going to talk about the custom setters. So, the property you wrote in the previous lesson is called read-only property. It has a block of code to compute the value of the property. Okay, block of code that compute a value of property. The custom getter. This is the custom getter. It's also possible to create a read-write property. Okay, so this is read-only property. This will be write or read-write property. It's also possible to create read-write property with two blocks of code, a custom getter and a custom setter. This setter works differently than that you might expect. A property that has no place to store a value, the setter usually set one or more related other property indirectly. So, how to do that? First of all, we have the diagonal here. We have the custom get that we have done in the previous video. And we start here by, for the custom setters, here, custom getter, and here, custom setter. Start by set value and val ratio by ratio width equal to 16. Let me say val ratio height equal to 9. Val ratio diagonal equal math dot square root of ratio width or ratio height times ratio height plus ratio width and times ratio width. Okay, now height equal to value dot to double. We are converting it to double. Now times the ratio height over ratio diagonal, ratio height. Okay, the ratio diagonal. And the width equal to height times ratio width over ratio height. Okay, this is very simple how to make a set for the custom setters. Now I change it to var math. Okay, this is very simple. We have changed it to val. Okay, very simple how to create a custom setter. Here's what happened in the code. you've changed the diagonal to var instead of val, since you are giving it a setter to change the value. Okay, so we have Control Z. If I change Control Z, there is an error telling me if I Alt plus Enter, it's telling me to change to var. So if I go up, I have changed the val to var. So why? Because since you are giving it a setter to change the value. Also, you use the same code as before to compute the value of indicator. And for a setter, you usually have to make some kind of assumption. In this case, you provide a reasonable default value for the screen ratio. In this case, 16 times 9. This is a default value. Why we have done this? Because a default value. The formulas to calculate a height and width given a diagonal and a ratio are a bit deep. You could work them out with a bit of time, but you've done the dirty work for you, and but we have done the dirty work for you and provide them here. Okay, the important parts to focus on this formula for the height and width are the value parameter, which value parameter to the custom setter lets you use whatever value you pass in the during the assignment. And since the value is an int, you first convert it double using toDouble. You see, guys, we have converted it from int to double. Okay, once you have done the calculations, you assign the height and the width property of TV object. Okay, now in addition to setting the height and width directly, you can set them indirectly by setting the diagonal property. Let's go here, and without using this, we can set directly TV diagonal, TV I need diagonal equal to 70. I need to calculate the height. So TV dot width and TV dot height. Here I provide the diagonal. I need a TV with 70 inches. And now we discover the width and the height of the TV. It is, let me print them. Print ln. Now let's run and see. Its width will be 61 and 34 is its height. Okay, so you give me the diagonal of the TV and I can give you the width and the height of this TV. This is the custom getters and this is the custom setters that we have learned about them in this. If you have a property that might take some time to calculate, you don't want to slow things down until you actually need the property. Say hello to lazy properties. These could be useful for such things as downloading a user's profile picture or making a series calculations. Look at this example of the class called circle. Kotlin, I will create a new Kotlin class called circle. Then go up the class, and I will start by getting the radius. So var radius double equal to 0.0. I will initialize it as the default values. Now pi here is double, and I would use a new keywords by lazy. Okay, so don't worry, we are going to clarify everything. So I will get the circumference of the square, but till now I will create a val pi, and by lazy I will calculate this by lazy like 4.0 times math dot atan 1.0 slash 5.0 minus math dot atan 1.0 over 2.39.0 times 4.0. Okay, now val circumference double get equal to pi times radius times 2. I'm getting the circumference by calculating the pi. I am creating and calculating the pi, not using it 3.14 directly. I'm calculating the pi. Every time I need to get the circumference, I need to calculate pi. It is not directly using it like 3.14. I'm going to calculate it here, double by lazy, and making this calculation, and it takes some time to get here the returning value times radius, that it is the passed by the parameter, and times 2. Here you are not trusting the value of pi available to you from the standard library like 3.1416. You want to calculate it by yourself. You can create a new circle instance in the Kotlin course here by creating circle val circle or circle equal to circle, and I passed the radius. It is about 5.0. Okay, got a circle. Pi is not be run. The calculation of pi waits potentially to see, waits patiently until you need it. Only when you ask for the circumference property is pi calculated and assigned a value. So without using the circle and without passing this parameter and without creating a new instance of the circle, pi would not be calculated. It is awaiting your orders. Okay. Now, if I print circle dot circumference, it will give me here. Let me run and see. It will give me 31.41, and it is working fine. But since you've got eagle eyes, you've noticed that the delegated property pi uses by lazy, okay, pattern to calculate its value. The trailing parentheses are the lambdas. These are the lambdas, okay? So again, we have seen lambdas here. The trailing parentheses are the lambda that initializes the value of pi. But since pi is marked as by lazy, this calculation is postponed until the first time you access the property. For comparison, circumference is not delegated property and therefore is calculated every time it is accessed. You expect the circumference value to change if the radius changes .pi, as a lazy property is only calculated the first time. That's great because you want to calculate the same thing over and over again when you first initialize the circle instance, like here. The pi property effectively has no value. True. When some part of your code requests the property of pi, its value will be calculated. The value will be only changes once, so you can use the val on the property. Okay, this is the lazy property. Okay, so it is useful when dealing with non-synchronous or once you have things that you need to be calculated or done, and they are heavy, and you are not making and slowing down your program for doing that. So use lazy to do the calculations and to be fasting your program and making its complexity. Hello, my friends. Welcome again to the complete Kotlin course. We have learned about the classes, methods, properties, and much more concepts. But classes concepts include inheritance, overriding, polymorphism, and composition, which makes them suited for this purpose. These extra features require special consideration for construction, class hierarchies, and understanding the class lifecycle in memory. This chapter will introduce you to the finer points of classes in Kotlin and help you understand how you create more complex classes. Introducing inheritance. As an overview, we can make a class that allow other classes to inherit properties and method from it. How does this means, or how this works in Kotlin? Okay, I will create a class, a general class, and allow other classes to inherit from it. So, for example, we have done this in the previous lessons. I will create a grade class. This class would be making as data class grade and having val letter char val points as double and val credits double. Okay, we have created this in the previous lessons. Okay, I will show you in this example the importance of inheritance and how to convert these hierarchies into inheritance hierarchy. Person, I have created a new class called person and having var first name of type string and var last name type string and function. It will call the function full name, or making a function full name equal to calling inside it having a function that will concatenate the first name with the last name. Sorry. Okay, this is the class person. Now, I will create a new class, Kotlin class called student. This student will have var first name of type string, var last name type string. Okay, and having a var, or making it as global grades mutable list of grades. I'm making a grades a collection, mutable list of the grade, and it is of mutable list of, I will pass grade. Okay. Now this function record grade of grade. Now grades dot add grade. Okay, this function will record the grade inside the mutable list. So every time you pass a new grade for the student, it will be recorded inside the mutable list called grades. Okay, and this is the person, and this is the grade class. Now, it's not difficult to see that there is an incredible amount of redundancy between the person and the student. Think about it. There is a first name here. If I put them here like this, if I put here also the student and the person. Student has a first name and the last name, and the person has last name and first name. Every time I need to create a person, I need to pass his first name and last name. And every time I need to create a student, I need to pass first name and last name. Okay? Maybe you have noticed that the student is a person. Yes, student is a person. So this simple case demonstrates the idea behind class inheritance. No need if student is a person, so no need to allow the student to define the first name and the last name every time I create a student, because he is a person. So student is a person. So this is a relationship. Will clarify the basics of the inheritance. The simple case demonstration the idea behind, or demonstrate the idea behind class inheritance. Much like in the real world, where you can think of a student as a person, you can represent the same relationship in code by replacing the original person and student class implementation as this. So since I have the student is a person, I can remove this redundancy code. So no need to write every time these codes. I can make a person. I put open here. So the keyword open class person, having the first name and the last name, and this concatenation function. Okay, and inside student, class student, first name directly without var, without clarifying, without creating var every time. I put first name here, the same as last name also here, and I will keep the var for the grades, because these would be inherited from his father, his superclass person. So the class that allow other classes to inherit from it is called superclasses, and the inheriting classes are called the subclasses. Okay, so how to allow the inheritance to take place? Open, we make the father of all the classes, the superclass we will make open, and student, inside the student, the subclass of the person would be like this. We remove every var that we have created for the common properties, like first name and last name here, and we keep on the variables that they are not inherited from the superclass, and then we put here 2 points. It is inheriting from person the first name and the last name. So in this way, we are telling that the student is a class having three parameters. Two of them are inherited from its father, its superclass person, which are the first name and the last name. So we have removed here the var and nomenclature. Okay, it's very simple, guys. Now the function here, I need to put it as an open because we are adding it to a class student that allows the person to use it later on. In this modified example, the person class now includes the open keyword, and the student class now inherits from the student by making this person and inheriting from it the first name and the last name. Okay, you must still add through inheritance. Student automatically get the properties and methods declared in person class. In the code, it would be accurate to say that the student is a person. So a student is a person. Person is a superclass and the student is the subclass. With much less duplication of code, you can now create student objects that have all the properties and method of a person. Now let's see how to make this person and student. So val, I will make it as JSON equal to person. It's a new person having a first name as JSON. This last name is statum. Val, another student like Jennifer equal to person. Jennifer the last name Lopez. In order to get the full name function, because it is a person and I can get the full name, so JSON dot full name, I will print it here. Okay, it's normal class because I'm making use of this. I am just concatenating the two first name and the last name. But if I make use of the student object, how to make this? I will make val new grade history equal to grade having letter A on history, points is 19/20, and the credits is equal to 3 credits. Okay, 3.0 points 19.0. I will add for JSON the JSON I can't access only the first name and the last name. Okay, I can't add grade to the history because the person is the father and he don't have any methods except the full name. Okay, I need to make use of record grade inside the student. So Jennifer, I will transform it into a student and everything will work fine because the student here, the student will took the first name and the last name, and the var grades would be a null till now. Okay, JSON will not able to record the grades, while Jennifer, if I put Jennifer dot, I press Control and space, grades, last name, record grade, you see guys, and the full name. So we have a record grade function in student. Yes, it is here. But if we look closer, Control and space, we have full name function. So full name function, full name is coming from the person class that the student inherits from it. This is the importance of inheritance, because you don't need to write for every student, for every employee, for every teacher, for anything who inherits from or he is a person. We are not going to write a function that in every time for the student tell him that to get a full name. So that this is the redundancy of code. We don't need to rewrite everything and copy and paste the code. We need to make a clean architecture, having a inheritance, having a class, a super class that allow the subclasses to inherit from it, the sharing of the functions, the most commonly used functions, the common function, and the properties between these subclasses. Okay, so the student here does not have a full name function. It contains a record grade only. So grade history, I can add it to Jennifer, because Jennifer is a student and is a person, by the way. So full name, Jennifer full name, I can get it, but I need to use record grade, and I will add the grade of history. Okay. Now Jennifer is a student, but I can't make this for Jason because Jason is a person. Person does not inherit from student. Student inherits from the person. A class that inherits from another class is known as subclass or derived class, and the class from which it inherits is known as superclass or base class. Okay? Kotlin class can inherit from only one other class, a concept known as a single inheritance. Also in Java is a single inheritance, while in C++ it is multiple. The student-person relationship demonstrates a computer science concept known as polymorphism. We said that a student is a person. Okay? So, in brief, polymorphism is a programming language's ability to treat an object differently based on context. So, how does this mean? Or what does this mean? Student is a person. Okay? I can treat a person as a person, but I can treat a student not a student. Also, I can treat a student as a person. What does this mean? How to do that? We said that Jason is a person. Okay? If we look on the properties that Jason accepts and the methods that have acquired, have last name, first name, and full name. Okay? These are for the superclass. But if we put Jennifer is a student. If we go to the student, we have first name and last. We have grades and we have record grade. We have this function record grade only. If we go back, we see that Jennifer is a student, and we press Control and space. We have grades, first name and last name, record grade, and full name. So full name function is not found inside the student class, but it is inherited from the full name. So we can treat Jennifer, because it is a student, we can treat it as a person. So I can write here full name. Treating it as a person means we can use the properties and the function of a student a person inside a student. Okay, so if I print here, print ln, we run it, we see Jennifer Lopez. Okay, so we have used the full name function that it is not written inside the student, but because the student inherits from the person and the person is a superclass of the student, we can get the full name function to be inherited and called and be applied for the data that it is for the student. Okay, so we are treating now a student as a person. Subclasses receive all properties and methods defined in their superclass, plus any additional properties and methods the subclass defines for itself. We have seen that a person is a superclass having a full name and properties first name and last name, and the class student inherits from the person. So additional to full name and the first name and last name properties that inherit from the person, student defines a new mutable list grades and a new function record grade. In that sense, subclasses are additive. For example, if you've already seen that the student class can add additional properties and methods for handling the student grades. These properties and methods would not be available to any person class instances, but they would be available to student subclasses. Okay, so besides creating their own methods, subclasses can override the methods defined in their superclass. So if I need to get this use this method inside the student class, we create a new student, Jennifer, and uses the full name. But we can override this method. Assume that we need to add the maiden name for the full name function. Okay, I need the first name, the last name, and I need to add like hello. I need to say hello for my name is first name. So if I need to modify in the student class the full name to say like the student name is like this, but I can't put here in the person because the person will apply for all subclasses. So I need to override this method inside the student class. So I write here the override keyword function and called record, or this is the full name, and it took the first name and the last name. Okay, super, I will use the super keyword. I will modify it later on. Super plus super dot. So the super keyword will refer for the function that it is inside the super class. I need to call the same function as full name. Okay, full name. I have modified open function because if I remove this, it will give me an error telling me that it is alt. If I press alt plus enter, change return type to string, I am getting a string, and override alt plus enter, make first person.fullname open. If we go there, we see that open here. If the function is not open, I can't override it. Okay, so here I need to make a return plus hello student. Okay, this is the function overriding. Now let's run and see the same thing. JSON will printing the full name because JSON is person. It will ordinarily print his first name and the last name. While in a student, because Jennifer is a student, it will print something different. Let's run and see and discuss what we have. JSON status is a person. Okay, while and we have its first name and the last name. While Jennifer Lopez is a student, so we have added directly to this custom hello student message. So this is the method overriding. We have added to the function that we have inherited from the superclass person a constant string hello student with these dots. Okay, this is the method overriding. In certain situations, you may want to prevent class from being instantiated, but still be able to be inherited from. This will let you define properties and behavior common to all subclasses. You can only create instances of the subclass classes and not the base parent class. So you can make an instance of subclasses but not making an instance of a superclass. Such parent classes are called abstract classes. Classes declared with abstract keyword are open by default and can be inherited from. In abstract classes, you can also declare abstract methods marked with abstract that have no body. The abstract method must be overridden in the subclasses. This is the beautiful thing in inheritance and abstraction in Kotlin and Java. Now, abstract class. How to define an abstract class? I remove this person, grades, these codes. You can download the source codes from the Udemy course resources folder. Abstract class. I will create a new Kotlin core class here. I will name it as mammal, and this mammal class would be abstract. I can't create an object or an instance of the class as a mammal because because there is maybe a bird, anything that having 4 legs, 2 legs, but they will making inheriting from the mammal. Okay, so I can't create an animal directly, an instance directly as a mammal because it is an abstract class, and the logic will tell me that I can't make or I can't find in the nature something called mammal. I can find an animal that belongs to the class mammal. Okay, so I will make birth date string. I will define also a method called abstract function consume food. Okay, this is an abstract function that should be defined and overridden inside all of subclasses of the mammal. So everyone having a superclass as a mammal, I should define the function and override the function consume food and see how to override it later on. So I can create now a new Kotlin class called human, and human, by the way, is mammal. So mammal here is or human here, it will take birth date from directly. As I told you in inheritance, when I need to get the properties, I should declare them here without making var or val, and I will define that this class is inheriting from mammal. So we have seen this in the previous video, and I am getting the birth date from the mammal here. Till now, we have everything working fine, but there is a new error. We have seen this and we have done this in the previous videos about inheritance and polymorphism. But what this error means, if I click in this red bulb, implement members or make human abstract, implement members, and I see here that I should implement members, and this members is a function, consume food. Let's put a click OK. And here we go. It have been making and overriding a function called consume food. I will remove this and I can make here override function consume food. This function will print consuming 1000 calories. Okay, per day for the humans. Okay, if I create new Kotlin class, I will name it as like birds. It is not mammal. Okay, so I will remove it. I will create a new Kotlin class like cats. This cat will take birth date as a string from its superclass, and it's extending mammal passing birth date, and this error is the same because I have to implement and override the function. Alt plus enter, implement members, consume food, and click OK. I will remove this and I will print here consuming 400 calories per day. Okay, so human and cats are mammals. Okay, extending from the abstract class mammal, and they should override the function called consume food. Okay, now let's go and to the core Kotlin course class. It is where the main function included. Abstract, I will create val human equal to human, and I will give the birth date 10th of June 2000, and I will create a cat object equal cats. I will give the birth date of it 5/05 2020. Okay, these are the classes that are inheriting from the mammal. But there is one thing that I should remember you, that I can't make a val mammal equal equal to mammal, and I can't pass like this, like 0409 2000. There is an error because here cannot create an instance of an abstract class. This is the error. I can't create a mammal instance of the mammal class. Okay, this is the importance of using the abstract classes. You can create an instance of mammal subclasses, human and cats, but not the mammal class itself. Abstract classes are closely related to interfaces that we are going to see in the next. Sealed classes are useful when you want to make sure that the values of a given type can only come from a particular limited set of subtypes. They allow you to define a strict hierarchy of types. The sealed classes themselves are abstract and cannot be instantiated. Sealed classes act very much like enum classes that we are going to introduce later on, which but also allow subtypes which can have multiple instances and have state. Consider a sealed class called shape here. Create a new Kotlin class called shape. And this class here, I will name it as sealed, and giving it as a keyword as sealed. And the sealed class shape, it has a class circle having val radius int and inheriting from shape, and another class called square val side length int shape. Okay, val here. Okay, you have used the keyword sealed to mark shape as a sealed class. Both circles and squares are shapes, but a circle has a radius and a square has a side length. Unlike enum classes, you can create multiple instances of each type within a sealed class. Let's go to the Kotlin course.kt. This is the class that we are going to test, and we have tested all the codes that we have created. So I will create val circle1 equal to shape dot circle. So I'm like making a nested classes. I'm making class and then a shape for a limited number of classes. So shape will contain a circle or square. So you can't make a shape only if it is a circle or a square. Circle of radius 4. And I will create another val square 2 equal to shape dot square and having a radius or side length equal to 2. Okay, and functions defined on shape can distinguish between the different subtyping using the when expression. Okay, so if I need to make a function here and use this sealed classes, function size shape, and the returning type of it is int, return when shape. If it is a circle, is shape dot circle return shape dot radius, get radius. Then is shape dot square return shape dot side length. Okay, now sir, if I need to test this, circle one dot size. I can put this inside here, function size, and I will put here 2. Okay, sorry, the shape circle. It will return for me a circle because I have passed a circle, and it will consider if it is a shape circle, it will calculate the shape dot radius. Okay, so the size here may have 2 possibilities, either a radius or a side length. If the shape pass is a circle, it will know directly that it is a radius. If the shape is passed a square, it will be known as a side directly. While the open keyword determines what you can and cannot override in class hierarchies, visibility modifiers determine what can and cannot be seen both inside and outside of classes. The 4 visibility modifiers available in Kotlin are: first one is public, visible from everywhere within subclasses, other files, and other project models. If no visibility modifier is specified, it is default to public. So this is the default modifier. If you don't put any modifier, it will be a public. The second one is private, visible only with the same class for classes, and only within the same file for top-level functions and other non-class definitions. So private, we will see them in the example. 3, protected, visible only within subclasses for class hierarchies, and for internal, visible only within the same model, for example an IntelliJ model. Okay, so generally you want to limit the visibility or scope of your classes and variables as much as possible. This will keep the responsibility of your classes clear and prevent you from changing the state of class when you really shouldn't be. Okay, now let me create a new Kotlin class here, and it is called privilege. And this class is of type data class. It will take in its default primary constructor val id of type int and val name that string. Okay, this is the class of privilege. Okay, I will create another class here, but let me first remove the use from the previous exercises. I will create a new Kotlin class named user. And this class user, it is an open class. It will take val username of type string, private val id of type string, and protected var age of type int. Okay. This is very simple. Just creating the classes. Now, I will create another class and define the function and see the relation of the access modifiers or access, the scopes, the visibility modifiers that we have talked about there. This class now will be named as privileged user, and it would take username as string, and it will be extending the user. Okay, so this is the subclass of the username of the user class, id of string, age of int. It will be extending the user class having username, id, and age. Okay. Now I will define the functions here to see how the functions and how it will work. If I create add privilege function, take privilege object as parameter. I need to create privileges here. It's of private. You see, guys, this is the first modifier, private val privileges equal to mutable list of, and we will see of type privilege. Okay, and I will add, when you call the function add privilege, it will take the past parameter and add it to the list that we have created here. Remember, the aim of this exercise to understand the modifiers and how they work. Okay, so the privileges here is a list defined as private. We will see how to access this. Add privilege from here. Okay, again I will create a function has privilege int, it will return Boolean, return privilege dot map it dot id. I'm getting map dot id dot contains id, checking the map, and function about taking turning and string. This string will return username and age. Okay, look guys, if we see the ID, ID is private, because if we go up user, if we see that private here is the ID and the protected is the age, I can use here, because privileged user is subclass of superclass user, or a privileged user is a user, and privileged user class inherits from user. But there is one thing that you should pay attention. In the superclass, the ID property is marked private. Okay, so you can only be referenced inside the user class. This private will give you an access inside this class, but not inside the subclasses. Okay, while protected, the age protected property, or the age property is protected, so the subclass privileged user can see it. You see guys, we can access it. If I put ID here, it will give me an error, because cannot access ID. It is invisible, private in super type, in privileged user. You can make ID public. Okay, I can make ID public so I can access it. Okay, the error has been gone. If we go to the user, we see that the private is disappeared. If I add private, the error will be found. So if I put the age, it will be good. If I put username, it will be good, because here there is a public keyword. Okay, so this is how we access how we use the modifiers. Okay, if I go to the main and try to test this code, val privileged user equal to privileged user having username like Jack, ID and age 30. Okay, if I create also val privilege equal privilege 1 in like no access, privileged user dot add privilege. I'm just adding them. Okay, and now if I try to print the privileged user dot about let's run and see. It will give me the name and the age and not the ID. You see guys, this is the importance of making and understanding the modifiers, because if we go back to the about function, it will give me the user and the age. But if I replace it, as I told you with the previous exercises, ID will be not accessible, because in the superclass ID is defined as private. So private is only for the class itself, protected for the class and its sibling, its subclasses. Public is for all. This is the modifier. You have learned about two Kotlin custom types, classes and objects. There are another custom type that's quite full. It's called interfaces. Unlike the other custom types, interfaces aren't anything you instantiate directly. Instead, you define a blueprint of behavior that concrete types conform to. With an interface, you define a common set of properties and behaviors that concrete types go to implement. Okay? The primary difference between interfaces and other custom types is that the interface themselves cannot contain state. They are containing behaviors, only methods, only functions. In this lesson, we will learn about the interfaces and how they are used inside Kotlin. So, you define an interface much as you do any other custom type by going here to the source, create Kotlin class, and we see here that this green one with I is called interface. I will make an interface called vehicle, and this vehicle, this is the keyword interface, okay? And in this vehicle interface, remember, there is a keyword interface followed by the name of the interface, followed by curly braces with the members of the interface inside. The big difference you will notice that the interface does not have to contain any implementation. We cannot implement anything here. We cannot define a val here, or we cannot write a function, a complete function here like accelerate that, and we put a body of the function. It is not allowed. So why we use it? I will tell you. Every vehicle in the world will have two things like accelerate and stop. So when you have a very big common between things like vehicles, like airplane, cars, boats, and whatever you want, there are common functions between these objects, which are accelerate and stop, and you need to mandatorily implement them. So we see in the abstract classes, when you define an abstract function, all the subclasses of the abstract class will be mandatory implementing them. But here, interface, any class implement the vehicle interface, it should implement all of its methods. Okay? That means this would not be instantiated. This means that you cannot instantiate a vehicle class directly. So if we go to the main, I can't write here vehicle of type vehicle. I can't, because interface, if we see on the error, look, interface error, interface vehicle does not have constructors, and interface is not having constructors and cannot be instantiated. Instead, you use interfaces to enforce methods and the properties, these methods, on the other types. What you have defined here is something like the idea of vehicle. It's sometimes that can accelerate and stops. Okay? Now, Let's go deep and learn about the interface syntax. An interface can be implemented by a class or object. And when another type implements an interface, it requires to define the methods and properties defined in the interface. See, guys, remember these two methods, accelerate and stops. Okay, so I will create a class here, a new class, concrete class. I will name it as bicycle. Okay, this bicycle is a vehicle. So how to implement the interfaces? It's just putting 2 points vehicle. Okay, it's very simple. There is an error here appearing. Class bicycle is not abstract and does not implement abstract member. Public accelerate. Implement the members. These are the members that I should implement. Accelerate and stop. We need to put OK, click OK. So we have implemented these two functions, accelerate and stop. I told you to save this naming because everything extends or implements, using implement for interfaces and extends for the classes. Okay, this is the inheritance. Any class that implement vehicle interface should include inside its body the accelerate and the stop method. If I define the third method here, it will enforces this class to implement the other functions. Okay, this is very important point. Now let's say here speed var speed equal to 0. When you accelerate, speed would be equal to 8 kilometers per hour per hour square. Speed equal to 0. Okay, just two functions adjusting the speed of the bicycle. Okay, this is very important. Now there is something interesting in interfaces. Since stop in all vehicles will make it like 0, but the accelerate, it may differ between the vehicles and the vehicles itself. So the acceleration of a plane will be different from the bicycle. So, but the stop of the plane is the same as the stop of the bicycle in terms of the final results. I can define here default method implementation. How this works? I can put here for the stop like a print, like a slow down to 0. So if I go back here, and then I Alt plus enter, implement members, accelerate. Okay, I have implemented the accelerate only. Okay, where does stop have left? You have defined an implementation for stop inside the interface, but left accelerate undefined. Any types implementing vehicle, such as bicycle, must include an implementation of accelerate. When an interface defines a default implementation, this is the default implementation, you can still override the implementation in the type that conforms to the interface. I can now override. Okay, so override function stop. Okay, you see guys, this is the function override we are making as this, and we are making use of the stop. And here the bicycle both overrides both of the functions, the accelerate and the stop. And it also uses super in the stop to call the default implementation. As we have seen in the super keyword, it will do the same as its super class or implementation. Bicycle will do this the same now in the stop as its implementation. It's just print down the slowdown to 0 speed. In order to add things and allow it to be more reliable, speed equal to 0, and accelerate speed is equal to 8. Okay, always do add the codes after the super. You are not allowed to add here like speed equal to 0. It will give you an error. Okay, just put everything after the super stop. Okay, in programming, centralizing your code is one of the biggest ways to save yourself from headaches and prevent bugs. That way, when you are executing the same thing in multiple places, there is only one place where those executions are actually happening, and the only one place where they could possibly break. A really helpful feature of Kotlin for this is called generics. The general concept of generic programming is that you don't necessarily need to know exactly what type an object is, or an object associated with primary object you are working with, in order to perform actions with or around it. This allows you to combine and simplify functionality in real powerful ways. Okay? So, anatomy of standard library generics type. When getting started with generics, it helps to look at the major generic types that are included in Kotlin's standard library. This way, you can see how the language itself uses this functionality and get some ideas about how you might be able to use itself. Let's take an example of the list. If we go here, if I type var list equal to list, if I click on Control and hover the mouse on it and click the left click, I can go to the source code that the list is writing this. Okay, so this is inside the collection. I scroll down to the list of, see this method that we have used them, list of, and mutable list of, and arrays, mutable list of, and we see that there is this diamond nomenclature, or this typing, like T is the type, and these angle brackets, they are surrounding T, and here is again the T, and here is the again T. So what this means, okay? Take this part a bit. This is declaration. If we go scroll up, if we are looking for the list itself, okay, so let me check for a list of. Okay, this is the function list of. Okay, we are going to work with it. So if we go, this is the declaration of all collections in the library, and this is the class that we are going to test the code and learn about it. Look, guys, if I'm going to make var list, I need to specify if I want to the type of this string and list of, and I put here like element 1, element 2, element 3, and so on. Okay, so look, guys, if we took a closer look here, if we call the function list of, there is before public function list of, there is between them this angle bracket with the t. Okay, Kotlin collection list of and returning, and the type of it is t. This is the symbol or the syntax that are telling us that the list of is accepting, it is a generic function. If we go through here, list of string, we go up, and the returning type of this would be a list of t. So t represent anything, any object, any type of collection, any type of objects that can be used in the collection of list. So this, if we hover here, the string class represent character, telling us in the character, and we are telling that this would be replacing the t here. So t now is a string. This function now deals with the t as a string in the case of our list. We will continue with the code. List of, we are getting list of and elements t. And I told you that since the t is now declared as a string, so these are being accepted because the function t, a function list of, accepts all the elements of this t. T represents string, so list of now is string in the case of the list. The first t indicates that this is going to be a function that does not or does something with generic type. Okay, and the second t indicates that the list you are calling this function on must be a list containing only objects of the same of that generic type. Okay, this is the list, and this is the t that we have talked about. Okay, the third t, that the returning value, this is the t, the second t, and the third t return value of both the same type t, which is string here. Okay, this is generics. It may be confusing. Don't worry. On the exercises, we are going to see how it works and how to be clear. You are wondering why we are going to use generics and what are the importance of generics. Let me try to make this list, and you'll see why the importance of the generics. And we will start by the list, and we'll take examples about the map and the sets later on. But till now, I will make a mutable list of, and I put 1 and 2. Okay. Kotlin now understand that this is a mutable list of integers. If I try to add list.add Jack here, okay, print the list or print list. Let's run and see. It does not allow you because there is an error, and this is not on runtime error, it is on compiling error, on compile time error. When typing, there is an error. This is telling us Kotlin type mismatch, inferred type is string, but int was expected. So you are passing an int a string, but there is accepting a integer. So if I put integer here, it will work fine. But if I put a string, it will make an error. Okay. Since Kotlin's type inference system only sees the two int objects passed into mutable list of, it assumes that the generic type of the mutable list being created is int. Okay. As we have seen in the previous video, when we talk about the list and the mutable list and the list of, we have seen that it is a passing and uses generics in form. This is the t. So when you're passing 1 and 2, t is now an integer. So the list will make sure that only accepts t equal to integer. And here, when we pass a string, it refuses to add this. Okay? This is great if you want to prevent someone from accidentally adding an object of the wrong type to your list. This is called type safety. So the generics, the main purpose of generics is making the type safe. So you are preventing anyone from entering the age, from entering the age or entering the anything that you are only accepting integers, only accepting the strings, or only accepting specific objects to the list or any collection. Okay, so if you want to be able to add an object of any type to the mutable list, it's very simple. Where there is a type that we have talked about it called any. So if I create here val list, a mutable list, I will make a mutable list here. Mutable list. You see the e here, it's telling me that I need the e, which is the element. I put the keyword any. So any in Kotlin allows you to add anything for this mutable list. 1, 2 is integer. Okay. And now there is a confusion because when we create a mutable list, I passed any. Now any will override the integer, will like pass the integer. Yes, the root of the Kotlin class hierarchy, every Kotlin class, let me show you, any has an any as a superclass. Okay, every Kotlin class has any as a superclass. As object class inside Java is the main object. It is a superclass of all the classes you create. And the same way, any is the father of all data types in Kotlin. So 1, 2 are integers, okay? But this will not define the mutable list as an integer. So the t here, or the generics, is passed as any. It accepts all type of data. So if we go here, we see that Jack now can be passed as a string to this integer list. Let me run and see. And here we go, guys. 1, 2, and Jack. So we are accepting integers and we are accepting strings. Okay, this is how we use any with mutable lists and how to pass the type safety of generics. And why we use generics? Because of its type safety, and it's very important, guys, when making big programs. You are mandatory, and you should add this type safety, because people or users may encounter accidentally errors or bugs in your system.